Hi all, how are you all?
Hi everyone, how are you doing? So now the exam is over finally, and there are many students. I think those who have joined. Okay. So how was the exam? So we will tell our analysis, but before that, would you like to tell how was the exam? Okay. Someone was saying tough paper, not that good, बहुत difficult था. Okay. Moderate. Guru CSE saying moderate. So how was the difficulty level according to you? AIMT जैसा. Okay, someone is saying very easy. I think 100 by 100 might come this year also. Yeah, maybe possible. Maybe possible because the questions were not unconventional. Like what we felt that questions were conventional. I mean, there like we can talk about the difficulty level, but the questions were very much PYQ type. I mean, there was no new type of questions which were unseen question. So and also they have not asked in TOC for example they have not asked other than regular language and NFA DFA. So they have not asked anything from PDA, not from context sensitive, neither undecidable or these things. And similarly in many other subjects also they have just touched. I think in 2 3 subjects also they have just touched one or two topic, and from there they have asked many questions. For example, in DBMS they have asked mostly questions from dependency and relational database and all, and also like I think DBMS, yes, they have asked from this, and also from algorithms also they have not asked. Yeah, I think algorithm was good because they have asked MST question, they have asked trespass question, so algorithm was good. And what other subject? Yes, from compiler design, Deepak, how was the compiler design this time? I think it was
Com-
moderate,
Compiler
right?
design
Compiler
was
design.
also moderate. It was not tough. There was a question from available
Yes.
expression analysis. Basically, there was a question in which the question was asking about common sub expression in basic block B1, B4, B5. And that question, let me tell all the students that in Go classes, we have taught available expression analysis. All the Go classes students, let me know, were you able to solve that question? Available expression analysis, we have already studied. For a basic block, how do we find what are the in available expression analysis, what are the out available expression analysis, basically. So that question was there, and of course we are going to discuss all the questions. We will provide you memory based questions, their answers, the difficulty level, the complete analysis we will provide you for this gate CS 2026 set 1. Okay, so
Yes.
let's start this session now. We will discuss all the things, we will discuss one by one. Okay, we will go one by one. So first, Sachin, we can discuss
Yes.
one by one. We are going to discuss. So first, let's discuss the difficulty level, because most of the students are waiting to hear what was the difficulty level. So I and Sachin will share our opinion. Let me tell you that we both attempted set 1, GATE CS 2026 set 1 today. This paper we attempted, and what I felt, let me tell you that it is very much possible that some students, or I can say few students, maybe 5 to 10 students will get more than 95 marks, and maybe there can be some student who can get 100 out of 100. This was that type of paper. This paper
Right.
was very similar to GATE CS 2025 set 1. In GATE 2025, the set 1, in set 1 a student got 100 out of 100. Many students got more than 90 marks. Some students, I can say multiple students, got more than 95 marks in set 1 2025. This paper was also similar to that. In this paper also, this is my opinion that this paper, in this paper also, multiple students will get more than 95 marks, and some student might get, it might be possible that someone can get 100 out of 100. So this is very close to the GATE CS 2025 set 1.
Right.
I
If
think
not 95 plus, then I think 90 plus are definitely possible for I think 4 5 students very easily. So 90 plus would be, very easily possible for 4 5 students. Yes, after normalization, their marks may get decreased, but before normalization, we do not want to predict anything about the set two. Let's just see what happens in set two. So
Just
yeah,
one
but
second,
this was very similar to last year's set one.
Sachin. Is audio,
Uh.
video, volume, echo, is everything fine? I think Sachin, your audio or video, I think that was fluctuating. Let me know before we
Okay.
discuss the
So
memory
is
based questions and answers. थोड़ा शायद ऑडियो वीडियो में शायद कुछ ग्लिच आ रहा है सचिन.
actually, I think there is a lack of connectivity from your side because I'm getting some break of
Can
voice.
anyone tell me? I and Sachin, like, या सचिन, चैट में भी किसी ने लिखा है कि सचिन सर का ऑडियो जो है वो थोड़ा जिटर हो रहा है,
Okay. Okay.
थोड़ा
Let
ग्लिच हो रहा
me check.
है. Okay, so this was about the difficulty level. I think, see, depending on your level of preparation, you may not agree with us, but we are talking about the overall, I can say, students. Okay, not about a specific student. We are talking about the overall set of students who will attempt this set one. I think you can call it lengthy comparing to the set one of 2025. Maybe it was little bit lengthier. Okay, this I agree that comparing to gate CS 2025 set 1, this set 1 of gate 2026, this was comparatively lengthier. Okay, but it was very similar to that. In the difficulty level, it was very similar to that. Okay.
Yes. So, but actually, Deepak, I think compared to last year's set one, it might be little tough. What I feel might be little tough because there
because of
were
because of maybe
few
lengthier,
questions.
as I said,
Yes.
like
Yes.
it was. Okay, what you are saying, Sachin?
Yeah, so I was saying there were few questions definitely which were not easy, like which were tough. For example, like TOC question, that number of age, number of V's, that foo bar question, and there were many other questions which were really good questions. So probably because in last year's set one, like only I think 2 3 questions might be good, but this year there might be 5 6 questions which were good.
Okay,
That
so I
algorithm
think
question also good.
other than those 5 6 questions, I think the remaining questions were quite, I can say, doable and quite straightforward type
Right,
question,
right.
PYQ based questions. Okay, let's also discuss the overall distribution. So the distribution was very bad this time. Let me tell you,
Yes.
subject by subject, let me tell you. In DBMS, there were 3 questions only from relational database, from super key, from decomposition, BCNF, 3NF, and there was another question from functional dependency. So you can see 3 questions only from the normalization and relational database. 3 questions. There was no question from transaction management, no question from ER model, no question from SQL, no question from indexing. Seriously, this was the most, I can say, disbalanced, or I can say it was fully like the gate question maker was thinking that in the DBMS we only have relational model. There was only one question from TRC and relational algebra. There was a single question in which TRC query was given and relational algebra equivalent query was, this question was asking, and the remaining questions, they were from relational model, super key, normalization, functional dependency. So you can see transaction management, scheduling, all these things like indexing, B tree, B plus tree, SQL, ER model. These 4 topics, Sachin, these 4 modules, they were untouched. Not a single question from these
Right.
modules. Okay, so you can see this was about DBMS. Let me also tell you about discrete mathematics. There were 2 questions from graph theory. There was one question from combinatorics. Other than that, there was no question from propositional logic, no question from first order logic, no question from set theory, no question from functions, relations, group theory. There was literally no question. Discrete mathematics, total 3 questions were there. 2 questions, very good questions from graph theory, and one question from combinatorics. Other than that, there was no other question from discrete mathematics also. So you can see that majority of the topics they did not even touch in DBMS, in also discrete mathematics. So again, disbalanced. In theory of computation also, there was no question from decidability, there was no question from Turing machines, there was no question from PDA. There were questions from finite automata, from grammars, context free grammar, and closure property, and regular grammar, finite automata. Only these, I can say, easy topics they were asking. No PDA, no decidability, no this type of question. Okay, so you can see the theory of computation was also very disbalanced. And other than that, I think, Sachin, in operating system,
Yes, in operating systems, scheduling question was there, and memory management, that one TLB hit, then that question was there. So, uh, other than that, do you remember operating system?
in operating system, I think there was no question from paging, from multi-level paging. I think
Yes,
there was no question. And
there was a
from
four question was there,
fork,
and
yes,
scheduling question was there, and that TLB hit question was there. I think only three questions.
one deadlock question, banker's algorithm
Banker's
question was
algorithm
there.
questions was there. Yeah.
Okay. Okay, so these questions were there. You can see in operating system also there was no question from synchronization. You can see
Yes.
synchronization, paging. From these two topics, there was no question. Yes, there was a question based on page fault. I can say TLB, page fault, cache memory. There was this type of question was there. Yes, okay, that we will discuss. There was a question from deadlock. Okay, but there was no question from synchronization. And in computer organization and architecture, there was a question from addressing mode, there was a question from cache memory, one very good question from pipeline also, and there was a question from hard drive, hard disk. Okay, so we will discuss all these questions. Now I think, Sachin, overall we can say, at this moment we can say that the paper was disbalanced. Basically the distribution among the topics, that was
Yes.
very, I can say, very much
Skewed.
non-uniform,
Right.
very much non-uniform. So I think that is one thing. The questions were traditional. In set 1, gate CS 2026, the questions were traditional. There was not a single question which we did not cover in the Go classes. There was not a single question which was off topic. You can see last year in gate CS 2025, last year, there was a question from backpatching. There was a question from booth algorithm. This type of questions were there which you can call off topic. But this year, there was no question off topic. In algorithm, there were two questions from tree traversal, pre-order, post-order.
Hmm.
There were multiple questions from binary search tree, this binary search tree, pre-order, post-order. This type of two, three questions were there. Heap, min heap question was there. So you can see, Sachin, in algorithm, I think there was no question from dynamic programming also.
Right. From sorting, searching, greedy, dynamic, all of those like traditional algorithms, there is no question. But yes,
MST was
graph-based
there
question.
in
Yeah.
greedy. Only MST question was there from greedy.
Yes, yes, yes. So basically, graph-based questions were there. Like shortest path question was there, and MST question was there. And apart from that, BST pre-order traversal and those questions were there.
So overall, this was a very disbalanced paper, and but the questions were traditional. If you have solved all the gate PYQs with good understanding, with clear, complete understanding, with complete analysis, if you have done the gate PYQs, then all the questions were doable. But I can say, Sachin, one question which was not there in the gate PYQ, that was available expression analysis question. Control flow graph
Okay.
is given to you, and the question is asking for the common sub expression in basic block B4 B5. That question we have done. Available expression analysis we have already studied in our Go classes lectures. Okay, if you remember, for basic block how to do, for a single statement how to do, for a control flow graph without loop, with loop, all the variations, everything we have already seen in our lectures. But this question came for the first time. This type of question was not there in the gate PYQs. So I can say this particular question was not present in the gate PYQs. This was a new question, but this was covered in Go classes available expression analysis lectures. Okay, so Anything else other than that before going to the memory based questions and answers, Sachin?
Yes. So now I think we can jump to the discussion.
One more interesting thing I want to tell you, in GATE CS 2026, you you cannot, if you remember, if you noticed, I don't know, in the MSQ question, you cannot click all the four options. Did you notice this? If you try to click the fourth option for any question, for any MSQ question, if you try to click all the four option, it was not permitted. So in the instructions before the GATE exam starts, in the instructions, it was not given, this information was not given, that in MSQ all four options cannot be correct. This type of information was not given. So I was thinking that maybe in MSQ all the four options can also be correct this time. But did you notice, how many of you noticed that in any MSQ question, whatever MSQ question you take, you cannot click all the four options. It will not allow you. If you click three options and then automatically the fourth option you cannot click. Okay, so overall, if you remember, I made a video few days back where I was discussing that in GATE 2024, this instruction was given before exam starts. This instruction was given that in MSQ question, all the four options cannot be correct. This instruction was given before the exam starts. But this time, what they did, they did not give this type of instruction, but they disallowed clicking all the four options in the MSQ question. Okay, so I think the GATE exam, this was a very, I think, poor decision from the GATE exam, Sachin, I think, because if they are thinking that in MSQ all the four options cannot be correct, why don't they write it in the brochure? Why don't they
Hmm.
write it in the instructions?
Instructions.
Like in the brochure, they can write it, right? Okay,
Right.
so in the information brochure, they can write that in MSQ question, one option or two option or three option can be correct. Four option cannot be correct. Like what was this? I can say behavior funny. I will say disappointing, honestly, because if they write it in the instructions, in the brochure, in the information brochure, if they write that all the four options cannot be correct, then in our test series, in our weekly quizzes, there also we will try to make sure that all the four options cannot be correct. So I really did not understand this behavior. Okay, maybe you can raise this issue, okay, on the LinkedIn, of course, on the Twitter. It's not a big issue, of course. Okay, it is a good thing for students, it is a good thing. But they should write it in the information brochure so that student can prepare according to that. Okay, so this was a odd thing. Anyway, I think we have discussed about the paper. Now we can discuss the memory based questions and answers. Anything else, Sachin?
Yes. So we can discuss now.
Okay. So let's start the discussion of questions and answers. We are going to provide you almost all the questions and their answers. We are going to provide you.
Yeah, and also like please be present in the chat and help us with the options and with the question. Okay, so let's start one by one, and please help us with the questions if we forget, and help us with the options also. Okay. So Deepak, let's just start. I have noted down few questions. So I will just tell you the question hint. Like you can tell me the subject. I will tell you the questions of that subject.
So I think let's start with
Discrete
TOC. We
mathematics.
can start, Sachin.
Okay. Okay.
TOC से शुरू करें.
ठीक है ठीक है.
Okay.
So in
एक बार.
yeah, so in TOC there was one question: L1 intersection L2 is regular and L2 is regular.
Just a second. Actually, I am just checking how the audio is coming. Okay, the person who is speaking, his audio is coming. Sorry, video. His video is
Yes,
coming.
yes. Okay.
मल्टी स्पीकर भी कर लिया. आई थिंक ये जो बोलेगा उसका वीडियो आएगा.
हाँ.
ठीक है.
So let me just turn off my video. I will be
नहीं नहीं, कोई
present in
दिक्कत
that.
नहीं है. वो अभी
हाँ वो तो
इसमें.
कोई इशू नहीं है. हाँ.
ठीक है. ओके, सो लेट्स स्टार्ट द थ्योरी ऑफ कंप्यूटेशन क्वेश्चंस डिस्कशन. सो देयर वाज अ क्वेश्चन L1 intersection L2. This type
L2.
of question was there. This was the given information. that L1 intersection L2, this is regular, and this was a given information that L2 is regular. Okay, so this was the given information. This was a MSQ question, and four options were there. The question was asking that what can we say about L1, L2? So one option was that L1 regular, another option was L1 context free, another option was L2 complement context free, and another option was, Sachin, do you remember another option? L1 union L2, I think. Yes.
Yes, union,
L1
union, right.
L1 union L2 was,
Context free or regular?
I think, either regular or context free. Anyway, both options will be wrong. So L1 union L2 was either regular or context free. Okay, so actually whatever option you take here.
Regular. So in options they are saying regular. Oh, in chat they are saying regular. Anyway,
Okay,
yeah.
so okay, regular or CFL, actually this will be false. So this was the question, and let me tell you the answer for this question. So for this particular question, the answer will be that L1 regular, we cannot say. L1 CFL, we cannot say. L2 complement CFL, yes, definitely. And option D, we cannot say. This was MSQ question, but only one option is correct. And the logic is actually very simple. Let me quickly tell you the logic. You can see that it is given that L2 is regular. Maybe L2 is 5. Okay, you can take, maybe you can take L1 equal to A power n, B power n, C power n, where n greater than equal to 1. You can easily see this is a famous language which is not context free and which is CSL. Yes or no? So this is basically non CFL. Okay, this language is non CFL. Yes, this language is CSL. Okay, and you can take L2 equal to 5. Okay, you can see this is regular. Now what will be their intersection? You can easily see that L1 intersection L2, that will be 5, which is regular. Okay, but here you can easily see that L1 is not regular, so this option A is wrong. You can see L1 is not context free, so option B is wrong. You can see L2 complement will be regular. Okay, because L2 is regular, so its complement also will be regular. L2 is regular, so we can say that L2 complement also will be regular, and every regular language is a CFL. Okay, and you can easily see that L1 union L2, what that will be? L1 union L2, that is same as L1 here. Okay, in this situation, so you can see that will be A power n, B power n, C power n. Okay, where n greater than equal to 1. So here you can see that this option D is also wrong. So for this question, for this MSQ question, only option C will be correct. All the other options will be wrong. How many of you did it correct? And do you think this question was easy or hard? Sachin, what do
Yeah,
you
so
think? Easy
I
question,
think
right?
I think if I can understand TOC question, then it was easy question. So I think it was conventional question because these type of questions have already come in
So
gate also,
Sachin, we
and
can
yeah,
we can write this, maybe for some questions we can write this also, that
yeah,
this
difficulty
question
level.
was the difficulty level of this question. What do you think? In the chat, let me know. What do you think? What was the difficulty level of this question? So you know that answer will be
Everyone is saying easy.
yes. I think this question was easy, traditional, PYQ based.
Yes. So there was another question from TOC, NFA to minimal DFA, and six number of states were there in NFA, and they were asking which of the following cannot be possible number of states in DFA.
This was also MSQ question, and two options were correct. Basically, the given data, let me write it here, that you have NFA with 6 states. Okay, and equivalent minimal DFA, equivalent minimal DFA. Okay, this word is very important, minimal. So equivalent minimal DFA cannot have, cannot have how many states? How many states? Okay, cannot have how many states? This was the question. So the options, let me tell you, there was option 1, there was
32,
option 32,
128 and 65.
128, and 65. So for this question, the answer will be option C, comma D. Okay, this is MSQ question. The answer will be option C, comma D, 128 and 65. The logic is very simple, because if you have NFA with 6 states, then then equivalent minimal DFA must have, or I can say will have less than equal to 2 power 6 states. Okay, so the equivalent minimal DFA will have less than equal to 64 states. Okay, so these are possible, but this is never possible. Equivalent minimal DFA can never have 128 states. Equivalent minimal DFA can never have 65 states. Remember one variation, maybe one variation, Sachin, that
Yes.
if they do not give this minimal word, if this minimal word is not given, and let's assume that they just simply say that equivalent DFA. Actually,
Right.
equivalent DFA can have all these.
Um,
All these are possible for equivalent DFA. If they do not give minimal DFA, then remember equivalent DFA can have. I can say equivalent DFA can have these states. Okay. So anyway, don't worry about it. But basically, for this question in the GATE CS 2026 set one, the answer will be option C, comma D. What do you think? This was an easy question, moderate, or hard question?
So tell us the difficulty level. How you feel this question was?
So I think this was a very easy question. I can call it.
Right.
I think, Sachin, very easy question. Again, this is
Yes.
PYQ based question. Okay, so this is quite easy question. So in TOC so far we have seen two questions, both MSQ, and they were easy question.
Yeah, there was one question in TOC regarding like leftmost derivation, rightmost derivation of some strings they were asking.
Yes, yes.
So
Sachin, I remember that. So let me write.
okay.
This question was also MSQ. I think all the TOC questions are MSQ. It seems like. So basically, this
Yeah,
grammar
true.
was
Right,
given.
right.
This given grammar was there. You have a grammar, and this grammar is S goes to ASBS or BS or epsilon. Okay. And the question was asking, there were four options in this question. The first option was that G is ambiguous. This was one of the option, that this grammar is ambiguous. Another option was that this string ABAB has only
One rightmost
one
derivation.
rightmost derivation. There was another option, that is ABB has two distinct derivations, two distinct derivations. And option D, that was that language LG is undecidable. So this question was there, and for this question, let me quickly tell you the answer. Grammar is ambiguous. Yes, this grammar is actually ambiguous. We will see why. Okay, so basically, yes, the grammar is ambiguous. ABAB has only one right mode derivation. That is also correct. ABB has two distinct derivations. That is also correct. Remember, in this question, it is not mentioned that exactly two distinct derivations. The question is saying that ABB has two distinct derivations. Yes, we have two distinct derivations. Actually, more than two distinct derivations are there. For ABB, more than two distinct derivations are there. But the option is asking that ABB has two distinct derivations. Remember, the question is asking here, option C is asking derivation. It is not saying leftmost derivation, rightmost derivation. It is saying derivation. ABB has two distinct derivation. This is actually true. Okay, next, LG is undecidable. Of course, this is a nonsense option, because already this grammar, you can see this grammar, this is already a context free grammar. So the language is CFL, and every CFL language is decidable. Every CFL language is recursive. So very simple question here. You can just let me quickly tell you that this grammar is given as going to AS, BS, or BS or epsilon. Now here you can quickly see that this grammar is a context free grammar, right? This is a context free grammar G. So because this is a context free grammar G, so LG is what? LG is CFL. Every CFL is what? Every CFL is recursive. And recursive, another name for recursive, that is decidable. Okay, so the language is decidable. This, for this grammar, if you see the string w equal to AB, then it will have exactly one parse tree. Okay, for this AB, the parse tree, if you make, that will be A, S, B, S, and then you can see that this S cannot go to BS. This S cannot go to BS because we want to A to B. So if this S goes to BS, then we will have more B than A. You can see that this S cannot go to ASBS because then we will have double A. Okay, so you can see that this S must go to epsilon and this S must go to ASBS, and then this must go to epsilon, this must go to epsilon. Okay, so here you can see we got AB, and for this string we have exactly one parse tree. We have one parse tree, and remember, for any string, the number of parse tree is equal to the number of rightmost derivations, and that is equal to the number of leftmost derivations. Is this clear? For any string, the number of parse tree is equal to the number of rightmost derivation is equal to the number of leftmost derivation. So very simple. And for this grammar, you can notice one more thing, that if you take this string A double B, then you will get multiple parse tree. You will get, you can see that S can go to AS, BS, then this S can go to BS, and then all the S can go to epsilon. So we got A double B. Another is AS, BS, then this S can go to epsilon, and this S, this second S can go to BS, and you can see this S can go to epsilon. So you can see that for this we have two distinct derivations. Actually, we have two distinct parse tree, two distinct leftmost derivation, two distinct rightmost derivations. So of course we have two distinct derivations. Okay, so you can see that this string is ambiguously derived. This string is ambiguously derived. Because this string is ambiguously derived, if you have at least one string ambiguously derived, then the grammar will be ambiguous. Okay, so that's it. This is the analysis of this question. The grammar is ambiguous because for this string we have two distinct parse tree, and remember, for this string we have two distinct derivations, and for this string we have exactly one rightmost derivation, and the language is CFL, so that is decidable. Okay, so for this question the answer will be option ABC. This was MSQ question. What do you think? This was easy, hard, or moderate? Which category you will put this question? Let me know. So this question, Sachin, what do you think?
I think it will be moderate. I mean, easy है वैसे तो मतलब but easy to moderate we can say because the silly mistake chances are there. So that's why I'm saying.
I think, Sachin, silly mistake chance are there in the option C, because
Of
students,
not
some,
mentioning exactly too.
yes, they are
Mhm.
not mentioning that two distinct derivation. Is this exactly two? Is this at least two? Is this at most two? And they are mentioning derivation. They are not mentioning leftmost derivation, rightmost derivation. They are not mentioning parse tree. Okay, so that might be the reason. Actually, for this string also, if you see, Sachin, only one rightmost derivation will be there, but actually the number of derivations, that will be actually more than one. For this string also, the
Right,
number of
right.
derivations will be more than one, but the number of rightmost derivation will be exactly one. So I think if some student has made mistake, then they must have made mistake in the option C, I think. Other than that, this question is quite standard question. We have already done this type of questions in our lectures, in the test series. You may have seen this type of question in our weekly quizzes and test series in AMT also. But here, this distinct derivation, two distinct derivation, they have not given actually. In this type of situation, we should by default consider at least, because this is the meaning of this option. Okay, this option want to say that A double B has two distinct derivation means if you have two distinct derivation, there can be more, but if you have two distinct derivation, then this statement will be true. Overall, I can put it in the moderate category. Okay, let's put it in the moderate category. This might have confused some students, so let's put it in the moderate category. But this was a traditional question. This was also traditional PYQ based. How many of you did it correct, and how many of you did it wrong because of this option C? Two things you let me know. Did you do correct? Did you do wrong? Did you do wrong because of option C? Let me know. Let's go to the next question, Sachin.
Yes, so it is regarding number of A's and number of B's. So it was a good question. I do not have the grammar with me.
Okay, let me write the question because I remember the options and I remember what was the correct option. So the grammar, maybe we don't remember, but I remember what were the correct options. So another MSQ question, Sachin. All TOC questions are MSQ.
Yes, yes. So that's what I also noticed. So basically, in this question, let me remind you before the options. There were like two, three non-terminals were there. S was giving something, but the catch was that we discussed, Deepak. That A and B were, I think, generating equal number of A's and B's, right?
See, no, no, this A was not generating that,
A was
but
not generating.
B.
B was
Actually,
generating
B was generating A power n, B power n,
AB. This is AB.
AB. So B was generating A power n, B power n, where n is greater than equal to 1. And this S was going to something like A, B, A, then capital A, A, B, capital A, A, B, then B, A, B. Okay, so this something like this was there basically. In S, you have number of small a equal to number of small b. Then in A, you have two productions. In one production, you have something. Okay, I don't remember exactly, but something like A, then A, B, A, then B, something like this. Or
AAB, I think.
no, here also it was A, B, B, something like this.
Okay.
Basically, I exactly remember this point that both these A productions, they were having one more small a than small b. Okay, so you
Right.
can see here also one more small a than small b. Here also one more small a than small b. Okay, this type of productions were there. I'm not saying that this were the exact production, but I'm saying I guarantee that in both these productions, the number of small a was one more than number of small b. And in S, in this production, the number of small a equal to number of small b, and this B production is exactly correct. Okay, so this B production is exactly correct. Here, let me put star that, but these one thing is very sure that in this A also, one thing was very sure that in these productions also the number of small a was one more than number of small b. So this type of question was there. And let me tell you the options also. Let me write the options also. So Sachin, basically the question was saying that N1 means N1W. Okay, in this
Yes.
question, this type of statement was given that N1W, N1 of W, that is basically equal to number of A's in W, and N2W, that is basically equal to number of B's in W. Okay, so this was given. Now let me write the options. The option number A, that was that
For
for all W,
all
huh,
W,
Sachin,
number of A's are less than equal to 2 into number of B's.
number of A's are less than equal to 2 into number of B's.
Yeah.
Okay, and there was another option that was negation of this basically. For at least one string, for some W, number of A is more than twice number of B. And there was another option that was that for all W, for all strings W, the number of A that is greater than equal to the number of B's. And there was option D, which was negation of option C, that was for some W, number of A that is less than number of B. So this question was there. What do you think? What was the answer? Anyone here? solved it. So for this question, what do you think? What was the answer? This was actually a good question, and let me tell you the answer here. This was not an easy question, but let me tell you the answer here. You can easily see that for every string, the number of A will definitely be greater than equal to number of B. So option C, that is correct. So automatically option D, that is wrong, because option D is basically negation of option C. So option C is correct. So automatically option D is wrong. And what about option A comma B? So let me tell you, option A is correct and option B is wrong. Okay. So here actually these two options were easy, but this option was tricky. Okay. And let me tell you what is happening here. See, you may have made this type of mistake. Okay. You may have thought like this, that S is going to, for example,
Yeah,
okay,
actually, I did this mistake. I thought that okay, S is going to equal number of age and equal number of B's, and B is also going to equal number of age and equal number of B's. So there is only A which is having double A's than the B's.
see, A going to, just let me quickly write it. सचिन, चैट में किसी ने बताया क्या कि ए के एग्जैक्ट प्रोडक्शन क्या था, कुछ ऐसा?
हाँ, हेत ने बताया था, बट उसने फिर डिलीट कर दिया। ओके, यस,
हेत,
कैपिटल ए
डिड यू
going to,
डिलीट? हेत, अगर
यस,
आपने डिलीट किया है तो प्लीज एक बार फिर से पुट कर दो।
नहीं, देर इज वन कमेंट, वो दोबारा हेत ने डाल दिया। स्मॉल ए कैपिटल बी
कैपिटल
कैपिटल ए
बी,
के प्रोडक्शंस, कैपिटल ए के प्रोडक्शंस,
हाँ क्या था? स्मॉल ए,
स्मॉल ए कैपिटल बी कैपिटल ए।
ओके, कैपिटल बी कैपिटल ए,
हाँ
ऐसा?
हाँ हाँ हाँ,
ओके ओके, कैपिटल बी
कैपिटल
कैपिटल
ए
ए,
एंड डबल
हाँ।
बी। ही इज सेइंग डबल बी। नहीं यार, डबल बी तो नहीं था।
नहीं नहीं, डबल बी नहीं था। नंबर ऑफ ए
हाँ,
जो था, नंबर ऑफ स्मॉल ए जो था, वो नंबर ऑफ स्मॉल बी से एक ज्यादा था। ठीक है, तो हाँ, ये हो सकता है कि डबल बी होगा यहाँ पे, कैपिटल डबल बी होगा, ये हो सकता है बिल्कुल।
हम्म,
ठीक है हेत, जो नंबर ऑफ स्मॉल ए था वो नंबर ऑफ स्मॉल बी से एक ज्यादा था, जो ए के प्रोडक्शन थे उसमें। डबल,
या सो
चलो
बेसिकली,
ठीक है, मतलब बात यह है कि एक्चुअली मुझे मुझे लगता नहीं है कि इस एग्जैक्ट प्रोडक्शन से कुछ फर्क पड़ेगा। क्योंकि एक्चुअली इसी चीज से फर्क पड़ेगा कि ए बी के अंदर जो नंबर ऑफ ए है वो इक्वल टू नंबर ऑफ बी है, एस में भी नंबर ऑफ ए इक्वल टू नंबर ऑफ बी है, और ए के अंदर जो दोनों प्रोडक्शन है उसमें नंबर ऑफ ए जो है वो वन मोर देन नंबर ऑफ बी है। हाँ सचिन।
yeah, so let me tell you my silly mistakes. I think many of the students might have done the same silly mistake. So what I did, I thought that okay, this S and B are generating equal number of A and equal number of B, so let's just forget about it. So I actually forgot about this S and B. This was the biggest mistake that I did. That I discussed with Deepak later. Deepak told me that it was a mistake. So
सिली, या लेट मी राइट इट सचिन, कि सिली मिस्टेक कुछ ऐसी थी कि सिली मिस्टेक इज बेसिकली कैंसलिंग,
the effect of
कैंसलिंग, फॉर एग्जांपल कैंसलिंग एम एज विद एम बीज, आई कैन राइट लाइक दैट्स राइट, canceling m is with m b's, something like this, right Sachin?
right, right.
हाँ,
Basically, I,
so
I actually haven't even written down those S and B productions on the paper. I thought it's not relevant for the question.
actually Sachin, let me just take a small example, okay, and let me explain what is happening here and
Yes.
why this canceling is a mistake. Basically, let me take this example, a small example I am taking. Okay, consider this example, that s is going to a a b. Okay, so here you can see that number of a equal to number of b, right Sachin?
Yes.
Now just take this, that let's assume that A is going to double AB and double AB. Now here, if you notice, you will be thinking that here number of A equal to number of B. I am talking about number of small a, small b. So you will be thinking, all the students, notice here that you will be thinking that now here number of A equal to number of B. So let's cancel them. Okay, forget about them. And here you can see that number of A is double of number of B. So what can I say? Can I say that here you tell me, here can I say that for every can I say that, can I say that there is a string. Okay, this is, let me write it, that can I say that for some string, for some w, can I say that number of a will be equal to, or I can say greater than equal to twice, sorry, or greater than equal to, okay, twice the number of b. So can I say this? Now notice one thing here. Notice this a, what this a will generate, this will generate a power 2n b power n, where n is greater than equal to 1. But please notice here, if you generate, let's assume if you take n equal to 1, okay, let's take n equal to 1, but the string will be generated by s. Please focus, string will be generated by s. So overall, what string you generated? You generated ab, already there is ab, and here you have generated a power 2 b power 1. So overall, what we got? We got a power 3 b power 2. So did we get double a's? We did not get double a's. But if you cancel this a with this b, if some student is thinking that, okay, let's cancel this a with this b because these are equal, okay, for every a you have every a you have b, but here you have double a then b. But you can see overall the string is generated by s. So you can see that number of a is not double of number of b's. If you take n equal to 2, then also the same story, a b, and in between what you will get? You will get a power 4 b power 2. So the same story is repeating, that here also you can see we have a power 5 b power 3. Here also we don't have double a then b. Yes or no? I hope you are getting my point, that if you cancel like this, if you cancel m a's with m b's, okay, if you cancel m a's with m b's, and then if you solve this question, then you will get wrong answer. I hope you understood my point, that here, can I say, for some this statement actually will be false. Okay, so I hope you understood the point. So let's finally come to the answer. What will be the answer? So for this question, the answer will be that for all w, the number of a will be less than equal to twice the number of b. And also this option C, that is for all w, the number of a will be greater than equal to number of b. So this was the question. What do you think? This was a easy, hard, moderate? What type of question was this? Anyone?
I
Sachin?
think it was moderate to tough because of this mistake, like of canceling out mistake. According to me, it was moderate to tough.
Yes, it was a. I definitely it was. I can say moderate to tough. Maybe we can put it in the tough category. Okay,
Yes.
so we can put it in the tough category. Okay, this was really a good question, but we can put it in the hard category. It was not easy. This was definitely moderate to hard, or I can say hard. Okay, so let's just directly call it hard.
Right. Right.
Okay, because actually this option will confuse many students. Actually, this option a comma b, this will be confusing. And also, Sachin, in this particular question, if you try to take strings, if you try to generate strings, that will consume a lot of time.
Right. Right.
Okay, so for this particular question that we just discussed, for this TOC question, it was moderate to hard, or I can say it was hard. Did you do it correct? Is there anyone here who did it correct? Let me know. And did you do it correct by the same logic that I told you? Did you skip it? Did you do it wrong? Did you do it correct? Okay, let us know. Now we can go to the next question. So Sachin, TOC का कोई और बचा है
Yeah.
क्या?
I think TOC is over, so we can go to discrete mathematics.
TOC के बस इतने ही क्वेश्चन थे क्या? 4?
If there is any other question, please let us know in the chat. So currently, I think these are the only questions that I have.
Other than these 4 questions, was there any other theory of computation question? Do you remember any other theory of computation question? You can see in all these 4 questions, the questions are from grammars, from finite automata, from closure property, regular languages. Only these topics. There is no question from decidability, no question from Turing machine, no question from countability, no question from PDA, push down automata. These type of questions are not there. No question from detection of languages. So this type of questions are not there. LL1 grammar, that is a compiler design question. Any other theory of computation question? Do you remember? Let us know. Sachin, next कौन सा subject?
Yes. Discrete mathematics.
Discrete maths. Okay. So let's discuss the next subject, that is discrete maths.
Yes. So there was one question related to vertex cover. This was a MSQ question, and in that only one option was correct.
Huh. So there was a question, the given information, basically question on vertex cover. Okay, vertex cover question was there. We have already studied vertex cover in our discrete mathematics graph theory course. Do you remember? In very detailed way, this vertex cover we have studied. So vertex cover question was there. And in this question, this was a MSQ question, but only one option was correct. Sachin, almost all the questions are MSQ. Like, can I say that number of MSQ question? I think that is way more than the usual number of
Right,
MSQ
right.
questions, I think.
Generally, in any gate, I think 10 to 12 or maybe 13 MSQ questions come. But this time, like we have to count it, but probably more than like 16, 17.
Sachin, one student is also saying that one question in DBMS came directly from our final All India mock test. Anyone remembers this BCN of decomposition, dependency preservation, BCN of dependency preservation, 3N of dependency preservation, 2NF? Do you remember this exact question as it is question, dependency preservation plus BCNF, 3NF, 2NF? Do you remember this exact question was present in our Go classes All India mock tests? I think 6. The last All India mock test, this question was present. Do you remember? Anyone? In Go classes final All India mock test before the gate exam, this question was present. Where the options, this we also gave MSQ question. The options were BCN of decomposition with dependency preservation is possible or not. 3NF with dependency preservation is possible or not. 2NF with dependency preservation is possible or not. Anyone remembers it? That exact question. Yes, that exact question came this time also. Okay, we will discuss it. But yes, Sachin.
Right. So, from discrete mathematics, there was one question related to vertex cover,
Yes.
and like they were asking about the I think vertex cover of some vertex. So, degree k plus one, you told me the degree k plus one option was correct in
Okay,
that.
let me write the question. Actually, the vertex cover question was there, and the question was saying that minimum vertex cover size, that is k. Okay, this was given. This was given that minimum vertex cover size. Minimum vertex cover size, that was k. Okay, this was given. Also, the question was saying that for any vertex cover of size k, for any vertex cover of size k. Okay, basically, S is any vertex cover of size k. S can be any vertex cover. Remember, it was given that let S be any vertex cover. Yes, I remember. This was the question, that let S be any vertex cover of size k. Means, okay, basically, what this means, this simply means that S is any minimum vertex cover. Okay, S is any, it can be any minimum vertex cover. Okay, this was given. And now the question was very interesting. The question was asking that for any V, the question was asking for any vertex V, for any vertex V, which condition, which condition guarantees, which condition always, which condition always guarantees, which condition always guarantees that V belongs to S. This was the question. Okay. So the question was asking that for any vertex V, which condition, some conditions were given, and which condition will always make sure that V belongs to S. And now the options were option A, that was that degree of V is equal to K plus 1. And let me tell you, this was the only answer. है ना, Sachin?
Yes, yes. This was the only answer, I think.
So this option was there, that degree of V is equal to K plus 1. And there was another option. Another option was that V is V is part of click. V is part of a click of size K, of size K. एक ये ऑप्शन भी था। और ऑप्शन क्या था, एक
I
था।
think V is a part of some path graph. वो इस
हाँ
क्वेश्चन था क्या?
हाँ हाँ, वो भी सही है, वो भी सही है। वी इज पार्ट
हाँ।
ऑफ पाथ। वी इज पार्ट ऑफ अ पाथ ऑफ लेंथ, शायद क्या थी, लेंथ के थी कि के प्लस 1 थी?
Okay,
लेंथ
that
शायद
I don't remember. हाँ.
के प्लस 1 थी शायद। लेंथ के प्लस 1, आई थिंक लेंथ के प्लस 1 ही थी।
Yes,
और
yes.
एक और ऑप्शन था, कुछ याद आ रहा है सचिन? कि एक तो डिग्री थी, डिग्री इज इक्वल टू के प्लस 1।
Click degree and
एक और था कि देयर वाज वन मोर ऑप्शन, एनीवन रिमेंबर्स? ओ यस यस, साइकिल का पार्ट एक्चुअली, एक के लेंथ साइकिल का पार्ट वी इज पार्ट ऑफ अ के लेंथ साइकिल, अ के लेंथ साइकिल। ये सही है? साइकिल
right,
ऑफ
right,
लेंथ,
right, right.
स्टूडेंट्स बोल रहे हैं साइकिल ऑफ लेंथ के प्लस 1।
Yes, yes, yes. K और
स्टूडेंट्स के प्लस 1 बोल रहे हैं, चलो मैं के प्लस 1 लिख देता हूँ। ओके, सो इट वॉज अ पार्ट ऑफ के प्लस 1 लेंथ साइकिल। ठीक है ना अब?
हम्म right, right.
हाँ ठीक है, ज्यादातर स्टूडेंट्स भी वैसे भी के प्लस 1 साइकिल बोल रहे हैं। ठीक है, सो फॉर दिस क्वेश्चन लेट मी टेल यू द आंसर। This was MSQ question, but only one option was correct. That was degree of V is equal to K plus 1. Okay, so let me just give you the counter example for option B, C, D also. You can consider, first of all, let me give you counter example. Like consider this consider this graph like V1, V2, V3, V4, V5। ओके, ये पाथ कितने लेंथ का पाथ हो गया? ये 4 लेंथ का हो गया, राइट? ठीक है। अब इसके अंदर, in this actually in this path, if you find the vertex cover, then that will be size 2. Okay, and this is, so if I do this, then I think it will become size 3. Okay, now consider this graph for a moment. Consider this graph. Now for this graph, if you notice, the minimum vertex cover size, that will be this vertex you can take, then you can take this vertex, and then you can take this vertex. Basically whatever you do, minimum vertex cover size, that is k equal to 3. Okay, because this is the minimum vertex cover size. Whatever vertex cover you create, it will have size 3, minimum vertex cover size, that is 3. Now you can see that v1, v2, v3, v4, they are part of k plus 1 length path. Yes or no? If you notice this path, consider this path, consider this path, you consider this is length 4 path. Yes or no? Okay, so you can see this is basically k plus 1 length path. Now here we can easily see that not every vertex cover will have, for example, v2. Okay, you can see that this v2 is part of this k plus 1 length path, but you can see I can give you some vertex cover, for example, a possible s. Okay, s can be, for example, v1, v3, v4. This is possible. Another, that is v2, v3, v5, this is possible. There are more. Okay, so you can easily see that it's not necessary that v2 will be part of minimum vertex cover. It is not necessary. Okay, so you can see this option. Which option? This option C. We have seen the counter example of option C. Okay, next, what about option B? V is part of clique of size k. So I can say that this is counter example. This is counter example of option C. And I can also just quickly give you the counterexample for option B also. B is saying that V is part of clique of size K. So what you can do, you can consider this A, B, C, D. Okay, or consider this A, B, C, V. Now here you can easily see what is the vertex cover size, what is the K size. So you can take this, you can take this. Here K is 2, but if I put another vertex here, let's zoom. If I put vertex C here, then in this case 1, 2, if I take these, then K will be 2. And if I want K equal to 3, maybe I can take, for example, here E, F, something like this. So you can see now, you can easily see that this is a, okay, for this whole graph, you can see you can take this vertex, you can take this vertex, all the edges will be covered. So you can see that K is actually 3 for this graph. Okay. And you can see that this is K plus 1 length cycle. Okay, you can see V is part of K plus 1 length cycle. So here you can see that what are the vertex covers possible. For example, this is a vertex cover possible, A, V, but another vertex cover possible, that is E. Then you can take B comma C. Okay, you can take B comma C, right? So you can see that V may not be part of vertex cover. If I take E, B comma C, all edges are covered. Okay, so you can see that this is the counter example of which option? This is the counter example of option D. Next, I can give you the counter example of option B also. That is V is part of clique of size K. So clique, okay, I can make like this: A, B, C, D, and I can put a like this. Now, of course, this is a clique. Clique means a subgraph which is complete subgraph. Okay, so you can consider this. Here you can see what is the K value. So that will be 3 vertices you have to take. Either you can take these 3 vertices or these 3 vertices, but 3 vertices you have to take, the K value will be 3. Okay, now you can consider that this is V. Okay, for a moment you consider this V. Now you can see that V is part of clique of size 4. Yes or no? This is a clique of size. V is part of clique of size K plus 1. Okay, but here you can see what will be S, what will be minimum vertex cover. You can see this minimum vertex cover is also possible. This minimum vertex cover is also possible. Okay, so like that. One more thing here, if you consider that V is part of clique of size K also, you can consider this. Okay, you can consider this one. Please notice. Consider this clique. This is also clique. Clique means complete subgraph. Okay, you can see this is a clique. This is a clique of size 3. Okay, so you can see V is part of clique of size K, but still you can see that this S is possible, minimum vertex cover. This is possible, ACD. This can be minimum vertex cover. So here also you can see that V is not part of S. So I hope you understood the point that option B, option D, option C, they are wrong. And for this MSQ question, only one option is correct, that is option A. Okay, let me just quickly tell you the proof for option A also. For option A, okay, you can actually easily prove it, because you can see you have a vertex which has degree. Let's assume this has degree 4. See, assume for a moment, assume that K is equal to 3. If K is equal to 3 and this vertex has degree 4, this vertex has degree 4. Now you notice, if V is not present in minimal vertex cover, let's assume for a moment, okay, assume V does not belong to some vertex cover. Okay, some minimum vertex cover. There is some minimum vertex cover to which V does not belong. Then what will happen? In that minimum vertex cover, what will happen? You have to take this vertex, you have to take this vertex, you have to take this vertex, you have to take this vertex. So you can see in this minimum vertex cover, okay, let's call it some h2. Okay, so you can see that in this h2, the h2 size definitely will be greater than equal to 4, because in h2 this abcd must be present. Do you agree with me? Okay, yes or no? So you can see that then okay, from here I can say then h2 h2 will definitely contain abcd. So the size of h2 will become greater than equal to 4, but we are saying that size of h2 that is actually 3, so that is a contradiction. Okay, I hope you understood the point, that if v does not belong to some minimum vertex cover, then abcd must be present in that minimum vertex cover. So the size of that minimum vertex cover will become more than 3, so that is a contradiction. Okay, yes or no? So that is a contradiction. I hope you understood this proof. This is a very simple, cute proof. I hope you understood. Okay, let's move on now to the next question.
Yeah, so from discrete, there was one question related to matching. I think it
हाँ,
was a very long question.
यस यस, नहीं एक्चुअली सचिन वो भी काफी इजी क्वेश्चन है. ओके,
Okay.
हाँ, but before that you just tell me about this particular question. What do you think about the level of this question? Anyone? This minimum vertex cover question, what do you think? What was the difficulty level? I want to write the difficulty level of this question, this vertex cover question. Sachin, what is your opinion? कैसा था ये question?
I think it was moderate, like not that tough, or neither it was easy.
Actually, this was moderate to tough if you can find the counter example.
Yes, yes,
If
right.
if if a student can find the counter example, then it was, I can say, moderate. Otherwise, it was tough. Okay, overall, this was moderate to hard. The reason is simple. If you can find the counter example here in this question, if you are able to find the counter example, then it is moderate, or I can say easy. But it might not be easy to find the counter example. Okay, finding the counter example might itself be hard, or I can say it might be challenging. So overall, this was, I can say, yes, hard. Okay, most of the students are saying hard, so let's go with hard.
Okay.
Okay, now we can go to the next question now. But remember this vertex cover problem, this vertex cover concept, vertex cover matching. Sachin, is bar this year in same gate paper, like in set 1 of gate CS 2026, two questions came from graph theory. One, actually three questions came from graph theory, one on matching, one on coloring, another on vertex cover. And I have seen, okay, let's forget about other institutes, but in Go classes, we have taught all these concepts: matching concept, perfect matching concept, vertex cover, edge cover, all these concepts, click, okay, the concept of click, the concept of coloring, edge coloring, vertex coloring, each and every concept, you name the concept, that is covered in Go classes discrete mathematics graph theory course. This year from graph theory, three questions have come. One based on coloring, another based on matching, another based on vertex cover. All
I
these three
think,
concepts in a detailed way we have covered in Go classes discrete mathematics course. Yes, Sachin.
and also I think from discrete mathematics, there is no other question from apart from these three questions.
There was one this
I can that matrix question, 4 cross 4.
combinatorics question, matrix 01.
Yeah, yeah.
That question also we will discuss. That was also a beautiful question.
Yes.
So I really loved that question, but that question also was there. So basically, total four questions were there from discrete mathematics. And these four questions, three of them are from graph theory. There is no question from group theory, no question from relation function, propositional logic, from set theory, from first order logic. There is no question. So the paper was very disbalanced. I can say in discrete mathematics, three questions only from graph theory. And
Right.
graph theory we have studied in a very nice way in the Go classes discrete mathematics course. You can watch it. You can check that मैचिंग, परफेक्ट मैचिंग, वर्टेक्स कवर सब करवाया है, इंडिपेंडेंट सेट, रिलेशनशिप बिटवीन, ये सारे क्वेश्चन सब कुछ करवाया है.
And
ओके,
दीपक ऑल्सो आई थिंक कि शायद ही ये बाकी किसी इंस्टीट्यूट में इतना डेप्थ में शायद वर्टेक्स कवर और ये
नहीं
इंडिपेंडेंट साइड पे
नहीं, या
नहीं
तो
हुआ हो.
स्किप करेंगे, या फिर या तो स्किप होगा आपको, या तो जैसे मैचिंग और वर्टेक्स कवर या तो आपको मिलेगा नहीं. नोट्स के अंदर चेक कर लो, शायद नहीं मिलेगा. अगर मिलेगा तो बस ऐसे सुपरफिशियल, मतलब कि ठीक है बस डेफिनेशन चारों, एक होता ना कि एक ही पेज के अंदर, एक ही स्लाइड के अंदर दो तीन डेफिनेशन दे दी, बात खत्म, ऐसा कुछ. सो ओके, बट वी हैव डन द कंप्लीट एनालिसिस. ओके, यू कैन वॉच the Go classes discrete mathematics graph theory course. You can watch all these concepts: matching, matching, vertex cover, independent set, everything is covered. Okay, so let's discuss the next question. कौन सा था, मैचिंग वाला क्वेश्चन? यस.
या ये
So
मैचिंग
there
ऑफ
was a,
टू कलरेबल वाला भी था एक.
this question was there. Yes, two colorable question was also there, but this question was NAT, and the question was matching question.
यस.
Anyone here who did it correctly, this matching question? So let me tell you the given information in the question. Basically, you have a path graph. You have path graph on 8 vertices. Okay, so basically you have P8. Okay, and the question is asking just number of matchings. The question is asking number of matchings in this P8. Okay, that's it. This was the question, that we have to find the number of matchings in P8. And let me tell you the answer for this question. This was actually quite, I can say, easy question. It was lengthy question. You have to calculate. We will see the solution. You will see that this is lengthy question. The calculation is lengthy, but the question was very easy. If you understand the concept of matching, if you understand the definition, if you have studied the concept of matching, if you have watched Go classes discrete mathematics graph theory course, then this question is very much doable, very easy, but it was lengthy. Now we will see the solution, don't worry. But the answer was, Sachin, answer I think 34, right?
34, yes.
Yes, the answer will be 34. And let me just quickly tell you the solution. The solution is actually very easy. The question is asking number of matchings. First of all, let me tell you what is a matching. Matching is basically set of non-adjacent edges. Set of non-adjacent edges. Okay. So any set of non-adjacent edges, any set of non-adjacent edges, that is basically matching. Means matching is basically set of edges where no two edges have any common endpoint. Okay, so you can see, I can say that it is basically set of non-adjacent edges. Now let's quickly see the solution for this. You can see you have a path graph, right? Path graph on 8 vertices. So first let's draw the path graph on 8 vertices. It will be like v1, then v2, v3, v4, v5, v6, v7, v8. This is the path graph on 8 vertices. Now let me tell you, let's find the matchings. Matching is any set of non-adjacent edges, yes or no? So let's find matchings. Now remember, any set of non-adjacent edges, that is matching. So you can go in a systematic way. First you can find matchings of size 0. Okay, so let's find matchings of size 0. First what you can do, you can find how many matchings of, find the number of matchings, or I can say, yes, the number of matchings of size 0. Okay, how many matchings of size 0 we have? So that will be only one, that is empty set. Yes or no? Okay, you can see matching of size 0, that will be empty set, means you are not taking any edge. So matching of size 0, that will be your empty set. You are not taking any edge. Okay, so if you don't take any edge, that is fine, because matching is any set of non-adjacent edges. So you can see matchings of size 0, that is 1. Now what will be the matchings of size, let's see, what will be the matchings, number of matchings of size 1. So if I am finding the number of matchings of size 1, then only one edge I will take. So you can take any edge here, yes or no? So the answer will be 7. Okay, so the number of matchings of size 1, that will be 7, because you can take this edge, you can take this edge, or you can take this edge. Okay, so you can see what are the matchings of size 1. Some examples let me give you. For example, you can take this edge. Okay, for a moment, you can see this v1 v2, this edge you can take, or you can take v2 v3, this v2 v3, this edge you can take, or you can take v3 v4, this edge you can take. Okay, you are getting my point, right? Okay, and so on, v7 v8, this edge you can take. So basically 7 matchings of size 1 we have. Next, what about the third? How many matchings of size 2? So the number of matchings of size 2. Now this is actually quite interesting, because notice, if I take this edge, okay, for, if I take v1 v2, just notice one thing, that if I take v1 v2, means this edge if I have taken. Now if I have already taken this edge, then definitely I cannot take this edge, because these are adjacent edges. Okay, yes or no? This edge, they have common endpoint v2. So these are adjacent edges. This edge, they are adjacent. So if I'm taking V1, V2, then definitely I cannot take V2, V3. But remember, I want matchings of size 2. So with V1, V2, I can either take this edge, or I can take this edge, or I can take this, or I can take this, or I can take this. Okay, so you can see number of matchings of size 2, that will be 5 plus, okay, 5, where I have taken V1, V2. Okay, V1, V2, and one more, plus one more, I can say, plus one more is V1, V2 plus one more is, this type of matchings will be 5. This type of 5 such matchings we have. 5 such matchings. Okay, I hope you understood. Now notice, now already we have considered V1, V2. Now forget about V1, V2. Now don't take V1, V2, because all the possibilities with two size matchings where we have taken V1, V2, those we have considered. Okay, so now we will not consider this V1, V2. Okay, now assume that this V2, V3 you have taken. Now this V2, V3 you have taken, so you cannot take this as, because this V2, V3 and V3, V4, these are basically adjacent. You can see this as, they are adjacent. So you cannot take this as, but you can take this, or you can take this, or you can take this, or you can take this. So basically, again, I can say 4. Okay, I hope you understood. So you can see, if you take this as, then total 4 matchings of size 2 you can create. Okay, then you can see, if I take this as, then I cannot take this as. Remember, don't consider V1, V2 with these edges, because these we have already considered. In this 5, we have considered all the matchings of size 2 containing V1, V2 as. In this 4, we have considered all the matchings of size 2 containing this as V2, V3. So now don't consider V1, V2, don't consider V2, V3, these edges. Okay, so you can see, if I take this V3, V4, then I cannot take V4, V5. Okay, then I can take this or this or this, because I want matching of size 2. So finally you can say that plus 3. I hope you are getting the point. Like this, it will be plus 2 plus 1, because you can see, if I take this as, then I cannot take this as, then I can take this as. So you can see, 1. Okay, if I take this as, then 1. If I take this as, then 2. Okay, so you can see, if I take this as, then 5. So I can say 5, 4, 3, 2, 1. Okay, and if I take this as, then I cannot create. Okay, so I hope you understood. Now plus what? Plus what? I think that's it. Okay, so the matchings of size 2, these are the matchings of size 2. You cannot create any other matching of size 2. So what is this number total? You can see 5 plus 4, 9, 12, and 15. So 15 matchings of size 2. Now what will be the number of matchings of size 3? So what that will be? I hope you understood the idea. Now you can just find the number of matchings of size 3. So let's start with V1, V2. If you have taken V1, V2, now you need to take one more edge. Okay, you need to take plus 2 more edges. Okay, you need to take plus 2 more edges you need to take. So how many such matchings I can create? So already you have taken this V1, V2, you cannot take this. Now notice that here I want two size. Okay, please notice, from here I want two size matching. Yes or no? So already this we have calculated. From here I want two size matching. So if I take this, then I cannot take this, then 3 will be there. Okay, you are getting the point. So you can see that if I take this, then 3 will be there. Plus, if I don't take this, if I take this, then I cannot take this, and I can take any of these two. So 2 will be there. Okay, so you can see, if I take this, then 2 will be there. Okay, now next, if I don't take this, if I take this, then I cannot take this, I have to take this, so 1 will be there. Okay, overall I can say it will be like plus 1. Okay, so now I can say that this type of how many matchings? 6 such matchings. 6 such matchings, and then plus, you can see, if I don't take this. Okay, now forget about V1, V2, because all the matchings of size 3 containing V1, V2 we have already considered. 6 such matchings are there. Now you forget about V1, V2, don't consider V1, V2. Now if you take this, then you cannot take this. If you take this, then you can see you cannot take this and 2. Okay, so I can say that 2 plus 2 plus, you can see if I take this, I cannot take this. If I don't take this, and let's assume I take this, then in this situation I cannot take this and I have to take this. So plus 1. Okay, so that's it. That's it. So next, after that, you can see if I now don't consider these. Okay, if I take this, I cannot take this. If I take this, I cannot take this. Then there is only one possibility. Okay, so that's it. Now there will be no other three size matching. So how many three size matching are there? 6 plus 4, that is 10. 10 three size matchings are there. And how many matchings of size 4? Number of matchings of size 4, that will be only one. Okay, because to create matching of size 4, you have to take this, you have to take this one also, this one also. Okay, so you can see the number of matchings of size 4, that will be only one. It will be like v1 v2 you have to take, v3 v4 you have to take, v5 v6 you have to take, v7 v8 you have to take. Okay, so finally what will be the answer? The number of matchings, the total number of matchings, what that will be? So I told you that this is an easy question, but this is lengthy question. Okay, do you agree with me that this is lengthy question? So you can see number of matching of size 0, that is 1. Number of matching of size 1, that is 7. Number of matching of size 2, that is 15. Number of matching of size 4, that is 1. कुछ मिस हुआ है सचिन? मिस हुआ है क्या कुछ? एक सेकेंड. So 1 7 15 10, 1 7 15 10. आई थिंक ये टोटल कितना बना?
25, 26, 27 या 34.
34 बन रहा ना?
हाँ हाँ हाँ.
Okay, so this will be your answer. What do you think? What was the difficulty level of this particular question? Will you consider this hard, easy, moderate? Definitely, it is lengthy question. Okay, I have no doubt about that. Sachin, what is your opinion on this question? What, like after seeing the solution, Sachin, what is the opinion?
I think it was for me it was hard because of lengthy, and also like it seems to be a hard question. Yeah, obviously, like once it clicks in the mind that we need to solve in this way, then probably it will take 5 minutes. So
Definitely, it was lengthy. Even if you understand the concept, then also it is lengthy, really, literally lengthy. Okay, and I can put it in the hard category, no doubt. Okay, so or I can say maybe moderate to hard, but definitely it is too lengthy. I can say so much. I can say it is like there is nothing conceptual here, Sachin. Like it's not this particular question is just about brute force कि बस ठीक है लगे रहो अपना टाइम थोड़ा वेस्ट करो. ऐसा कुछ एक होता है ना कि जैसे क्यूट क्वेश्चंस होते हैं जहां पे कि यार कम कम टाइम में सोल्व हो जाते हैं, लेकिन मतलब क्वेश्चन में कुछ अच्छा कॉन्सेप्ट होता है कुछ. इसमें
right.
तो क्या है कि एक बार अगर आपको क्लिक हो गया कि आपको साइज 0, साइज 1, साइज 2, साइज 3, साइज 4, you have to find the number of matchings of different sizes. And to find that, you have to basically do a lot of manual calculation. It is kind of, I can say, a brute force. Okay, and this type of questions are definitely not good questions. I will say this is really not good question, but this is doable. This is what I'm saying. It is moderate to hard, more inclined toward hard. So basically, you can consider this is lengthy and hard. Okay, what is your opinion?
And also, Deepak, I asked Gemini and ChatGPT, so they have suggested very nice other way to solve this question. So they are
अच्छा.
saying that just like dynamic programming, कि लास्ट वाला जो वर्टेक्स है ना, उसको ले भी सकते हैं, नहीं भी ले सकते, मतलब वो मैचिंग में वो आएगा या नहीं आएगा. अगर वो आता है तो फिर अपने पास n-1 का पाथ बचा, है ना. तो
ओके.
आएगा तो n-1 का पाथ, सॉरी नहीं आएगा तो n-1 का पाथ बचा, और आएगा तो फिर शायद बी, मतलब अगर लास्ट वाला आएगा तो सेकंड लास्ट भी आएगा, मतलब कुछ ऐसा होगा ना, सेकंड लास्ट भी आएगा. तो
अगर
फिर
लास्ट आएगा तो सेकंड लास्ट नहीं आएगा, तो फिर उसके बाद में हमें टी एन
एन माइनस
माइनस
टू
टू
का.
फाइंड करना है.
हाँ, तो
आई
बेसिकली
थिंक.
मतलब एस एन इक्वल टू SN-1 प्लस SN-2, कुछ ऐसा रिकरेंस बन जाएगा.
ओके ओके ओके, सो बेसिकली फॉर दिस मैचिंग क्वेश्चन आई थिंक लेट्स ट्राई, या फिर मतलब अभी ट्राई करें कि सचिन की नेक्स्ट
हाँ
क्वेश्चन पे
नहीं,
चलें?
मतलब रिकरेंस लिख सकते हैं बस, और तो कुछ नहीं.
हाँ ठीक है, दिस मैचिंग फॉर दिस मैचिंग क्वेश्चन you can basically do like this, that if your pn path
हाँ.
graph on n vertices, so there will be n minus 1 edges. Okay, and v1 2 and so on, vn minus 1 vn. So here let's assume in the matching we have this, then we cannot have this next one. Okay, so this is vn minus 2, and now if we have already taken this, then we cannot take this. Then now we have to find what is
N minus 2.
n minus 2. So it will be like the number of matchings
In n
as
equal to, Sn equal to.
Sn is equal to, that will be Sn minus 2 plus. So if we don't, if we take this, then we cannot take this. Then we have to basically find a matching here. Okay. Plus if
Plus if
we
we
if we
don't take this,
don't take this, then we just have to find a matching here.
right?
Sn
Sn.
minus 1. And what will be the base conditions?
Yeah,
For
so
example, if you have
S1.
S1, if you only have one vertex, then one vertex means there is no edge. So S1 will
0.
be 1 because empty set will be there. Okay. And what about S2? S2, that will be, I think, 2. Okay. So now we can find what will be S3. Let's check from this formula what will be S3. S3 will be S2 plus S1. So
3.
that should be 3. Is it correct? Like if you have, let's assume if you have V1, V2, V3, then you can take empty matching you can take, plus if you take these, that's it. 3. Yes, 3 is correct here. Okay. Then I think this will work, Sachin. This
Yes.
works.
Yes, it seems like it is working.
Okay, okay. So from here, if we find what is
Next number will be
S8.
5. We can just keep on
So
adding the consecutive numbers.
okay, so basically next will be 5. Okay, so it's like Fibonacci series, huh?
Right, right, right. Yes,
Okay,
it's
so Fibonacci series we are getting. Okay, if we find for Pn, what will be the number of matchings? That is Sn, and this series is basically we are getting this series like, okay, so this series will be, you can see 1, then 2, then 3, 1, 2, 3, then 5, then 8, then 13, and then
21.
21, and then 34. Nice. And this is what the question is asking. So you can see it is like this is basically P1 for P1. Okay. And this is 1, 2, 3, 4, 5, 6, 7, 8. Yes, this is for P8. Okay. So the answer will be 34. So this is another way. I think this is smart way. But yes, this is actually really smart way, and this makes the question beautiful also. So this is really a very, very nice, beautiful way. So for
Right.
path graph on n vertices, we can find the number of matchings by this recurrence relation, where what is Sn? Let me just quickly write it. Okay, where Sn is number of matchings of Pn. Okay, that's it. Is there anyone here in the chat? Let me know. Is there anyone here who solved this question correctly by the second method, by the recurrence relation method? Is there anyone here during the exam in those 3 hours? You solved this question correctly using this recurrence relation method. Also, is there anyone here who solved this question correctly using our first method, that was brute force? And how many of you did it wrong? Basically, these are the 3 categories. I think, Sachin, this recurrence relation, and we have studied recurrence relation in a very nice way, in a very detailed way. You can just search on the YouTube, you can put recurrence relation go classes. A playlist will come.
Yes,
In
yes.
that playlist, I think almost, I can say, a variety of recurrence relation questions I have taken. So
Yes,
you can just
even
watch it.
some foreign university students also commented there in that
हाँ,
playlist.
वो
Yes, I
प्लेलिस्ट के
remember.
ऊपर व्यूज भी काफी अच्छे थे, मतलब
हाँ.
गो क्लासेस की शायद वो आज से शायद 1 या 2 साल पहले वो हाईएस्ट मतलब व्यूड प्लेलिस्ट थी। उस प्लेलिस्ट के ऊपर उस टाइम पे व्यूज काफी थे। अब तो यूट्यूब ने क्या किया कि उस प्लेलिस्ट को कोर्स में कुछ कन्वर्ट कर दिया और वो व्यूज नहीं दिखते अब उसके ऊपर। ठीक है,
ओके।
यूट्यूब ने उस प्लेलिस्ट को कोर्स में कन्वर्ट कर देता है वो। तो अब
हाँ।
उसके ऊपर व्यूज नहीं दिखते, लेकिन वो आज से 1-2 साल पहले जब वो प्लेलिस्ट के फॉर्मेट में थी तो वो हाईएस्ट व्यूड मतलब उस टाइम पे, और कमेंट्स भी आते थे फॉरेन फॉरेन यूनिवर्सिटी के स्टूडेंट्स के, आउट ऑफ इंडिया स्टूडेंट्स के कमेंट्स भी आते थे उसके ऊपर। सो द रिकरेंस रिलेशन प्लेलिस्ट यू कैन फाइंड ऑन द गो क्लासेस यूट्यूब चैनल, जस्ट पुट ऑन द यूट्यूब, यू सर्च रिकरेंस रिलेशन गो क्लासेस, playlist will come, and there you can study recurrence relation in discrete mathematics. A variety of questions we have done, gate pyqs we have done, some foreign university assignments and some questions we have done. And this really, this question, this particular question also we can solve using recurrence relation method. The answer will be 34. चैट में किसी ने बोला है क्या कि उन्होंने इस क्वेश्चन को सॉल्व किया है रिकरेंस रिलेशन से? इज देयर एनीवन हियर?
और
ओके,
नहीं, आई थिंक इट इज रियली टफ टू थिंक लाइक दिस इन एग्जाम बिकॉज वी आर नॉट मच हैबिचुअल। सो
बट
किसी ने, हाँ।
but I hope that students understood the both the methods, the method 1, method 2, both the methods. I hope you understood, and the answer will be 34. This was NAT question. Now we can go to the next question in discrete mathematics. There was question number 3. This was
टू
MSQ coloring question, right?
यस।
Two colorable question. So for this two colorable question, what is the answer? Let's see. First, let me tell you what was the given information. The given information was that the graph given G is a two colorable graph. Okay, this was already given that G is a two colorable graph. Okay, a graph is given to you, which is actually graph is not given. They are saying that let G be a two colorable graph, and they are just asking which statements are true statements. Okay, so the question is having these options. Like the first option was, if G is a two colorable graph, then G can have odd cycle. G can have odd length cycle. G can have odd length cycle. Okay, another option was G can have even length cycle. Another option was, क्या ऑप्शन था एक, हाँ, टाइम कॉम्प्लेक्सिटी, राइट? चेकिंग इफ अ ग्राफ G is too colorable or not.
हाँ, टाइम कॉम्प्लेक्सिटी वाज गिवन टू बी v plus e in one of the option.
Checking if a graph is too colorable or not can be done in order of theta, I think theta या order जो भी, order
थीटा,
of
आई रिमेम्बर करेक्टली।
V plus E. Okay,
इट वाज थीटा,
so
आई रिमेम्बर 100%।
एक्चुअली मतलब थीटा तो नहीं होना चाहिए, क्योंकि जो ग्राफ है उसको हो सकता है कि अपन मतलब शुरू में ही मतलब वो हो जाए। सचिन, जैसे हम चेक करना शुरू करते हैं, हमें सारे वर्टिसेस चेक करने की जरूरत ही नहीं है, क्या पता वो शुरू में ही मतलब एक थ्री लेंथ साइकिल बन जाए, और तो
हाँ
मतलब
नहीं,
थीटा।
काउंटर एग्जांपल तो हो सकता है, बट वो वर्स्ट केस ही होगा, मतलब
हाँ,
देखो।
शायद वो ऑप्टिमल एल्गोरिथम का पूछ रहे थे। सो
वर्स्ट केस
बेसिकली दिस
होगा।
ऑप्शन सी वाज चेकिंग इफ अ ग्राफ इज टू कलरेबल और नॉट कैन बी डन इन ऑर्डर ऑफ V plus E by optimal algorithm. And the last option, that was same
सेम बट
same
ई
option.
लॉग बी।
Yes. Okay, same option, same option theta कितना सचिन?
ई लॉग
E,
बी, ई लॉग बी।
E log V. Okay, same option but theta E log V. Okay, so for this question, what is the answer? This was actually a very easy question. So for this question, the answer will be option B. G can have even length cycle. Option A is not correct, and option
ऑप्शन
C
सी।
is correct. Option C is correct, and option D is not correct. Okay, so for this question, actually, the answer will be option B, comma C, that G can have even length cycle, and to check whether the graph is too colorable or not, the optimal algorithm can do it in the V plus E time. Okay,
तो
so
एक्चुअली Yeah,
Yes,
so
Sachin.
basically, it will be done by DFS. So DFS has the application of finding the cycle, and DFS time complexity is B plus E. So we can easily count the number of vertices in the linear time. So basically, it will be done by DFS, that B plus E time DFS will be taking to find the cycle, because it is a very popular application of DFS to find the cycle in a graph. And DFS time complexity is B plus E. So that's why this algorithm will be taking B plus E for in general case, like for any graph. In worst case, we will be applying DFS, and it will be taking B plus E. So
Actually, in this particular question, why we are finding the cycle? Because the question is talking about two colorable graph. So let me tell all the students that two colorable graph is nothing but bipartite graph. Both are same. Bipartite graph is same as two colorable graph. And bipartite graph definition, if you remember, bipartite graph is a graph without any odd length cycle. Bipartite is a graph in which every cycle is even length cycle. So you can see, if you want to check whether a given graph is two colorable or not, then all you have to do is just you check, does it contain odd length cycle or not. If there is no odd length cycle, then the graph is two colorable. If the graph contains odd length cycle, then the graph is not two colorable. That is the reason Sachin is giving the explanation that we can detect odd length cycle in a graph using the algorithm DFS. Okay, you have studied in the data structure,
algorithm.
there you have studied. There is another method also, Sachin, from the graph theory point of view. So if a graph is given to you and you want to just check whether it is bipartite or not, then what you can do, you can just take a vertex, you give it red color. You are
Right.
basically checking, is it two colorable or not. So you just take a vertex, give it red color, then all the adjacent vertices you just give blue color. Okay, all the adjacent
Mhm.
vertices. Now what you do, now you just check for each, you just go to every vertex and you check its neighbors, are they having the same color as this vertex. If if this vertex and it's at least one of the neighbor has the same color, then it simply means that it is not too colorable.
Not too colorable.
Okay, so basically what we are doing, ultimately what we are doing, we are going to every vertex. So order of v time complexity. Okay, we are visiting every vertex, we are checking by taking every vertex. Okay, one by one we are taking every vertex. So order of v time complexity, and for every vertex we are checking its neighbors. For a particular vertex we are checking its neighbors. So total, we are checking all the edges, because for a vertex we are checking all the neighbors. So in the overall graph we are checking all the edges, and also we are checking all the vertices. So that is the reason order of v plus order of e, that is basically order of v plus e time complexity. This is another method. If you don't remember DFS, BFS, DFS, if you don't remember, then this is another method, just purely in terms of graph theory. Okay,
Right. Right.
so but the better method, I can say, if you search on the Google how to check whether a given graph is bipartite or not, then you will see DFS, this algorithm you will see. Okay, this procedure you will see. Okay, so this question, Sachin, I think easy.
Yes. Yes. It was, I think, easy.
What do you think, students? Let me know this question, should I mark it easy, moderate, hard? So I think this question was quite easy. I can put it in the easy category, because we already study all these concepts like two colorable graph, that is basically two colorable two colorable graph. This is another name, this is exactly same as bipartite graph. Bipartite graph. Okay, both are synonyms. And bipartite graph, that simply means graph without odd length cycle, graph without any odd length cycle. Okay, or I can say that graph in which every cycle is even length. Okay, so based on these concepts, these are standard concepts, so you can solve this question. I think this was a easy question, you can do it. Okay, so these were discrete mathematics question. The last discrete mathematics question, let me just solve, that is from combinatorics. The question was asking that you have 4 by 4 matrix, you have 4 by 4 matrix, of zeros and ones, zeros comma ones, and the question was asking the number of such matrices in which every row, every row and every column, every row and every column has even number of ones. Okay, so this question, actually this was a really interesting question, and let me tell you how you can solve it. And after seeing the solution, you will really feel it that this was really a wow question. But I can definitely say that it was not an easy question, because this, the solution may not click, I can say. Okay, so let me just tell you quickly the method. The method, Sachin, I think what was the answer? 3 by 3,
2 power
so
9.
2 power 9, that is basically 5 1 2. So let me tell you the answer. The answer will be 5 1 2. And the method is actually very simple. See, you have a 4 by 4 matrix. Okay, and you want that every row should have even number of ones, every column should have even number of ones. So what you can do, let me tell you, you can see, for a moment forget about the last row and the last column. Okay, for a moment forget about the last row and last column, last row and last column, you forget. Now if you see the remaining, if you see this remaining 3 by 3 matrix, okay, if you see this remaining 3 by 3 matrix, now here you can put anything. See, very interesting point, that here you can put anything you want. Okay, anything you want. You can put 0 or 1, you can put 0 or 1, you can put 0 or 1. Here also you can put 0 or 1, here you also 0 or 1, 0 or 1. 0 or 1, 0 or 1, 0 or 1. Whatever you want, you can put. Now, whatever you want, you can put it. Then, for these entries, now we don't have choice. Okay, for example, notice here, if you are putting, let's assume, two ones, then here you have to put 0. Here, if you are putting three ones, then here you have to put 1. If you are putting here no 1, means all are 0, then here you have to put 0. Okay, similarly, here if you are putting in this column, in these three entries, let's assume you have two ones, then here you have to put 0. If you have here no 1, then here it will be 0. Here if you have, let's assume, 1 1, then here you must put 1. Okay, and similarly, whatever, like for example, if you have here three ones, then here you must put 1. I hope you are getting the point. So you can see in this 3 by 3, here you can put anything you want. Then for these, now we have only one choice, or I can say, either I can say no choice, or I can say, either I can say there is no choice. And when I say no choice, it simply means only one choice. Okay, similarly, here also, now either I can say there is no choice, or you can say that there is only one choice. Okay, so finally the answer will be what? Here you can put whatever you want to put. Okay, so you can see how many total cells are there. Total 9 cells we have. So 2 power 9, that will be 512. This will be the answer. Okay, so this was really an interesting question. But if it does not click, okay, see, in the 3 hours of the gate exam, this method, if this does not click, then it will become a complicated question. Sachin, what's your opinion? So what do you think, students? Easy, hard, or moderate?
I think it was a moderate to tough question because getting click that this method is not very intuitive in exam according to me. So let's just see what others are saying. Has anyone solved this question?
I can say it was very tricky, I think.
Yes, yes. Hard for
Is there
me.
anyone here who solved this question without this method, without brute force also? Like, of course, you, if you do brute force, then how can you get like this calculation? It will be very hectic if you do brute force, right? So tell me, is there anyone here who solved this question during the 3 hours of set 1 gate CS 2026? किसी ने किया था?
I think mostly people are saying skipped it, and some people are saying it was hard.
It's really tricky. It's really
Yeah.
tricky. I also want to know one thing. Other than this method, I told you one method. Other than this method, did you use some other method to solve this question and did you get the correct answer in the GATE exam? Is there anyone here? Please let us know. So for this same question, actually, for mn, what for n by n matrix, what it will be?
This will be 2 power m minus 1 into 2 power n minus 1, I think. Achha,
For
n cross n. Okay.
so for n by n matrix, the answer will be what you can see. This is n by n matrix. So what you do, you can put anything in this n minus n. Okay, this is your n minus 1 by n minus 1 part. Here you can put whatever you want. Okay, 0 1 0 1. Okay, 0 1. Okay, here you can put whatever you want. Then in here there will be only one choice. Okay, so here or here there will be only one choice. So finally, for n by n, the answer will be, for n by n matrix, the answer will be, how many cells we have? N minus n whole square. So it will be 2 power n minus 1 whole square. Okay, 2 power n minus 1 whole square. So this will be the answer. Okay, I hope you understood. So that's it. These are the discrete mathematics questions. Now we have done the analysis of theory of computation question, discrete mathematics question. Sachin, next, operating system.
Yeah, okay. Can you take one more subject before that? Like your subject? I think DBMS.
Okay, just give me a second.
Okay.
See, we are providing the answers also, the analysis also, and please press the like button if you are finding this session helpful.
Someone is asking दीपक सर के concepts का राज क्या है?
मैं थोड़ा अच्छा सा कुछ रिप्लाई सोच लेता हूँ, थोड़ी देर बाद में बताऊंगा. अभी एकदम एग्जैक्टली टॉप ऑफ द माइंड कुछ ऐसे सरकास्टिक रिप्लाई आ नहीं रहा, मतलब थोड़ा कुछ सोचता हूँ. हाँ सचिन, नेक्स्ट सब्जेक्ट. अभी आई जस्ट वांट टू नो वन थिंग. Actually I think we are giving the detailed analysis, so that's why maybe we are taking time. I have taken too much time. So Sachin, पहले सीधा क्या आंसर देख के चलें, ऐसा कुछ करें क्या? Let me know,
हाँ ऐसा
all
भी
the
कर सकते
students.
हैं. So let's just ask the students. I think इजी क्वेश्चंस का आंसर देके चलते हैं और कोई
कोई
कंट्रोवर्शियल या टफ
कोई
क्वेश्चन.
तगड़ा अच्छा क्वेश्चन होगा तो उसका एनालिसिस देते हैं.
हाँ.
ठीक है, वरना बाकी क्वेश्चंस का आंसर देते चलते हैं. लेट
हम्म.
अस नो इन द चैट, यू कैन लेट अस नो कि क्वेश्चंस का डिटेल्ड जैसे एनालिसिस हम दे रहे हैं अभी तक, जैसे टीओसी और डिस्क्रीट मैथ्स के क्वेश्चंस का वी हैव प्रोवाइडेड यू द कंप्लीट एनालिसिस. डू यू वांट दैट और डू यू जस्ट वांट अस टू गो थ्रू द क्वेश्चंस? Easy questions we just give you the answer, and for the tough question maybe we can provide you the analysis. Okay, I think let's provide the answers, and only for the tough questions, like there was a question in the foo bar. Okay, so those type of questions we can discuss in detail. Okay, so which next subject, Sachin?
Yeah, so DBMS could be the next subject.
So let's consider the DBMS questions. I will provide you the answers quickly. Okay, and maybe in some other session I will provide you detailed solutions. Okay, don't worry. So right now let's focus on the answers only. So there was a question, NAT question, super key question. So for this super key question, let me just write what was the given data. The given data was that you have a relation with 4 attributes and only 2 candidate keys are there. Only 2 candidate keys we have. These are AB comma AC. And the question is asking number of super key. This was really a dumb question. Means this was very traditional and very easy question. So the answer for this question will be 6. Okay. So this was quite easy question. You already know. You will find you can apply the inclusion exclusion principle. Okay, so okay, just because of AB there will be 4, because of AC there will be 4, and minus because of ABC there will be 2. Okay, so the answer finally will be 6. Next. So I think this was very easy question, Sachin.
Yes. So next was that
This was,
projection question. Projection question.
yes, this was very easy question. How many of you did it?
Yes.
Really dumb level question? Nothing. This was simply, I can say, extremely easy question. I think the easiest question in this paper. And the next question, the question 2, that was MSQ decomposition question. Sachin, प्रोजेक्शन मतलब
Yes.
डिकम्पोजिशन वाला है ना?
हाँ, मतलब वो था ना जो रिलेशन आर यू वी, जिसमें एक एट्रीब्यूट कॉमन था, वी
हाँ
वी
हाँ,
कॉमन।
ओके ओके ओके, सो टीआरसी, बेसिकली टीआरसी प्लस रिलेशन अलजेब्रा क्वेश्चन.
वो पाई ऑपरेटर प्रोजेक्शन वाला ही, उसको प्रोजेक्शन
हाँ
बोलते हैं
हाँ, यस यस यस.
ना। हाँ।
Okay, so basically there was a question which was MCQ question. It was MCQ question, 2 mark question, and the TRC query was given. So let me tell you, the TRC query was given. There were two relations. First of all, there was a relation R. इसके attributes क्या थे? A relation R was there. A relation S was there, XY. And I think here it was AB.
जस्ट अ सेकंड, आई एम टेलिंग यू।
So I think something like this. And given TRC query was given to you. The TRC query that was given to you, that was basically tuples, tuple U such that
आर
PQ.
का पी क्यू था, पी क्यू।
R का PQ था. Okay, okay. So R का था PQ. Now this TRC query was given to you where you are having tuples such that there exist V, there exist W, such that the question was saying, I think, there exist V comma W such that UV should belong to R and UV should belong to R and VW should belong to S. Okay, that's it. I think this was the query. This was the TRC query. So there exist V comma W such that UV belongs to R, VW belongs to S, and this type of U we are taking. Okay. So now the equivalent, the question was asking what is equivalent relation algebra query. Equivalent relation algebra query. And let me tell you the correct answer. There were 4 options, of course. Let me tell you the correct answer. The correct answer will be that you are basically pi, you are basically taking this P. Okay, you are taking P such that R conditional join S, and this condition we have that R dot Q should be equal to S dot X. Okay, that's it. Okay, so this was the answer. I think this was easy question. What do you think? Was it easy, moderate, hard? I think this was another very easy question, not hard, not
यस।
moderate. This was really easy question. This was a 2 mark question, easy question. Okay. Let me just quickly tell you the logic actually, because in this TRC query, you can see what we are doing. This TRC query is basically saying that those U I want, those tuples I want, such that there exist V, there exist W, and UV should belong to R and VW should belong to S. Okay, so here basically it's like R you have, S you have. Okay, in R you have PQ, in R you have PQ, in S you have XY. Okay, and basically it is saying that we want those U such that UV should be here and VW should be here, and then we want this U in the output. Okay, so very easy. So basically you can see that these must be equal, correct? and in the output we want to project rp. So it's like we are projecting r dot p, we are projecting this p, we are projecting, and we are taking conditional join of r comma s, where r dot q is equal to s dot x. Okay, so this was the simple logic, and this was an easy question. Did you do it correct? Anyone here who did it correct? This particular question. DBMS questions were very easy. All the DBMS questions were very easy. So far, we have done two questions. Super key question, very easy, very trivial question. And this relation algebra and TRC question, this was again very easy question. Okay, let's see the next question.
Yes. So next question was that BCNF 3NF question.
So it
So
was MSQ question, and it was decomposition, decomposition plus dependency preservation question. Dependency preservation question. Okay. So in this question, there were four options. The question was asking, there was option A, that always possible, it is always possible. Basically, there was an option which was saying that 3NF plus dependency preservation. 3NF plus dependency preservation. This is always possible. This is always possible. Yes, this option is correct. Okay. For every relation R, we can decompose the relation R into 3NF, which is also dependency preserving decomposition. So 3NF plus dependency preservation, this is always possible. And option B was that BCNF plus dependency preservation may not be possible. May not be possible. This option was also correct. Dependency preservation plus BCNF, this type of decomposition may not be possible for some relations. Okay. Next, another was 2NF plus dependency preservation is always possible. Always possible? Yes, this is also always possible. And I think another was 1NF plus dependency preservation may not be possible. May not be possible. Of course, this was false. I think this type of options were there. Sachin, ये options सही है क्या?
हाँ, I think सही है. एक 1NF और था. हाँ
एक 1NF का तो लिख दिया ना.
हाँ हाँ, sorry. हाँ
1NF, 2NF,
हाँ हाँ,
BCNF,
right.
3NF. This type of options were there. Okay, so this type of question was there. See, let me tell you, some student is asking in the chat, so let me tell you. For every relation, you can decompose that relation into 3NF with dependency preservation as well as lossless. But there are some relations for which it is not possible to decompose into BCNF with dependency preservation. It is always possible for every relation to decompose into BCNF with lossless. Means for every relation, BCNF plus lossless, this is always possible. For every relation, 3NF plus dependency preservation plus lossless, this is always possible. For every relation, 2NF plus dependency preservation plus lossless, this is always possible. For every relation, 1NF plus dependency preservation plus lossless, this is always possible. But for some relations, BCNF plus dependency preservation, this may not be possible. For some relation, it is possible. For some relation, it is not possible. Okay, this is the concept. You can search on the YouTube, you can search 3NF, BCNF, decomposition, Go classes. Okay, just search it and you will find a lecture. You can watch it for complete understanding of decomposition plus lossless plus dependency preservation. Basically, this complete relationship you can understand in that lecture. Okay, on the YouTube, you search BCNF, decomposition, Go classes. Okay, we have already seen. And this, Sachin, this as it is question, let me tell you, this was there in All India mock test, last All India mock test, the final AIMT before this GATE 2026 exam. In that paper, as it is question is there.
Wow.
Okay. So is there anyone here who remember in the final AIMT this exact as it is question was there? And let me know, was it helpful? Okay. So I think these are the DBMS questions. Any other DBMS question?
Any other DBMS question? Do you remember? Anyone in the chat section can tell us?
So एक तो हो गया सुपर की,
हाँ,
एक हो गया ये
वो BCNF, और वो एक हो गया वो प्रोजेक्शन वाला,
हाँ
TRC वाला।
3 questions.
हाँ,
Was there anything else? See, some students are saying for this previous question, some students are saying कि 1NF के साथ नोट नहीं था, 2NF के साथ नोट था. ओके ओके, तो मैं थोड़ा सा इसको बस चेंज कर देता हूँ, शायद ऐसा कुछ, तो बाकी ज्यादा फर्क नहीं पड़ेगा. 2NF में ओके कुछ ऐसा था कि CD 1NF में था ऑलवेज पॉसिबल प्लस डिपेंडेंसी प्रिजर्वेशन always possible. So yes, this will be correct. Okay, and this may not be possible. Here it was may not be possible. Okay, so this will be wrong. Okay, don't worry, you understand the concept. I'm very sure you understand the concept, so you don't have to worry. Sijin, there was another question, FD
yeah,
question, functional
functional
dependency.
dependency question.
This was also MSQ question. But it's too many MSQ questions, like almost every question is MSQ question.
Right,
So
right.
functional dependency question. And this functional dependency question, I'm telling you, this was very easy question. And I think as it is, we have seen this question in our test series multiple times. I think this question you may have seen multiple times in our test series and in our mock test, in our quizzes. Okay, so the question was basically 4 options were there. The question was asking which is true, which is true. Okay, for this question, 2 options were correct. Let me tell you, which is true, and the options were something like that. PQ, one option was PQ can determine R. Then, okay, this was one of the option that if PQ can determine R, then P can determine R or Q can determine R, something like this. Okay, this type of option was there. So of course, this option is wrong. Okay, this option was there. This is wrong. What about another option? One more option was there that क्या था? एक ऑप्शन था कि if P determines Q, R determines S, then PR determines QS. Okay, so this option was there. This is true. Another option was if P determines, क्या था सचिन, कुछ याद आ रहा है? P determines R. हाँ, if P determines R, then PQ determines R. एक और लास्ट ऑप्शन क्या था? Anyone? What was the last option? So only 2 options were correct for this question. Anyone want to tell me what was the last option? एक और ऑप्शन था सचिन, याद आ रहा है क्या?
हाँ, नहीं याद तो नहीं आ रहा।
लेकिन वो गलत था,
नहीं था।
जो भी एक और
हाँ,
ऑप्शन था. एक सेकंड, हाँ किसी ने बताया है कि इफ पी क्यू डिटरमाइंस आर
अच्छा, उल्टा था।
एंड पी डिटरमाइंस आर, देन क्यू डिटरमाइंस आर. ओके, सो कुछ ऐसा सा था. ठीक है, बेसिकली द फाइनल आंसर, लेट मी टेल यू दैट ओनली 2 options were correct. These two and these are false. Okay, so 2 options were correct, only these two properties were correct, and the remaining two were false. So in this question, actually 2 options were correct, I can say. Okay, I remember 2 options were correct and 2 options were false. Okay, PQ determining R, P determining R, then Q. ये था, yes. Okay, so don't worry, 2 options were correct and 2 options were wrong. That's it. Okay, you just have to remember this point. Now देयर वाज वन मोर क्वेश्चन एक्चुअली सचिन, एमएसक्यू क्वेश्चन था जिसमें फॉल्स पूछा था।
डीबीएमएस का।
किस कोई तो क्वेश्चन था किसी सब्जेक्ट का
हाँ
जिसमें फॉल्स
तो
पूछा था, और दो ऑप्शन ट्रू थे, दो ऑप्शन फॉल्स थे, यही था।
हाँ राइट राइट।
शायद
ये
मेरे ख्याल से
नहीं,
ये
ये नहीं
फंक्शनल
था।
डिपेंडेंसी वाला ही था, या कोई दूसरा था।
दूसरा था जिसमें हाँ
देयर
फॉल्स
वाज अ
पूछा था।
एमएसक्यू क्वेश्चन, एनीवन रिमेंबर्स? देयर वाज अ एमएसक्यू क्वेश्चन जिसमें फॉल्स पूछा था। दो टू ऑप्शंस वर करेक्ट, टू ऑप्शंस वर रॉन्ग. This type of MSQ question was there, I remember, and there was only this type of one question was there. Like there was no other question where the question was asking for false, but there was only one question where it was asking for false. शायद ये ही होगा शायद,
ओके।
मतलब जहां तक मुझे याद आ रहा है।
वन ऑफ द स्टूडेंट इज आल्सो सेइंग कि।
अच्छा, बैंकर्स का क्वेश्चन सचिन उसमें था फॉल्स, हाँ हाँ।
अच्छा
जो
हाँ हाँ
ऑपरेटिंग
हाँ।
सिस्टम में बैंकर्स एल्गोरिथम का क्वेश्चन है उसमें फॉल्स पूछा था।
राइट।
Okay, okay.
हाँ हाँ।
So these are the DBMS question. If any other DBMS question is remaining, please let us know. Any other theory of computation question, any other discrete mathematics question, any other operating system, sorry, any other
डिस्क्रीट मैथमेटिक्स।
TOC, discrete maths and DBMS. Any other question is remaining, let us know. सचिन, नेक्स्ट, अभी ऑपरेटिंग सिस्टम का ले ले।
ओके। सो नाउ लेट
मैं,
मी शेयर माय स्क्रीन।
हाँ हाँ, एक सेकंड, एक सेकंड, चेंज, ठीक है सचिन।
ओके।
Now we are going to discuss operating system questions also. Disk question was also there. Okay, I will discuss. हाँ, एक डिस्क का क्वेश्चन भी है, आई विल डिस्कस, डोंट वरी गुरु, डिस्कसिंग इट। ओके, एक बार ऑपरेटिंग सिस्टम, लेट्स डिस्कस ऑपरेटिंग सिस्टम, देन वी विल डिस्कस द डिस्क क्वेश्चन आल्सो।
यस। सो लेट्स जस्ट डिस्कस ऑपरेटिंग सिस्टम क्वेश्चंस। So let's start with one question which was related to Banker's algorithm. So question number one. Just a second.
पेन की साइज
क्वेश्चन।
थोड़ी ज्यादा है।
हाँ
थोड़ा वो,
वही। वो मैंने कम किया
हम्म,
अभी जस्ट। एक मिनट और कम करता हूँ। पता नहीं कैसे
नहीं उधर से पेन ले ले सचिन, तूने वो ले रखा है क्या कहते हैं, शाही वाला पेन ले रखा है उधर साइड में, एक पेन, पेन का भी है।
नहीं मैं इसी को यूज करता था।
अच्छा अच्छा, ओके ओके, ठीक ठीक ठीक।
ओके। So the question was that which of the following is false? It was MSQ question and they were asking for the false, right? So let's just like write the options. So first option was that Banker's algorithm. By the way, in almost all the AMTs, we had some question from Banker's algorithm, and finally it came into GATE examination this year. I somehow had intuition that they might be keeping some Banker's algorithm questions this year. So that's why. Do you remember that many times I think out of all AMTs, out of 6 AMTs, maybe 3 times I have put this Banker's algorithm questions, or maybe 3 to 4 times, right? So the question was related to the Banker's algorithm. It was saying the Banker's algorithm prevent deadlock, something like this, right? Prevent deadlock. The next option was safe state. Safe state means there is execution order possible. Execution order possible without deadlock, right? Without deadlock. There was another option which was just a second. Can you tell me the options?
सचिन, एक ऑप्शन था कि बैंकर्स एल्गोरिथम प्रिवेंट्स डेडलॉक, हाँ ये तो फॉल्स हो गया। सेफ स्टेट मींस द प्रोसेस कैन एग्जीक्यूट विदाउट डेडलॉक, ये भी सही है।
एंड होल्ड एंड वेट वाला था एक। होल्ड एंड if we remove hold and wait, then deadlock will not be
कैन बी
possible.
प्रिवेंटेड,
हाँ, something like this.
डेडलॉक कैन बी प्रिवेंटेड इफ वी डिसअलाउ होल्ड एंड वेट,
हाँ, deadlock can be
प्रिवेंटेड इफ वी डिसअलाउ hold and wait.
There was one more option.
एक था असाइनमेंट एज का कि
हाँ,
रिसोर्स अलोकेशन ग्राफ में,
right.
इन रिसोर्स अलोकेशन ग्राफ आरएजी लिख दे। हाँ, इन
Resource,
रिसोर्स अलोकेशन ग्राफ असाइनमेंट एज इज फ्रॉम प्रोसेस टू रिसोर्स। असाइनमेंट एज इज फ्रॉम प्रोसेस टू रिसोर्स, ये भी फॉल्स था।
yes, from process to
टू
resource.
रिसोर्स।
So since they were asking for the false option, so let's just see all the options. Banker's algorithm prevent deadlock. So obviously it doesn't prevent deadlock. It just check whether the current system is in the safe state or not, right? And if it is unsafe state, then it may lead to deadlock. It cannot prevent deadlock, right? So that's why it was false option. Safe state means there is execution order possible without deadlock. So this is true, right? So, I mean, that is the definition of safe state. So this is true. Deadlock can be prevented if we disallow hold and wait. Since these are the four necessary conditions, hold and wait and circular wait, and these are the four necessary conditions. Hold and wait is one of the necessary condition. If we disallow that, then obviously deadlock can be prevented. So that's why this is also true. In resource allocation graph, assignment age. So basically, let's suppose this is a resource which is having 2 3 instances, and there are, like, let's suppose P1 P2 two processes. Now if some of the instance has been already assigned to a process, let's suppose P, then this is basically like this. Okay, it makes it very clear that this particular instance has been assigned to this process. So basically it is from resource to process. But in the options, the options were given in such a way that it was written that it is from process to resource. So that's why this option is also false. And since they're asking for the false options, so that's why I can say A and D currently, these are the two correct answers. So what do you think the difficulty level of this question? I think it was easy question, right? It was easy question just based on the definition. So you can expect these kind of questions. It was easy question only. Now let's just see next question, operating system questions. Question number 2 from operating system. Just tell me what was the next question. So see, there was a question related to FCFS, right? FCFS. So they were saying that there are like two type of processes, process P1, process P2, which are having some accumulator and some C, I mean the short form of
कंट्रोलर,
C
एक एक कंट्रोलर थी, दूसरी का अजीब सा नाम था कुछ
controller.
मतलब बेसिकली टाइप ए टाइप बी, दो
हाँ,
टाइप की प्रोसेस थी।
right.
और दो टाइप की प्रोसेस थी, टाइप ए और टाइप सी।
Yes. So type A processes was coming at time t equal to 10, then 20, then 30, then 40, and then 50. Type C processes was coming from time t equal to 11, then 22, then 33, then 44, and then 55. And type A processes was taking 6 unit of time, 6 millisecond or 6 seconds, I think. Okay, so 6 seconds unit of time.
6 नैनो सेकंड, वैसे तो क्या फर्क पड़ता है, हाँ कुछ
हाँ.
ऐसा ही था शायद।
Okay. Yeah, so let's just keep it 6 seconds, or 6 unit of time basically they were taking. And type C processes were taking eight
ना,
eight unit of time.
एट एट था।
Huh,
यस यस।
8 unit of time. And they were asking the average waiting time. So what was your answer? Average waiting time. So if we calculate average waiting time, then we can easily see that the first process is starting at t equal to 10. Okay, so there is no, like, no process, or there is like, for this question the earlier processes are irrelevant. So you can start from t equal to 10. So from t equal to 10, the first process is starting, and then A is coming first, right? And then after that, C is, I mean, at t equal to 11, C has already come. So let me just call it A1, A2, like this, right? A3, A4, A5, and similarly this is C1, C2, C3, C4, C5. Okay. So first A1 will be running, and A1 will be running, you can say, from 10 to 16. And then since like, while A1 is running, C1 has already come. And since it is first come, first serve, so that's why, like, C1 will run, right? So C1 will run from 16 to 8, 8 unit of time, which is 24. And then A2 will run. So the execution order is something like this: A1, and then C1, then A2, and then C2, and then A3, and then C3, like this, right? Now, if we check the waiting time for C1, so C1 has started running at 16. So that's why the waiting time for C1 is 5, right? And for A1, obviously, there is no waiting time. But waiting time for A2, since A2 has come at 20, but it is basically waiting till 24. So the waiting time for A2 is basically 4, right? So now if you keep on doing it, you will notice that there is a pattern in a sense that here it is 4, then the next number that will come is 8, and similarly here the next number will come. uh, I think this was 8 and this was also 8, I think.
ये 8 है, हाँ सही है
हाँ,
सचिन, सही है। ये ऊपर के
then
जो टाइप ए प्रोसेस हैं, दे आर बेसिकली हैविंग
4
द
multiple.
वेटिंग टाइप ऑफ 4, 8, 12, 16,
हाँ,
and the type C processes, they are having like
yes,
3 gap. So 5, 8, 11, the pattern is basically
yes,
5, 8, 11,
and
14,
14 and
and then
17.
17.
Yes. So if you add all of this and then divide by 10, I think if you add all of this, it will be 95. If you divide by 10, it will be 9.5. So 9.5 is the correct answer.
Actually,
Uh,
in this question, one more information was given just to make sure that there is no ambiguity. So there was one more information in this question. They have written that this process A1, the type A process at time 10, it will start at time 10. So it is arriving at time 10. Also, it will start at time 10. This type of
Right,
basically extra 1 2 statements were given just in case.
right, right. So basically, yeah, so it's not in the ready queue, it directly started running at t equal to 10. So 9.5 was the answer. I think this was a little lengthy question if you are calculating all the times. Like if you are observing the pattern, like it is 4 and then 8, then you can observe the pattern, it will be 12 and 16. So actually Deepak has observed the pattern, but I calculated all the numbers because I thought that let's just quickly do it just in case, like just to make sure. So Deepak has, I think, solved only for 2 3 numbers, and then based on those 3 4 numbers, he just observed the pattern that okay, let's just do in the similar way. So this question could be little lengthy if you are finding all the waiting times, but ultimately it was easy question, right? So what's your opinion? Everyone, just tell me what's your opinion. I think it was easy type only, so we can keep it easy.
Actually, by default, I will say that it is lengthy because
Yeah.
it's not, I can say, it's not an easy thing that people will directly observe the pattern in this type of question. So far, if you notice the scheduling question in the PYQ, Sachin, in the scheduling questions in the gate PYQs, we never observe this type of patterns. Actually, this type of patterns, they are never formed, they are never created in the PYQs. In this question, this type of pattern is forming. So but I can say that most of the students, even the toppers, I think they will solve it by the brute force, and that is no problem, that is fine. Overall, this is an easy question, but it is lengthy.
Yes, it was easy but lengthy question. So two questions we have discussed. Third question was related to fork. So let me just discuss the third question. So it was something like this. I think I already written the question. So let me just check that. Yeah. So the question was something like this. For I equal to 0 to I less than 3, I plus plus, if fork equal 0, basically if it is written in 0, then you continue, right? Else break, and then after this also there is a print, printf hello. Okay. So this was the question. This is question number 3. So let's just solve this question. This was a moderate question, I can say. It was not very easy, not very tough, but yeah, this was a moderate question. So let's just solve this question. So see here what they are saying. There is a fork here. So if you remember that fork returns the fork returns the child ID to the parent. So which means actually doesn't matter that whether you have forgotten that fork is returning 0 to the parent or to the child. It doesn't matter. Most probably it should not matter. But let's just see how to solve this question. So what we can do, we can just make something called as process graph. Okay, process graph. So basically, I mean, it's just a fancy name to just understand this thing. So there is a process which is currently running, and it eventually the parent process is running, and then it sees a fork. The moment it sees the fork, it will be splitting it into the two parts, which means it will be saying that I'm anyway running, okay, I'm anyway running, but now the child has been spawned. So there will be a child process. Let me just call it C1 or something like this, right? So there will be a child process that has just got created, and the parent process will keep on running. Okay, the parent process will keep on running. So parent process will see that, okay, fork is actually not zero, because for the parent process it returns a child id. So it will say that, okay, this is false. Since this is false, so that is why it will just break, and then it will just execute the print statement, printf hello. Okay, this is the original parent process. Okay, it will just keep on running. But now there is a child that has been created. For this child, this fork is true. Okay, since it is true, so that's why it will continue, and it will just again run for I equal to 1 also. Okay, for I equal to 0, I'm running like this one. Now it will be running for I equal to 1 also. So basically, now it will say that let me just create one more process, something like this. For I equal to 1, it will be creating one more process. And then it will say that, okay, for me, I will just get exit, and I will just do the printf hello. But the child that I've just created, okay, it will, for that particular child, the fork is basically 0, and then that's why it will continue. Continue means that it will again execute for I equal to 2, and then it will say that, okay, the fork is again there. Then see, the pattern will be repeated. So you can say that here it will be again splitting into two parts. One of the part will be the original child, and another part will be the fork. So basically here you are again doing the two parts. So here it will be the print statement. Here you will say that there is another fork, right? For that I will continue, and but now I is basically 3, so it will get out of the for loop, and then here also it is print. So if you count the total number of prints, it is basically 4 prints, right? So answer was 4. Okay, I'm not going into too much of the detail because there are 65 questions to solve. So, but I hope you got the point that answer was 4. How many of you were able to solve this question in the exam?
For any question, if you want more detailed solution, then just put a comment. After this session is over, just put a comment that for this particular question, we want more detailed solution, more complete analysis. Okay, for any question, if you want, then just put a comment. Okay, we will try to bring the complete analysis of that question to you. Okay, but I hope you understood this question. The answer for this question will be 4.
Okay, so I think many of the students had done this question. So what do you think is the difficulty level of this question? I think it was easy to moderate question only. It was not that tough. And obviously, it was not tough, but for some people it was easy. For some people it was moderate. So let me just write easy to moderate. Okay.
सचिन, जो फोर्क का जो गो क्लासेस का लेक्चर है फोर्क वाला, तो वो
हाँ,
शायद यूट्यूब पे है क्या, वो फोर्क वाला लेक्चर?
फोर्क
फोर्क
वाला
एग्जीक्यूट है ना, इस तरह का एक, अच्छा शायद कोर्स में है
कोर्स में तो है ही। शुरू के कुछ
यूट्यूब।
लेक्चर्स यूट्यूब पे डाले तो थे, फोर्क वाला याद नहीं है कि शायद यूट्यूब पे तो नहीं है।
ओके ओके, नो प्रॉब्लम, ठीक ठीक।
ओके, सो दिस वाज वन ऑफ द क्वेश्चन फ्रॉम ऑपरेटिंग सिस्टम। नाउ लेट मी जस्ट सी व्हाट वाज द नेक्स्ट क्वेश्चन। So in operating system, do you remember anyone? Just let us know. Any other question if you remember? तीन ही आए थे क्या ओएस से?
एक तो शेड्यूलिंग, देयर वाज अ शेड्यूलिंग क्वेश्चन
हाँ,
वी हैव
शेड्यूलिंग हो
डिस्कस्ड।
गया। हाँ,
सिंक्रोनाइजेशन, देयर वाज नो क्वेश्चन फ्रॉम सिंक्रोनाइजेशन। देयर वाज अ पेज मिस, टीएलबी मिस,
हाँ, हाँ, हाँ।
दिस टाइप ऑफ क्वेश्चन वाज देयर।
यस,
एमएमयू, मेमोरी मैनेजमेंट।
राइट,
So
राइट।
basically the question have three things: TLB, comma MMU, comma cache.
Right. So basically, there was one more OS question which was related to TLB, and so basically, let me just write the question. It was saying that you have TLB, you have your page tables also, and you have the cache memory also.
Cache memory.
So by the way, you might recall that TLB is for the cache for the page table, right? So there were like few options. Let me also write the options. I think I have the options with me.
fork जो concept है operating system में, in operating system the fork concept, a student is saying that there is a video on the YouTube from Go classes. Okay, so there you can learn it, and if you are a Go classes student, enrolled student, then already fork, and I think a lot of practice questions we have done for fork in our weekly quizzes, also in our test series also. There are many questions related to fork that we have given. That is the reason the previous question, fork question, that was actually a easy question, and maybe for some students it might be moderate, but it was kind of standard question. A lot of such questions we have seen in the Go classes lectures, test series, and weekly quizzes.
Yes. So, so this question was related to a sequence. So they were saying that tell us a sequence which is not possible. Okay, so they were asking not possible sequence, not possible sequence. Now TLB miss. Once the TLB miss is there, then after that they were asking, is this possible to have page table hit? Let's suppose page table hit, and if page table hit is there, then is this possible to have cache hit? Something like this. Okay, to have cache hit. This is suppose option A. The another option is after TLB hit, is this possible to have page table miss? And after page table miss, is this possible to have, let's suppose, cache hit? Something like this, right? So obviously this is not possible. I mean, after TLB hit, once the TLB is hit, then it must mean that page table must be having the that entry, right? So it is actually we will not be even looking at the page table. So because like I already got from the TLB hit, but if we look at, then there won't be any page table miss, right? So for multi-level paging, maybe we need to look at the page table because let's suppose the TLB is only having the the outermost TLB just for the outermost page table, and after that, if we look at the page table, it will be hit only. It cannot be missed. So this is one of the option which is not possible. They were saying not possible option, right? This is one of the option which was not possible. Another one was that after TLB miss.
एक था जिसमें सारे मिस थे,
हाँ
टीएलबी मिस था, पेज
हाँ
टेबल
पेज
मिस था,
टेबल मिस.
कैश मिस था.
हाँ पेज टेबल मिस एंड देन कैश मिस. एंड एक और ऑप्शन कौन सा है?
एक ऑप्शन है, ठीक है, एक एक जिसमें सारे मिस थे, एक में मिस मिस हिट, वो लिख दिया क्या, मिस मिस हिट.
हाँ
टीएलबी
मैंने
मिस, पेज टेबल मिस, एंड कैश हिट.
टीएलबी मिस, पेज टेबल मिस.
एंड कैश हिट, हाँ ये थे, ये चार ऑप्शन थे.
हाँ ओके या. So
आई थिंक
this D is also not possible because after TLB miss, like after TLB miss, you can go to the page table, right? But if the page table is also missing, right, then it means that there is a page fault. It means the page fault is there. And in case of page fault, obviously you cannot have the same page in the cache. So because in the question also it was clearly written that if some page is moving out from the memory, then the cache is also we are making the cache invalidated, right? We are making the particular entry as invalid entry. So that's why this is also wrong. Okay, so this is also not possible. So they were asking the not possible options. So this is not possible, this is not possible because the last option is not possible because in the question it was clearly given that if you are not having something, okay, some page in the main memory, if you are if you are having the eviction, what we call it, eviction, right? So if we evict that particular page from main memory, then we make that cache entry also invalidate. So that's why this cache hit is not possible in case of page table miss. So that's why this option is not possible. Else, like A and C are the possible options. If we are having the TLB miss, then obviously you can have the page table hit because the page table having the larger number of entry than TLB. So you can have the page table hit, and then finally you can get the data from the cache also. I mean, there is no need to get the data from the main memory. After the page table, you will be having from virtual to physical address, and the cache, it was given, it was clearly given in the question that cache is physically addressed. Okay, so in the question it was clearly given that cache is physically addressed. So which means that once the page table hit is there, you have your physical address, and then you can go to the cache memory, and then you can check whether that particular, the desired byte or the desired location is there in the cache or not, because the cache is physically addressed. So that's why A is possible. Okay. So let me write the possible here. A is possible. What about C? C is saying once you have the TLB miss, then definitely it is possible to have the page table miss, right? Then it is a page fault, and then obviously the cache miss will anyway be there. Okay. So you can say that yes, C is also possible thing, right? So you can say B and D were the correct answers as per this slide. I mean, the actual options might be having the swap here and there, but yes. So this B and D are the correct answers here. So these were the 4 questions from operating systems. Do you
See,
remember?
Sachin,
Huh.
Sachin, in that previous question, that banker's algorithm question, did we give the answer for false or did we give answer for true? Like, did we
For false,
mark?
I think we give just
The
a second.
question was asking false. एक बार
हाँ,
देखना, क्वेश्चन जो है वो false पूछ रहा था, तो सिली मिस्टेक वहां हो सकती है.
right, right, right. No,
क्वेश्चन
we have
false पूछ
given
रहा था.
answer
हाँ,
for false.
ओके ओके ठीक है. सो ओके ओके, दैट्स फाइन. हाँ, सो द क्वेश्चन वाज आस्किंग false, so yes, A, D are false. Okay, okay.
Right, right. Okay. So these were the 4 OS questions. I think operating system overall was easy to moderate, because this question was easy, this was easy, this was easy to moderate, and this question we can say it was also easy, right? I mean, easy to moderate at most, you can say. If not easy, then easy to moderate. So operating systems was easy to moderate. Like I think there were like 4 questions only. Let me just see if I've written any other question.
Is there any other question in operating system that we missed? So we have already seen 4 questions of operating system. Any other question that we might have missed? Let us know from operating system. In this particular question, remember, in this question number 4, some information were given to you, and from that information, I think you can get this answer also. Het is also saying, Het Prajapati Sachin. So
हाँ,
he is also saying in the chat that this question was really very easy because some information was already given in the question which was hinting towards the answer. Basically,
right,
the
right.
the question has already written that if a page is evicted from the main memory, then the corresponding cache
Yes,
memory entry will be invalidated. Okay, we will make it invalid. So you can see from that statement, I think from that statement you can see that option B is not possible. Sachin,
right,
from
right.
that statement.
So if you are having, yes, option B, yes. If you are having the page table miss, which means that it is not there in the main memory, then it cannot be there in the cache, because it was already given in the question. So yes, so basically B and D are the answers here. I think these are the only 4 questions from operating systems. Now let's just go to maybe computer network questions. Okay, let's just quickly talk about the computer network questions. So one of the question, okay, this is little controversial actually. So this question, I think, okay, I'm not claiming it, but I think it should be marks to all. Okay, so it should be marks to all question. Again, star is there, which means that I will just see the response sheet. Once the response sheet comes, I will just see the accurate framing of the question. But as of now, I'm thinking, okay, I'm just thinking that it could be marks to all question. I don't know if there is any other coaching. I don't think there is any other coaching who has said marks to all to this question. But let me tell you the question. Can you guess the question? Which question I'm talking about? Again, I'm saying that it is a star mark. I'm not claiming it. Okay. So yes, the question was related to the CIDR, right? So they were saying that you already have slash 15 block. and then you want to allocate 6,000 more addresses, right? So I think slash 15 block was something like 2202.16.0.0. Okay, this is already available with you, and then you want to allocate 6,000 IPs, right? ISP want to allocate 6,000 IP. Basically, there is a customer who needs 6,000 IPs. Now they were asking that which of the following block that can be given to that customer, right? Since 6,000 IP is required, I think this is like more than lesser than 2 power 13. So basically they required 13 bits from the host ID, right? So they required 13 bits from the host ID. So you can say we need slash 19 block, right? We need slash 19 block. And also in the all the options, the slash 19 were there. So as long as slash 19 is there, and as long as I'm keeping these 15 bits as it is, then this answer should be true. And in all the options, those 15 bits, let me write all the options, right? See, this block was there 202.16.0.0 slash 15. By the way, anyone else also felt in the similar way that it should be, all the options are correct?
Actually, Sachin, in the chat, some students are saying like our Go classes student itself, like Guru Prasad is saying, and there are some other students also. They are saying that they also felt that it should be marks to all. Basically, I think they are also saying that all the four options were correct. This is what some students are also saying. They are saying, I think you have answered a similar question, I think, in the Gate PYQ, Sachin.
Yes, actually, in the last AIMT, the similar kind of concept were used in the last AIMT, and maybe in the Gate PYQ, I don't exactly remember, but in the last AIMT, the similar kind of concept was used.
एक वो गेट पीवाईक्यू था सचिन, ऐसा कुछ सिमिलर सा मुझे याद आ रहा है जिसको हमने चैलेंज किया था, कुछ याद है
हाँ
वो
हाँ
ऐसा था क्या?
हाँ हाँ, नहीं वो एग्जैक्टली ऐसा तो नहीं था, मतलब वो
डिफरेंट था,
थोड़ा सा,
ओके
हाँ
ओके,
थोड़ा सा अलग था.
ठीक है ठीक है, ओके.
So basically, we need here slash 19 block, right? Now they are saying that 15 bits these 15 bits are fixed. So let me write those 15 bits. See, let me just do one thing. Let me first write this. So this is basically 202 dot. I'm not writing the binary of 202 because it is not needed. Let me write the binary of 16 only. It is 0001 and then 4 times 0, right? Then 4 times 0, then dot 0, that dot 0 slash 15. Okay. Now slash 15 means this is 8 bits, and then these are the next 7 bits. Okay. So these bits are fixed. Fixed means these are the part of the network ID. Now, as long as you are keeping these bits fixed, right, then you can allocate any slash 19 address to that particular customer, which means how many addresses are possible from here. See, you can, how many blocks are possible? You can say that, see, I'm keeping these 15 bits fixed. Now you can say that I can change this. Okay, so basically, if you want, you can change this from 0 to 1. Okay, and then say slash 19. If you want, you can directly say slash 19. Okay, slash 19. I mean the same address. You can keep the same address and then slash 19. You can do anything. Okay, you can do anything and then slash 19, as long as these are intact. Okay, these are not disturbed, then you can do anything. So let me write the options. The first option was something like this: 202.16.32.0 slash 19. Now just check the check the binary representation of this. This is 202.16 means the same thing, 0001 and then 0000.32.19, right? Sorry, dot 32.0 slash 19. Now here, if you notice that we are keeping the initial 15 bits fixed, right? Initial 15 bits fixed. Then we are saying that, okay, actually this 32 doesn't matter. Like I do not care about this 32 and all. As long as these 15 bits are fixed and then I'm having slash 19, then this is the correct answer. Okay. Now there is a small kind of misconception, I can say. That the misconception is that some people say that, let's suppose I'm writing, okay, let me take very simplistic example. Let's suppose I'm writing 190.1.0.0 slash 16. Let's suppose this is some block. Okay, some people understand like this, that we cannot, okay, we have to write like this only, we cannot represent We cannot represent this block like this. Some people think like this. For example, let me write, instead of 1, let me write some other number. For example, let's suppose 255. Okay, just to make it easy for you, so let's just write 255. So some students think that it should be 255 dot, let's suppose I write something like this: are these two blocks same or different? Can I write the set of all IPs in this block? Basically, there are 2 power 16 IPs, isn't it? 2 power 16 IPs in this block. Can I write those 2 power 16 IPs like this also? Is this wrong? Some students think that it has to be network ID. It must be. Okay, this is kind of misconception, I can say. Okay, some students think that it must be network ID. See, network ID is just a convention. I mean, here writing the network ID is just a convention. It is not a must condition. I mean, you can write any IP address in this range. So, what is the range of this? See, you know the range, right? The range of this will be 190.255.0.02, 190.255.255.255, right? So this is the range of this particular block. Now, if you write any IP in this range and then slash 16, this is as good as writing this. Okay, this is as good as writing this. So basically, you can say that you can write any IP here in that range. Okay, some students think that that we must be writing the network ID and the host ID part must be 0. Okay, the misconception is that host ID part must be 0. Host ID part must be 0. It is not necessarily 0. I mean, host ID part, once you write slash 16, then this slash 16 is so powerful that it means that you just take care these 16 bits. Initial 16 bits you just take care. The rest bits can vary. Okay, they can vary from anything to anything. Don't worry about these 16 bits. These has to be 0, this has to be 1, this has to be 2, or this has to be 3. This is just a misconception in the sense that you can write any number here as long as you are writing slash 16. So what I'm trying to say is that 190.255.0.0 slash 16 is as good as saying 190.255.1.1 slash 16. It is as good as saying 190.255.2.2.3 slash 16. It is as good as saying 190.255.x.x slash 16, which means you can write anything here. But some students think that this must be 0. Okay, the misconception is that this must be 0. This is kind of, I can say, misconception. Okay. So how many of you also thought that all 4 options are correct? Yes, we were not able to select all 4 options. I was just confused in this question. So that's why I'm just saying that I will just, once the response sheet come, I will just clarify it even more. But currently I'm thinking that all 4 options are correct, because in all 4 options, the initial 15 bits were same. Okay, and we just want initial 15 bits same. And after that, we can allocate any block as long as we have slash 19, because slash 19 means 13 bits are useful for the host ID and we need the 13 bits only, because 6000 IP means like 2 power 13. With this 2 power 13 we can manage 6000 IPs. Okay, so let me write immediately, quickly let me write all the options which were present in the exam. A, B, C, D. So one option was 202.16.32.0 slash 19. Another was 202.16.0.0 slash 19. Another was 202.17.24.0 slash 19. Another was 202.17.64.0 slash 19. Okay. Now, if you notice in all the options, initial 15 bits are same. I mean, initial 15 bits are basically, if you represent the 17, then last bit is basically is odd number. I mean, this is even number, this is odd number. So last bit will change, right? But the initial 7 bits will be same. So basically initial 15 bits are same for all of these IP addresses. So that's why you can allocate, you can use any of this IP address. Okay, so you can allocate any of this block. So any of this is correct answer, but some students are thinking that maybe C is not the correct answer, because in the C host ID part is not 0. So if you mark, because since we were only able to mark 3 options, then currently if you mark A, B, and D, then you can consider yourself 100% correct. But if you have skipped, okay, apart from A, B, and D, like for example, just to mark 3 options, if you have skipped, let's suppose D, instead of D you are marking C, then we will challenge this question and we will see that what happens, right? So we will try to challenge this question, but according to me, I will just again, it is just a star mark I'm saying. Okay, it is just a marks to all as of now. Let's just see that what gate decides. Okay. So for this
Sachin,
question, I think all of the options should be correct. I will just do little more research and I will just come back with the proofs and with a standard university and standard books backup. But I'm almost sure that all the 4 options are correct.
सचिन
Okay.
एक इसी स्लाइड के ऊपर एकदम क्लियरली जैसे ऊपर एक बार लिख दो कि
हाँ
भाई एबीडी अगर आपने किया है तो 100% गारंटी है यू विल नॉट लूज मार्क्स.
हाँ
ओके, if you have done ABD, then 100% guarantee you will not lose marks. But depending on the question after the response sheet comes, depending on the question, we are going to maybe depending on the question we are going to challenge this question and it might become marks to all, or it might become that any 3 options if you have done then
हाँ
you will get marks, because 4 options we could not choose. Okay, in gate 2026 CS paper, in any MSQ question it was not possible to choose all the 4 options. So if you wanted to choose all the 4 options, then remember it was not allowed. So if you have done any 3 options, then also there is a possibility you will get marks. Okay, because we are going to challenge it. Okay, but for now you can rest assured that if you have done ABD, then you will 100% get marks. Okay, but depending on the question after response sheet, it is possible they allow any 3 options, yes, or maybe marks to all. Okay, that will be their decision, but for ABD you can be very sure that you got your marks. Okay.
yes, or maybe marks to all.
Guru Prasad, which options did you do? Like according to these options, A, B, C, D, according to these options, which options did you choose? Which options did you select? Heth Prajapati, which options? Okay.
Yes, so let's just see after the response sheet. Let's not worry about this question much. Just wanted, since we had to discuss the question, so just wanted to share my opinion. Maybe I'm wrong here, so that's why I'm not, taking 100% guarantee here currently, because the response sheet is not out. But just telling you based on my intuition that all of the options should be correct. Okay. Now let's just move to the next question of computer networks. I think this question was easy only because there was not much difficulty in this question. So you can say it was easy question. So this was question number 1 from computer networks. Now let's just go to the question number 2.
Sachin, actually this previous question, similar question with the same ambiguity, similar question came in gate 2020. So after this session is
Oh,
over, maybe we will discuss that question.
right.
Okay.
Okay. Sure.
So like Guru Prasad is telling me in the WhatsApp chat also, he is telling me he has provided the link and he is saying that there was a gate 2020 PYQ which was having the same concept, the same ambiguity. Ambiguity was also same.
Okay.
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 And yes, and also the Abhishek Ghosh, you remember
Oh,
ISC,
I know.
Abhishek Ghosh, he has written many excellent answers on gate overflow as well as on stack overflow.
uh,
So Abhishek Ghosh has also written a answer or a comment. He has written under gate 2020 question that it is really ambiguous question, and uh, basically
okay.
he's saying that the given gate answer is wrong, and so this type of ambiguity is there in one particular question in gate 2020, which is exactly similar to this question, same concept, same ambiguity. Maybe we can make a video
Uh,
later when the response sheet will be out. Then if this question needs to be challenged, if this question needs to be marked to all, or basically any three marks, any three options should be awarded marks. If this type of possibility will be there, then don't worry, all the students, please listen to me, that we will make a separate video only for this question. We will also tell you how to challenge if you want to challenge. Okay, but again I'm telling you that if you have done ABD, then there is nothing to worry, 100% you will get the marks. Okay, so now let's move on to the next CN question.
Right. Okay. So we will see that GATE 2020 question. I think there is a similar kind of ambiguity is there. So we will see that question after the session, and then we will make a video about both of the questions. Okay. So now let's just go to the question number 2 in CN. I think it was related to sliding window. Okay. It was easy question, I think. Sliding window protocol. Some propagation time was given to be, I think, 100 millisecond, and transmission time we had to calculate depending on length and bandwidth. And if we calculated, it was coming out to be 10 millisecond, if I remember correctly. And then they were asking for the uh, window size, I think, right? So basically efficiency should be 100%, then what should be the window size? So in sliding window protocol, you can say efficiency is basically in stop and wait, it is 1 upon 1 plus 2a. I mean, depending on what notation you follow. So basically a means like TP upon TT, right? If you do not follow this a notation. So this is stop and wait, but if you use sliding window, then it will be the window size here, which is n. So now if you keep it to be 100%, right? If you keep it to be 1, then n was coming out to be 1 plus 20, which is 21, right? So 21 was the correct answer here. Okay, so I think it was easy question. Everyone has in the chat also, everyone has said 21. So it was easy question. So let me write easy. Do anyone remember it was 1 mark question or 2 mark question? But yeah, ultimately it was easy question, right? Okay. So now let's just go to the next question from computer networks. See.
एक कोई टीसीपी का कोई क्वेश्चन था सचिन?
हाँ, TCP, right. So there was question related to TCP. Let me write all the options here. One of the option that TCP, option A, okay. Option A was that TCP server cannot initiate fin, or the exact wordings was cannot initiate the termination of the connection. The termination of connection. This was one of the option, or let's call it option A. Option B was TCP is half duplex. TCP is half duplex. Option C was client and server. Client and server. They were asking for false or true. Do anyone remember in this question they were asking for, I think, true only, right? They were asking which of the following is true. Okay. They were asking for true, I think. So client and server can initiate the termination simultaneously. Can initiate termination simultaneously, right? And there was one more option. Do anyone remember that option? Half duplex was one option, and yeah, uh, two-way handshake, right? So TCP is two-way handshake for the connection establishment. So TCP is two-way handshake for connection establishment. So I think it was again very easy question. So in this question, like you can easily see that obviously TCP is three-way. So this is wrong. And client and server definitely, see in TCP there is no differentiation. Deepak, what happened? Why are you smiling? Okay.
अरे मेरी वीडियो नहीं आ रही?
हाँ, वो तो मुझे पता है, मतलब मुझे लगा चैट में कुछ इंटरेस्टिंग ऐसा कुछ है।
नहीं नहीं, मैं तो प्रसन्ना से डिस्कस कर रहा हूँ, प्रसन्ना पाटिल
ओके
गूगल।
ओके
तो
ओके
थोड़ा सा ऐसे
अच्छा,
उसके
so
साथ ही
that's
डिस्कशन चल रहा है।
okay.
उसने अभी जस्ट मैसेज किया कि और भाई आईआईएससी बैंगलोर में स्टूडेंट्स की सेटिंग करवा रहा है, ये सुनने में आया है। फिर मैं उससे कंफर्म कर रहा हूँ कि व्हाट डू यू मीन। फिर उसने बोला कि भाई मेरा मतलब है कि एमटेक में बहुत सारे स्टूडेंट्स गो क्लासेस के जा रहे हैं, ऐसा कुछ मतलब चैट चल रही है, लाइव चैट।
Got it. Okay, okay.
So Prasanna Patil, to the students, I want to give the context. Prasanna Patil is basically my classmate in ISC Bangalore 2018 to 2020, and he is right now in Google. Okay.
Yeah.
Sachin, continue.
Okay. So one option was TCP is 2-way. Obviously, this is wrong. And in TCP, there is no difference between client and server. I mean, TCP is a full duplex, and there is yes, we call client, we call one other host as server, but officially you can say there is like nothing like client and server. There is no differentiation. Okay. So yes, I mean the only differentiation you can say is that generally server is open to listen. Okay, generally server is listening and client sends the request. So that's the only differentiation. Once the connection is established, then after that there is generally no differentiation. Which means client can send the data, server can send the data, and anything can happen. But at the initial phase, you can say yes, there could be some differentiation. For example, let's suppose this is client, this is server. In that case, client basically server is in always in the active, you can say, listen mode. Okay, listen mode. That's the only differentiation, which means client initiate the connection. Client say that okay, I want to establish the connection. Okay, so generally client sends the SYN packet. So that's the differentiation. But in terms of the termination, there is no difference. So client and server both can initiate termination simultaneously. Yes, that is true. Server cannot initiate termination. This is false, right? Or what was the option? Server can initiate or cannot initiate? What was the option? Okay, depending on the option, if it is, let's suppose, cannot initiate, then this is also false because server can initiate. Okay, then this is also false. TCP is half duplex. This is also false. Okay, depending on the option, it will be either, if it is not, then it is false. If it is can, then it is true. Okay. So this was question number 3 from computer networks. Any other question? Do you remember? So I think this was also easy question. CN was really easy. So just let me know if there is any other question from CN. Do you remember? Yes, I think there was some question related to HTTP, right? Question 4, CN. So it was related to HTTP. Generally, we do not focus much on the application layer protocol, but yeah, that's fine. So HTTP 1.1 is persistent protocol. Do you remember in one of the AMT also we have given one question related to HTTP, persistent and non-persistent? So HTTP 1.1 is persistent protocol, and then they were asking, one of the option was that in one TCP connection, we can get multiple objects from a server of some web page. Okay, something like that. Multiple objects of some web page, of single web page, something like this, right? Single web page from server. Okay. So this was the option. This is true. Basically, you can get multiple objects in the persistent connection, which means after connection establishment, you don't have to tear up the connection. You don't have to send the FIN packet. You can request for the multiple objects from the server. Multiple objects could be from the single web page or could be from the different web page also. So basically, it's not like should be from the same web page. So the option B was, that's the same option, but here instead of single web page, it was like different web page, something like this. Different web page, right? So I think this is also true. And there was one option which was saying that from different servers. Okay, obviously this is wrong. From different servers. So this is wrong. Do you remember any other option? There was one more option. Yeah, multiple downloads from the same server from different server it is definitely wrong. Same multiple objects from same web page or different web page, both are true actually. There was one more option. Multiple web page and same web page we have covered. Different server was false. Yes. Okay. There was one more option. I do not able to recall that option, but I think that was false, right? I do not remember that option, but I think that was false. Okay. So I think in this question only two were true. Okay. Again, I do not remember the option D, so I'm keeping it open currently. Once I get to know the option D, I will just tell you that whether it was true or false. Okay. So I think these were the only question from CN. Do you remember any other question from computer networks? And again, based on your preparation, you can say it was just like a kind of, memory based question, because in application layer protocol, these kind of questions are memory based questions only. So based on your preparation, I can say it is easy to moderate. I mean, if you remember the persistent protocol, then you can say it was easy question.
चैट में
Okay.
किसी ने नहीं दिया क्या अभी ये ऑप्शन डी?
No,
मतलब
अभी
किसी ने नहीं बताया क्या ऑप्शन डी?
second
एनीवन
op-
रिमेंबर्स? इज देयर एनीवन हियर? प्लीज राइट इन द चैट इफ यू रिमेंबर all the options like
Yes, yes,
option
yes.
D.
One student has commented. Second object.
Can download before first
Yes,
object is completely downloaded.
yes.
Second object can download before first
Before the
object
first object.
is completely downloaded.
Uh, I think this should be false. Okay. The reason is that because TCP is in order protocol and HTTP uses the TCP and TCP is in order. I don't think that you can go out of order and you can download the second object before the first object. So it should be false. Okay. Because TCP is in order protocol. We deliver the data in order. Okay. So this is false. So only A and B should be true.
So for this question, only two options will be correct. This is another MSQ question. If I think about it, Sachin, too many MSQ.
Too many MSQ really. So there has been many MSQ, I think. This was MSQ, this was again MSQ, I think.
एक बार
This was
शेयरिंग,
also
एक बार स्क्रीन शेयरिंग हटाना.
हाँ.
Actually, now if I think about it, I'm thinking that this paper, it might be little bit harder than the set one of GATE 2025 CS.
Right. Because
Because
actually, one thing
because there were too many MSQ question. If you
right.
see, if like almost every question is MSQ question.
Right, right. Actually, I have noticed that in the year whenever there are many MSQ at that time the cutoff is already like the topper also get lesser marks and cutoff is already lower or the lower end. So if there are these many MSQ, then I think the cutoff will also be the lower and compared to the last year set one, and I think the topper will also be getting the, I mean topper means the top 0.1% people will also be getting the lower marks, because in MSQ there is a high chance of getting the 0 marks, because even if a single option misses, then you will be getting the 0 marks.
See, even if the MSQ question is, let's assume, easy or easy to moderate, then also because it is a MSQ question, it automatically becomes, I can say, error prone. Because if you miss, let's assume, even a single option, if you miss, then your marks are gone. So because there are too many MSQ questions in TOC, all questions are MSQ question in every subject. In every subject, out of 3 questions are MSQ question. Too many MSQ questions, I can say. And overall, because of too many MSQ questions, I'm very sure, I can guarantee that the toppers marks or students marks, they will decrease. So I'm almost sure that no one will get 100 out of 100 in this paper. And also it may happen that very few students, maybe 2 3 students, they can cross maybe 90 marks. That might be possible, but for very few students it seems. So it seems that this paper, this is really, I can say, 1 or 2 level higher than the set one of GATE 2025. Okay, so in the beginning of this session, I told you that this set one is similar to the GATE 2025 set one. Okay, they are similar, but I take my words back after seeing so many MSQ. Like for the last
Right.
As long as this session is running, I just keep seeing MSQ, 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 MSQ. And in MSQ, even if one option
Right.
you tick, wrong, even if you don't know whether a particular option is correct or not, okay, all the remaining three options you are very confident, then also you will lose marks. Okay, so I take my words back. And final conclusion, that set 1 of gate CS 2026, this is in my opinion, it is one or two level harder than set 1 of gate 2025, but it was not as hard as set 2 of gate 2025. So it was, I can say, in middle of, if I compare
Right.
with the set, I can say that it was similar to 2024 level, 2023 level, medium kind of, I can say moderate. It was uh, towards moderate. You cannot say it was hard, you cannot say it was easy. It was basically a moderate level.
Because there was like from 2 3 subjects there was easy questions, but from all the subjects I think there were at least one question which was tricky. So yes, so it was we can say it was like moderate. Let's
Okay,
just continue the discussion.
so next subject ये CN हो गया.
CN, no, one question of CN is remaining.
Okay,
So
okay.
let's just discuss that question. It was question number 5. I think there was a, silly mistake that like many of students might have done. The question was saying that it was slow start. Okay. So CN, let me write subject name also. So CN question. Okay. So question was saying it was a slow start in the TCP congestion control. And slow start means that you start with the congestion window of size 1. By the way, one thing I'm really happy to see that TCP question has came in the examination, and we were putting TCP questions in the IMT in the hope that that kind of question will come in the examination. And one thing you might have noticed, okay, let me just solve this question and then I will tell you one thing about this question. Actually, the similar question we have given in AIMT also, but I will tell you one special thing about this question. Okay. So, congestion window was 1, and then they were saying that slow start threshold. Okay. Slow start threshold was given to be 10,000 MSS. Okay. I do not remember the unit. What was that unit, but it must be converted to MSS. So it is 10,000 MSS was the slow start threshold, or the 10,000 packets, something like this, right? And then they were asking that at what time, okay, at what time you must have already sent packet number or the segment number 2000. Okay, at what time you must have already sent the packet number. Let me write the question. At what time must have sent packet number 2000, right? This was the question. Okay. So I think Deepak, set two is also like people set two people are also waiting now because their examination is also over. But yes, we will be doing the set two analysis also. Like we haven't had the first hand experience of the set two, but we will be asking some toppers and some of our Go classes employee, one or two of our Go classes employee also attempted the set two. So we will be asking them also. Okay. So the question was at what time you must have sent the packet number 2000. See, they are not saying the congestion window to be 2000. Okay. That is one thing that you should notice. They are saying the packet number 2000, which means you can say initially you will be sending the packet number 1. Then, so see here, the congestion window initially will be 1, which means you will be sending the packet number 1, packet number 1. And then the congestion window will be 2, which means you will be sending the packet number 2 and 3. The congestion window will be then 4, then which means you will be sending 4, 5, 6, 7. Then the congestion window will be 8, which means you will be sending something like 8, 9, 10, and then till 15, something like this, right? So basically the congestion window will be keep on doubling. till 10,000. Actually, don't have to go till 10,000 because we just need to send till 2,000. I mean, for this purpose of this question. So we will never be able to, touch this slow start threshold. And the system will always be in the slow start because we are never touching the threshold. So basically, you will be keep on doubling, right? 8 and then 16 and then like, let me write in 2 power. So basically, it is 2 power 3, then 2 power 4, then 2 power 5, then 2 power 6, then 2 power 7, then 2 power 8, then 2 power 9, then 2 power 10, like this, right? Okay. Now, see, this 2 power 10 is 1024. I completely agree with you. But this is 1024 is congestion window size. In this, see, whenever congestion window size is 4, you are sending the packet number 4 to 7. Whenever congestion window size is 8, you are sending the packet number 8 to 15, something like this. So, if the congestion window size is 2 power 10, then by this time, how many packets you have already sent? See, you will be summing up all, right? You will be summing up all. And then you will get to know that how many packets you have already sent. Okay. So the number will be something like 2 power 11 minus 1 if you sum all of this. What was the packet number? It was 2000 or 1000. I think 2000, right? Can you just tell me the packet number? So was it 2000 in the question? In the question they were asking for the packet number 2000 or they were asking for the packet number 1000? Do anyone remember? Yes. See, actually, I was already guessing. So many people have already commented that the silly mistakes, silly mistakes. Okay, this is the reply to other comment. That's fine. Okay, 2000, right? Packet number 2000. Yeah. So basically, by this time, packet number 2000 they were asking. So by the time the congestion window size is 2 power 10, at that time you have already sent. Okay, the moment you are sending these 2 power 10 packets, at that time basically you are sending till this time you have sent 2 power 11 minus 1 because if you sum all of this, it will be somewhere around 2 power 11 minus 1, right? So which is already basically 2 power 10 is 1024, 2 power 11 is 2048, right? Basically, it is already greater than 2000. It is already greater than 2000. So 2000 packet number 2000 has already left. And RTT was given to be 1 millisecond or something, right? So how many RTTs you have crossed till this point? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So 10 RTTs you have crossed. So you can say that 1, 2, just a second. So 1, 2 power 1, 2 power 2, 2 power 3. Yeah, 2 power 4, 5. I think 10 RTT, right? So I think the answer was T less than equal to 10. Oh, sorry, T greater than equal to 10 and less than 11, right? This was the correct answer. Have you marked this answer or you have marked something else? Let me know. Basically, there was there was one other option which was T 11 less than equal to T less than 12. This was one other option. Okay, this was one other option, and this option is false. This option is not correct. This is incorrect option, and this option is, I can say, kind of trap option. Okay, trap option, because some of the students have not summed all of this. They are just doing 2 power 2 power 2 power, and then they thought that it will go till 2 power 11. It will not go till 2 power 11. It will go till 2 power 10 only. Okay, it will go till 2 power 10 only. It will not go till 2 power 11. That was kind of silly mistake. Chances was there in this question. So this is the correct answer. Let me write the answer here. Answer is T less than equal to 10 less than 11, right? This is the answer. Okay. So I think CN questions are over now.
इसमें सचिन, ये जो सीएन का अभी जो क्वेश्चन किया था, इन दिस क्वेश्चन लाइक वन स्टूडेंट इज कमेंटिंग 2000 फॉर श्योर, बेसिकली ही
हाँ
इज
हाँ,
वेरी
वो तो
कॉन्फिडेंट.
हाँ, नहीं 2000 तो वो पैकेट नंबर था, वो मैंने ही पूछा था, वो सही है.
ओके ओके.
ओके. Okay, let me discuss one algorithm questions. Let's just quickly discuss one algorithm question. It was related to shortest path. Do you remember that DU DB question? There were two statements were given. Let's suppose P1 and P2 or PQ. I think P1 P2, right? So P1, P2, two statements were given, and one of the statement was related to only K. And one of the one of the statements was related to K plus 1 and K, and another option was related to only K. So let me just tell you the options, the statements. So basically something like this. Do anyone remember exact options, exact statements? It was very good question. Do anyone remember? Basically, if I remember correctly, then P1 was true here. Okay, P1 was true and P2 was false. Let me tell you the reason. Okay, if you remember the exact question, you can tell me, but let me tell you why P2 was false. So basically in P2, they were comparing only K. In P2, they were comparing dk of U and dk of B, something like this, right? And UB, basically they were saying UB is a part, UB is in shortest path. Okay, UB, basically they were saying that UB is an edge which is part of shortest path. Okay, so see, UB is already included in the shortest path, right? Now if you start from S, if you start from S and then if you go, let's suppose, to U using the shortest path and UB. Okay, so basically if you go from S to B, then UB is already there in the shortest path, it was given. Now it might be possible that if you just take at most K edges, okay, if you only take at most K edges, then it might be possible that this is K plus 1 edge, right? This was the only catch in this question, which means it might be possible. In the question, it was clearly given that initially they're initializing the distances with the infinity, right? It might be possible that this is K plus 1 edge, and that is why if you are only taking K at most K edges, then it might be possible this is infinity. Okay, so that's why if they are asking that this is greater than equal to, then this is wrong, because nothing can be greater than infinity. So that was the catch in this question. How many of you did this question correctly with this kind of thought process?
सचिन, एक स्टूडेंट बोल रहा है कि एक ऑप्शन था डीके यू लेस देन इक्वल टू डीके वी, ऐसा कोई ऑप्शन था, ऐसा एक स्टूडेंट ने बोला है।
K plus 1 वाले में था शायद वो, है ना? K plus 1 is less than equal to K. हाँ, less than equal to K. Yes, this P1 was correct actually. P1 was not very, but yes, P1 was comparatively the easier option. In P1, they were saying that if you have flexibility of taking at most K plus 1 edges, see, matlab, if they are not saying exactly K plus 1, okay, they are saying at most K plus 1. So there's a difference. If you have flexibility of getting K plus 1 edges, and I think this was the same U and U only, most probably. Okay. I also actually do not remember exactly the options, but the option was only saying that in one of the options they were comparing K plus 1 and K. That option is correct. Okay. In another option they were comparing K and K. That option is wrong. So I mean, in the second statement they were comparing K and K, and in the first statement they were comparing K plus 1 and K. That statement is correct. Okay, whatever that statement was. So basically, if you have flexibility of getting K plus 1, because this is not exactly K plus 1, this is at most K plus 1, so it is like kind of superset of K. Okay, so you will be anyway relaxing it, you will be not no, it's not like you are forced to take K plus 1 edges. So it's like you can take whatever the solution you were earlier getting with the K edges, you will be getting at most with the at most K plus 1 edges, you will be getting at least that solution only. Like if you're improving, that it is good. If you're not improving, it is okay. So basically with the K edges, whatever the distance you are getting, with the K plus 1 edges, you will be getting the lesser distance only, because the K plus 1 is at most, K is also at most. Okay. So anyway, this was correct, this was wrong. Anyone has made it correct, this question correct?
So for this question, like P1, P2, we might have forgotten something, but overall, this is final conclusion that P1 is true and P2 is false, right, Sachin?
Yes.
For this
Just
particular question, this is the final conclusion that whatever was P1, P2 statements, but P1 was true and P2 was false. And we have written the statements already on the screen, the explanation we have given to you. Okay. Maybe something in the UV or less than equal to something we might have missed, but overall P1 is true and P2 is false.
yes. So I think these were the statements only. Like here it is less than equal to, here it is greater than equal to. Okay. Most probably these are the statements only.
So I think, Sachin, this question you will consider as moderate, easy, hard.
I think it was moderate. It was just a definition based question. Just at most, at least these kind of like the definition we should be just taking care. So we can consider it moderate to hard, because I think many of the students are considering it little hard. So maybe we can say moderate to hard. यार पेपर इतना भी इजी नहीं था जितना जितना हम सोच रहे थे, आई थिंक.
हाँ मतलब one reason is MSQ, and another reason is some really good questions are there. Like we have seen in every subject, at least like one question, at least one question in every subject we have seen that was really like good question, not straightforward question. You have to really know the concept. See, for example, this particular question, I have seen many students what they do. If the graph is given, they can find the shortest path, the algorithm they by heart. Okay, basically they by heart how the Dijkstra algorithm or how the shortest path algorithm works. This type of concept they will by heart, then they will solve some graph questions, where graph will be given to you and they will ask you some shortest path something. So this type of questions they can solve. But many students what they do, they don't really understand these underlying concepts. Okay, but in our Go classes lectures, if you follow, then you will see that we have given the proof of all the concepts. We have told you about all these basic concepts, all the core. Basically, this is the core of the algorithms. Okay, this is the core of the shortest path algorithms. Okay, so all these things we have discussed in our Go classes lectures. If you watch the Go classes lectures, you will see Bellman Ford algorithm proof. With proof, basically with intuition, with idea, with proof, we have provided you the explanation. Okay.
So again, see, this is just a memory-based discussion. Okay, there might be less than equal to, greater than equal to, might be here and there. Okay, but so this is just a memory-based discussion. Once the response sheet is out, then obviously we will be telling you the correct and final solutions. And also some of the students are commenting that edge weights were not given to be positive or negative. So as far as I remember, it doesn't really matter for this question, because the question is just saying that if you have flexibility of taking at most k plus 1 edges or k edges, in that case that obviously you will be having the lesser distance if you have flexibility of taking one more edge. So it doesn't really matter about negative or positive. Okay, so basically the edge weights could be negative, positive, the answer won't be changing. Again, this is memory based. Okay, so once the question is the statement is very clear in front of us, we will be telling the exact and very correct solution. But this is based on our memory, based on our intuition. So I think that P1 is correct and P2 is false, and it really doesn't matter about the negative or positive weights here, because it is just saying that taking the k plus at most k plus 1 edges or taking the k edges, it doesn't really matter whether even if it's negative, positive, doesn't matter for this question. Okay. So let's just see the other questions from the algorithm.
There was a question, Sachin, T1, T2 were given.
हाँ, वो Master's theorem.
हाँ.
हाँ.
So there was this question. The answer for that question, actually, that question was easy question. So T1 was given.
Yes. So T1 n was
T1 was 4 T n by 2. T1 was 4 T1 n by 2 plus T2 n. And T2 n was 5 T2 n by 4. 5 T2 n by 4 plus log
plus
n. Plus log n.
log n. Yes.
And the one option I remember correctly, which is actually the correct answer also, that is theta of n square.
Yeah, I
One
think
of
I
the
remember
options.
other options also. One
Okay,
of the
okay.
option was theta of n square. Another one was theta of n square log n power log base 4 5, something like this. Another option was, I think, yeah, these kind of options were there, and it was easy question. So theta of n square is the correct answer. So why? Because here if you solve this T2, then it will be ns power log base 4 5, because this will be ns power log base 4 5 and this is log n. So ns, as I told you many times, like ns power any even smallest power, okay, 0.00000000001, any smallest power is far greater than this log n, right? So basically asymptotically I'm talking. Okay, so any small power of n is greater than this log n. So n's power log base 4 5 is definitely greater than log n, right? It is definitely greater than log n. So that's why T2 was coming out to be n's power log base 4 5. Okay, and T1, basically for the T1 we had to compare between this and n square. So obviously this is 1 point something, right? And n square is obviously 2. So that's why n square was the correct answer here. Theta of n square, I mean. Okay.
So this was an easy question. And for this question, the final answer, that is theta of n square. This was quite easy question. You just have to apply the master theorem. First, you apply the master theorem for T2. Then you apply the master theorem for T1. Okay, because T1 depends on T2. So first you find T2, then you find T1. So overall, this question was easy question.
Right. Let's quickly see another algorithm question. There was one question related to graph algorithms only, minimum spanning tree question. It was little, I can say, moderate to tough question. So here, one of the option, I think the options I have written.
Actually, the given data was distinct age weights. This
Huh.
this was the given data in the question. It was given that we have a graph with distinct age weights. Distinct,
I think it was undirected connected graph.
undirected connected weighted graph with distinct age weights. Undirected connected weighted. Okay.
With, so it was given in the question, right? And then they were asking which of the following is true. I think true they were asking. Okay. One of the option was that any
For every v, for
अच्छा
any
वो
v,
वाला for
for
any
every v,
yeah, for every B or for any B, the lightest incident edge on B is always a part of MST. Something like this, right?
हाँ हाँ सही
Like
है. The lightest मतलब वो smallest weight. So
हाँ
students already understand this.
हाँ.
Okay, so
So let me write a smallest only. So basically the
the
smallest
smallest weight is the smallest weighted is जो भी
हाँ weighted edge is always smallest weighted for any B, the smallest
weighted age incident on v, या फिर मतलब वो कोई बात नहीं वो तो.
smallest actually वो weighted ही हो जाता है.
हाँ हाँ. The
Smallest.
smallest age incident on v is part of every MST. Actually, they are writing this word every MST, but because the age weights are distinct, so actually we will get unique MST because
Right.
the age weights are distinct. So we are going to get only one MST we are going to get, but still they are writing this to confuse students. So this was one option. Another was option for any V, the heaviest, for any V, the heaviest is.
ये था क्या फॉर एनी भी था या फिर ऐसा था कि साइकिल का था सीधा कि
नहीं नहीं, दो ऑप्शन साइकिल के थे, दो ऑप्शन वर्टेक्स के थे.
अच्छा ओके फॉर
हाँ,
एनी भी द हैवीएस्ट.
दो ऑप्शन थे फॉर एनी वी और दो ऑप्शन थे फॉर एनी सी.
ओके
सो
ओके.
हाँ, फॉर एनी वी द हैवीएस्ट इज इंसिडेंट ऑन वी इज पार्ट ऑफ इज इज पार्ट ऑफ सम एमएसटी, इज पार्ट ऑफ सम एमएसटी, शायद. हाँ, याद आ रहा है मुझे. इज पार्ट ऑफ सम एमएसटी. यस यस.
ओके.
तो इन दोनों ऑप्शंस, बाकी दो ऑप्शन और थे, तो
हाँ
इन
दो
दोनों
ऑप्शन
ऑप्शन
तो
के अंदर तो.
हाँ
हाँ
एक बार वो लिख ही देता हूँ चार
हाँ
ऑप्शन.
हाँ.
ज़्यादा छोटा फॉर्म तो नहीं होगा. Okay, so the option C was that The
For any
heavy,
cycle C.
for any cycle C, it was starting from for any cycle C, the heaviest edge is never a part, right?
हाँ हाँ, इज नेवर अ पार्ट ऑफ एमएसटी, सही है, यही था, ऐसा ही कुछ था,
हाँ
इज नेवर अ पार्ट ऑफ एमएसटी। मुझे याद है 2 ऑप्शन करेक्ट थे, शायद 2 ऑप्शन रॉन्ग थे, तो
ऑप्शन डी क्या था?
ऑप्शन डी था स्मॉलेस्ट एज फॉर एनी साइकिल सी, द लाइटेस्ट एज is always part of MST. The lightest edge for any cycle, see the lightest edge is always a part of MST.
Okay. So basically, these are the four options that we had for this question, and these four options can be solved using two properties. One of the properties cut property, and another one is cycle property, right? You might already know if you have seen Go classes lectures. So one of the properties cut property, another one is cycle property. So let's just go with the option A. Option is saying that the smallest edge incident on V is part of every MST. Is this true or false? This is true, right? So let me just quickly tell you why that is true. So this is true. Why? Because the cut property says that whenever you have any vertex, let's suppose V, and there are, let's suppose, multiple edges, then you can cut. Okay, you can cut at any, like basically cut means that you have in one set you have some set of vertices, and another set you have another set of vertices. So you can cut on V, and then you can in this cut, whatever, you can take any cut. Cut property says that you can take any cut, and in this cut, whatever is the lightest or whatever the smallest edge, that is always part of the MST, right? So basically, in other words, you can think like this, that let's suppose this is V. Okay, there are like 1, 2, 3, 4, there are like 4 edges, and then you can apply Prim's algorithm on V. If you start Prim's from here, if we start Prim's from V, then don't you think that one will always be taken? Right? The lightest weighted edge will always be taken. So basically, you can think in this way that that we can start. Okay, if you want to make sure that it is taken or not taken, then you can think like that, that we can always start prims from that particular vertex, and then we can always take that smallest edge weight, right? Or using the cut property also, you can understand that if you take a cut from this V, then the smallest edge in this cut, the smallest edge weight is basically the same edge which is incident on this V, which is the smallest, right? So basically you will say that this is correct, A is correct. And option B is saying for any V, the heaviest edge incident on V is part of some MST. So what do you think, it is correct or wrong? The heaviest edge incident on V. See, it is not necessary to be correct, right? I mean, there is this is not following the cut property. The cut property says that lightest edge will be the part of every MST, not the heaviest edge. So this is false. This is true. Now there is something called cycle property. Cycle property says that if some edge is the heaviest edge, then you will never in a cycle. Okay, it says that cycle property says that heaviest edge in a cycle will never be part of MST. See, intuitively you can understand like this. If there is a cycle, right? If there is a cycle, and in this cycle, obviously, if let's suppose there are 1, 2, 3, 4, 5 edges, then obviously in the MST only 4 edges will be taken. Why you will be taking the 5 edges in a tree, right? So in the MST only 4 edges will be taken. Now, now obviously, if you have a choice to remove one of the edge in the MST, then you will be removing the heaviest edge only. Let's suppose if this is the heaviest, then you will be removing this edge. So cycle property says that the heaviest edge in a cycle will never be part of any MST. Okay, so it only says about the heaviest edge. It doesn't say anything about the lightest or any other edge. Okay, so let's just see the other options. Option C is saying for any cycle C, the heaviest edge is never part of any MST. Yes, this is true, right? Because this is exactly the cycle property says. And what about D? It is saying for any cycle C, the lightest edge is always part of MST. See, the cycle property doesn't say anything about the lightest edge. So it is kind of the fishy option, but let me tell you that this option is wrong. Why? Let me just copy this option on the next page and let me tell you why this option is wrong. See, see, cycle property only says about the heaviest edge. That heaviest edge will never be part of the MST, right? Now, if it is a lightest edge, let's consider some cycle. Okay, let's suppose this is 3, 4, 5. What is the lightest edge? Lightest edge is 3, right? Lightest edge is 3. Will it be part of? Will it be always part of the MST? May not be. Why? Because it may be the heaviest edge of some other cycle. For example, let's suppose this is the complete graph, right? This is 1, 2, and this is 3. This 3 is the heaviest edge. Oh, sorry, lightest edge of this cycle, but it is the heaviest edge of some other cycle. So based on the cycle property, this 3 will never be included because this is the heaviest edge. Even though it is the lightest edge of some other cycle, it doesn't really matter, okay, because the cycle property doesn't say anything about the lightest edge. So we will say that the lightest edge is getting included or getting excluded. It's basically not guaranteed. So always writing the always is wrong here, because the lightest edge of some cycle could be the heaviest edge of some other cycle, okay, and the heaviest edge is never included. So that's why this option is false.
सचिन, एक ऑप्शन बी के अंदर एक थोड़ी सी वो मतलब ऑप्शन बी चेंज है. ऑप्शन बी जो है वो होगा फॉर एनी वी द हेवीएस्ट एज इंसिडेंट ऑन वी इज नेवर पार्ट ऑफ एनी एमएसटी.
Okay.
इज नेवर पार्ट ऑफ एनी एमएसटी. इज नेवर पार्ट ऑफ एनी एमएसटी. अब ये फॉल्स है, क्योंकि अगर मान लो वो याद है वी वर डिस्कसिंग कि अगर अगर वो होगा, वो क्या कहते हैं,
Bridge. Yeah,
ब्रिज होगा,
artificial
हाँ,
intelligence.
तो ये ऑप्शन बी विल बी दैट हेवीएस्ट एज इंसिडेंट ऑन वी इज नेवर पार्ट ऑफ एनी एमएसटी. अब इसका एक वो काउंटर एग्जांपल सा कुछ ऐसे ग्राफ ड्रॉ कर देना, ऐसे कुछ
हाँ.
ट्रायंगल बना के कुछ ऐसे ब्रिज बना देना कुछ.
Right. So basically, option B
फॉल्स
is
तो है
saying,
ये.
it is false only. So it is saying that the heaviest edge will never be the part. Okay. So let's suppose this is V, and let's suppose this is the heaviest edge. Okay. Suppose 5,000 or 500, right? And this is just another one vertex U, and there is some other graph. Okay. The graph is here, and this is the heaviest edge. This is like 1, 2, 3, 4. Other edge is not the heaviest edge. So it is saying the heaviest edge is never part. No, it will always be the part, right? Why? Because this is a bridge. Since it is a bridge, so it has to be a part of MST. So that's why you can say it is false option, because it is saying heaviest edge is never part of any MST, which is false because this is actually the part, because it is a bridge, okay, and it is the heaviest. So
सो फॉर दिस क्वेश्चन देयर विल बी टू ऑप्शंस करेक्ट. एक बार दिखा देना सचिन.
हाँ.
So there will be two options correct for this question. You can see this option A is correct, that for any vertex the lightest, or I can say smallest edge incident on V is part of every MST. This is true because of cut property, and you can also use the Prim's algorithm basically, and already it is given that the edge weights are distinct, so there will be unique minimum spanning tree. Then on any vertex you can start the Prim's algorithm, so that logic we have already seen. And option C is true. For any cycle the heaviest edge is never part of MST.
Yes, so basically it is because of the cycle property, right? For in any cycle, the heaviest edge is never a part of any MST. So we have seen both of the properties in very good detail in Go classes lectures. Even I have told you the intuitive proof for both of these properties. Okay, so cycle property proof was given by something called as exchange argument. This is very famous, argument in greedy algorithms. To prove the greedy algorithms, we use something called as exchange argument. So anyway, we have proved the cut property, cycle property in Go classes lectures already. We have seen this in the very good detail. Okay. So I think many questions we have discussed.
कुछ और क्वेश्चंस जैसे
हाँ, एक
हैं।
फू बार वाला बता दूं।
हाँ हाँ, फू बार वाला वो काफी इंटरेस्टिंग क्वेश्चन था।
हाँ,
आई एम वेरी श्योर दैट इन दैट फू बार क्वेश्चन मेनी स्टूडेंट्स हैव वेस्टेड अ लॉट ऑफ टाइम, आई एम वेरी श्योर। एंड दिस वाज, आई कैन से, दिस फू बार क्वेश्चन वाज, I can say, was the hardest question of this set one. I can, maybe, I think, in my opinion. हाँ, पहले
राइट।
तो एक बार आंसर ही बता देना सचिन, क्योंकि आंसर से ही
हाँ।
मतलब थोड़ा पता चल जाएगा कि क्या आंसर है। फू बार क्वेश्चन वाज देयर।
I think actually some students were discussing, they already got it correct. So 2 power 16 is answer for this question, 65536. How many of you have done it correct?
So this was NAT question, and there was a program given.
Yes. So this was a question related to two functions. So let me write the functions. So it was something like this: int bar. Okay, it was taking some variable, let's suppose n, and then it was just returning. There was a base case which was returning zero. If I think n equal 1, then return zero. Else return basically 1 plus bar of n by 2. Something like this it was doing, right? And there was foo also. Let me write foo. So there was foo also, int foo, and here in this base case it was returning 1. Okay, return 1. And here in the recursive case it was calling foo also and bar also. So it was doing something like this: foo bar of n. Okay. So do you remember this question? I think many students has done 16 instead of 2 power 16. Okay. So let's just solve this question. So basically, if you notice, let's just first notice this bar. If you notice this bar, then let's just see what this bar function is doing. Okay, then we will be coming back to the foo function. Let's just see what this bar function is doing. So it is saying if you're passing any integer to me, then I will return. For example, if you're passing, let's suppose 8. Since it is divided by 2, so that's why I'm taking, to even number like 8, 16, like something 2 power number, because again and again I have to divide by 2. So that's the only reason I'm not taking 5 for to as an example. Okay, I'm taking, let's suppose 8. Okay, then it will say that return 1 plus bar of 4. Then it will say return 1 plus bar of 2. Then it will say return 1 plus bar of 1. And bar of 1 is actually 0. Right? So what it is doing, it is again and again calling. I mean, it is dividing by 2 and then 1 plus bar 4, 1 plus bar 2, like this. Okay. So which means it is counting 1 1 1 1 1. It is counting and keep on dividing by 2. So you might remember from the algorithms also. Okay, this is recursive, so that's why you might not be able to recall directly. But if it is for loop, right? So we have seen these kind of things also. Let's suppose you are starting from n and then I equal to I by 2. Then can you tell me what is the I equal to I less than equal to, let's suppose 1 from here, and I equal to I by 2. Can you tell me what is the time complexity of this for loop? If I'm just doing some simple operation, let's suppose print or something. Okay, you might recall. So basically, if I do always divide by 2, then in that case, the time complexity will be, if I'm starting from n, then it is n, then n by 2, then n by 4, like this, right? Then we have done these things, and time complexity will be basically log n. Okay, if it is for loop. The similar things is happening in case of the recursion. So basically, it is divided by 2, and it is just counting that how many 1 plus 1 plus, or how many times you can divide by 2, such that you get finally 1, and then 1 means 0. Basically, it will return 0. So ultimately, if you notice, it is calculating the log, right? It is calculating the log, which means 8 is 2 power 3. 8 is 2 power 3, and if you notice that it is also returning 3. So bar function is exactly same as log n. So bar of n is exactly same as log base to n. Okay. So bar n is doing nothing, exactly same as log base to n, assuming that n is in 2 power. Otherwise, like, I mean, mathematically, like, it won't be exactly same, because and if n is not in 2 power, then it will be some fractional number. It could be like I mean, like something, it will be having the fractional part, but bar will never return the fractional part. So assuming that n is always in 2 power, so it is exactly log base to n. Okay. Now you just forget about this bar n. Why? Because bar n is nothing but log base to n. Now let's just focus on this foo. Okay. What this foo is doing? By the way, has anyone did it correctly?
हाँ,
Has-
हेत
Oh
सचिन,
wow.
हेत
हाँ.
प्रजापति इज सेइंग कि ये क्वेश्चन इनडायरेक्टली गो क्लासेस की टेस्ट सीरीज के अंदर था, और जैसे ही हेत ने इस क्वेश्चन को सोल्व करना शुरू किया, तो थोड़ा सा एक दो वैल्यू लेने के बाद में उसको आइडिया लग गया कि ये तो वही टेस्ट सीरीज का क्वेश्चन है, लॉग स्टार वाला। एक
Oh,
ऐसा,
yes, yes,
ये कमेंट है, देख मैंने पिन भी करी थी इस कमेंट को। तो
I
हेत इज
will
सेइंग
cut
दैट,
it.
sir, this question was there in the test series log. Indirectly this question was there in the test series, and as soon as I observed the pattern, I thought that yes, this is the test series question, log star n
Okay.
question, so I answered it.
Great, great. This is really a good observation, Hit. So basically here this bar is nothing but log n. Now interestingly, let's just see this what this foo is doing. Okay. Suppose you are passing foo of 2 power 4. I mean, let's suppose you are basically they are asking that what value to be passed such that you get 5. I mean, what is the minimum value or something like that, right? Or what is the value that you should be passing such that you get 5 as an answer. Suppose you pass 2 power 4. Then then what will happen? Foo of 2 power 4 will be calling 1 plus foo of log of 2 power 4 means 4 only. It will call 1 plus foo of log of 4 is 2 only. It will call 1 plus foo of log of 2 is 1 only, and foo of 1 is actually 1, right? Foo of 1 is 1. So if you are having 2 power 4, then in that case you are basically having the answer as 1 plus 1, 2, 3 and 4, right? 4 is the answer, but we want 5. So what about 2 power 5? See, currently if you
सचिन,
are
एक
हाँ,
बार ये लिख देना कि क्वेश्चन क्या पूछ रहा था। क्वेश्चन ये पूछ रहा था कि किस
हाँ,
n वैल्यू के लिए फू n की वैल्यू 5 होगी, ये एक बार लिख देना यहाँ पे,
हाँ,
कि द क्वेश्चन वाज आस्किंग फॉर फॉर मिनिमम एक मिनिमम वैल्यू पूछ रहा था, फॉर मिनिमम फॉर विच फॉर विच मिनिमम एन फॉर विच मिनिमम एन फॉर विच मिनिमम एन foo n is equal to 5. So basically we need to find the minimum value of n such that foo n will become 5 now. Yes.
yes. So now if you let's suppose one thing is for sure that bar is calculating log, right? Now if you the first thing that I did in the examination hall, I tried to with 2 power 4 actually. Now if you try with 2 power 4, then you will notice it is 1 plus foo 4, and because 1 plus foo of log n, right? Log n means log of 2 power 4. So then you keep on doing it, and ultimately you will be getting 1 plus 1, 2, 3, 4 as an answer. So the next thing that you will be trying is 2 power 5, right? See here, what's going to happen if you try 2 power 5? Ultimately, we want 5 as answer, right? 2 power 5. 1 plus 2 of 5 because log of this is 5. Now there is actually some fishy thing is here because I was supposed to get something in 2 power, but I have gotten 5, which is okay. Let's just continue. Okay. Now this foo 5 will be doing what? 1 plus foo of log 5. I mean log 5 means like it will be the way bar is working, it is basically n by 2, right? N by 2. So n by 2, 5 by 2 and 4 by 2 are actually both are 2 in C programming. So you write 5 by 2 or you write 4 by 2, both are 2. So 5 is nothing but it will exactly behave just like 4, which means log of 5 is just like, I mean, log of 4 is 2 because it is 2 power 2. Similarly, log of 5 will also be 2. Okay. So basically, you notice here is that it is reducing to the same thing. But what I ultimately want, I want one level up. Okay, I want one level up. The moment you observe that I want one level up such that it is basically 1 plus. I mean, I want something here such that ultimately I get one level up and 1 plus foo of 2 power 4 I get as a result, which means I'm actually looking for, okay, 2 power 2 power 4 because it actually take the logs. So that's why I'm looking for 2 power 2 power 4. so that I can just make one level up. So it is 2 power 2 power 4. Okay. So now if you notice that if you call with 2 power 2 power 4, in that case, it will be 1 plus 4 of 2 power 4, and then you know this value is 4, and then I mean this value is 4, you already know this, and then 1 plus 4 is 5. So basically you get 5 by 2 power 2 power 4, which means 2 power 16. With 2 power 16 you get 5. 2 of 2 power 16 is 5, which means 2 power 16 means 65536. Okay.
This was really a tricky question, and
Yes.
I'm telling you, if you have attempted Go Class test series weekly quizzes, then this question you might have seen this similar question indirectly, where we were asking log star n, log star was defined, the definition of log star was given, and we were asking what is the value of log star n. So this type of question was present in the Go Class test series. You can see in the chat Het Prajapati. Het is Go Classes complete course enrolled student, and Het is saying that in the exam, in the set 1, he saw this question, this foo bar question he saw, and immediately he remembered the Go Classic test series question, and immediately he solved the question and he got this correct answer, that is 2 power 16. Otherwise, this question is really tricky question. Okay, but because had ho- Heth had already seen this question in our test series indirectly, so when he attempted this question, then I can say after few seconds, or maybe after just few minutes, maybe 1 2 minutes, he understood that this is that question. Okay.
Yes. So similar kind of question is already present in Go classes test series, where instead of two functions, so I have defined one function which is log star n, which was basically a function which is saying that like log of 2 power 2 power 2, let's suppose. Okay, then how many times you need to apply log to this log star? Okay, how many times you need to apply log to this particular number so that you get 1? See, if you apply one time, it will go away. If you apply one more time, it will go away. If you apply one more time, then this will be 1, right? So the answer will be 3. Like that, there was some function which we have defined. Log star of n is number of times we need to apply such that we get 1, ultimately 1. Okay, this is the similar kind of question that we have, because ultimately this foo, okay, is returning 1, right? And we are keep on applying the log. We are keep on applying the log recursively. We are applying the log, and this is the same thing. It is saying 1 plus means I'm just counting how many times we need to apply the log such that we finally get 1. Okay, this is exactly log star. Yes. So this is exactly, this foo is exactly doing the log star, because here I'm counting how many times we are applying the log. So this foo is exactly the same as log star n. Okay. So this was one algorithm question. And yeah, so let's just quickly tell the answers of few questions. For example, there was one binary search tree question where pre-order was given. Okay, pre-order was given, and they were asking in post-order, the location of 6 they were asking, right? So let me directly write the answer instead of solving it. So answer was 7, if I remember correctly.
Yes, yes.
Yeah,
The position was defined also. They were saying that
yeah, it
position of
starts from 1.
what will be the position of 6, and they have defined that position starts from 1.
Yeah, so
So
instead of
this was a
location,
question. Yes.
they have used the position word, and position was defined to be starting from 1, was given to be start from 1. Okay.
Yes. So this was basically easy question. Okay, BST binary search tree. So in order is basically, in order you already know that will be the sorted
Yeah.
order, and you can easily create the post order and you can get your answer. There was
Yes.
another question, Sachin.
From BST only, no?
BST plus complete binary tree. So BST plus complete binary tree, 1 to 16, these are the elements. They are inserted in some order such that we are getting complete binary tree. 1 to 6, 1 to 15. Yes, 1 to
15.
15. So
15
BST
got
plus,
inserted.
were inserted, 1 to 15 were inserted in some order, such that we get complete binary tree. Such that we get complete binary tree.
Yes. So basically, this kind of question was also present in our test series. Do anyone remember there was even the higher version of this question was already there? That I asked that how many ways we can insert 1 to 15 to get the complete binary tree. Okay. So in test series, we had in how many ways we can insert. Anyone remember this question? 1 to 15 such that we get complete binary tree. Anyone remember this question? So in test series, we had this kind of variation, and in gate, actually, the easier version was asked. So they are saying that that if you are inserting 1 to 15, then let me first make the complete binary tree. Let me just tell you. See, these are the leaf nodes. Now, since it is a binary search tree, so it has to follow the binary search tree property. So which means that here, how many elements are there? 1, 2, 3, 4, 5, 6, 7, right? 3 and 3, 6 and 7. So 7 elements must be here. 1 to 7 must be here, which means 8 will be here. So 1 to 7 means like you can anyway like very easy to do the in order projection if you remember. So you can directly fill this by using the in order projection. How? You can add 1 here, 2 here, 3 here, and then 4 here, then 5 here, 6 here, 7 here. Do you remember in order projection? Then 8 is already there, then 9 here, then 10, and then 11, 12, 13, 14, and 15. Okay. Now they were saying that what should not be there. I mean, something like that. They were asking that if you are doing something like this, then then which of the following should not come at the third position to get this kind of tree. Okay. See, 8 must be coming at the first because it is a root. Now after 8, to get this kind of tree, after 8, what are the possible things? Immediately after 8, 4 can come, or 12 can come, or either 4 can come, 12 can come, or okay, that's all right. 4 and 12 can come. Now let's suppose after 8, 4 is there. Okay. Then can you tell me what are the possible values for this third position? Maybe 2 can come, maybe 6 can come, or maybe 12 can come. Okay. So 2, 6 and 12, these are the three possibilities. In fact, we did it recursively. Like we have developed a recursive formulation in the test series. There was a question, and we did it very nicely because it's not possible to count all the possible number of ways to have the orders to get this tree. So in the test series question, we had it a little complex version of this question, and then we did it recursively, right? So anyway, so for this question, they are saying that what should not come at the third position. See, at the third position, if the fourth is the second position, then 2, 6, and 12 can come. Obviously, one of the option was 5. Then 5 cannot be at the third position. Why? Because at the third position, either 2, 6, 12 can come, or if 12 is here, then 4, 10, and 14 can come. I mean, there is no possibility of 5 because 5 is already at the you can say from this root, it is already quite far away, or in other words, you can say this is the fourth node from the root, right? This is the first node, second node, third node, and fourth node. Okay, 5 cannot come at the third position because the moment 5 is coming at the third position, it will be either at this level or this level, right? I mean, it cannot be at this level because the binary search tree cannot go to the right. But yes, after 4, if you ask me that if 5 is coming, then it will be at this level. 5 cannot be in that case at the last level. So options were, I think, 2, 4, 10 was
2,
also
4, 10,
option.
5. 2,
Yeah,
4, 10, 5.
yeah.
And
2,
the
4,
answer
10,
will
5.
be 5.
5. So 5 is the correct answer here, right?
one more thing, actually, we can observe that before 5, it's guaranteed that before 5 we have to insert 8, 4, 6.
Yes.
So automatically you can see that if I want
Mhm.
5 at the earliest, okay, if this is my wish that I want 5 to be earliest, then earliest position will be fourth position, because before 5 I must insert, before
Right.
5 I must insert 8, 4, 6. These must be inserted before 5. So automatically you can see that before 5 already 3 people are there that we will come before 5. Okay, so definitely 5 cannot be inserted at the third position.
Right. So which means 8 is there, and then obviously 4 and 6 will be there, but they need not to be strictly just after 8, right? I mean the sequence is same. I mean between 4 and 6 there could be some other things. Some other things can be like before 4 it can be 12. Okay, there are like possibility of 12 here, or there are like some other possibilities also which we have covered in the test series question recursively. So, but yeah, as Deepak has pointed out, that before 5, we must make sure that 846 has already come. So 5 cannot anyway come at the third position. Okay.
I think, Sachin, many good variations can be created only from this question itself.
Right, right.
Mm,
But
For
कितना
example, if
5 को अर्लीस्ट करना है, कितना दूर करना
हाँ
है ना,
हाँ
कि कितना लेट 5 को पुश कर सकते हैं.
हाँ, कितना लेट पुश कर सकते हैं,
हाँ.
कितना अर्ली पुश कर सकते हैं,
Right,
मतलब many such questions can be created here.
right, right. Actually
Maybe
वो जो हाँ.
when we provide the complete analysis, like for this particular question, when the response sheet will be available, when we provide the complete analysis, you can make 3 4 variations, that okay, just try these. Maybe
Right,
you
right,
can give these as a homework also.
राइट. एक्चुअली इनका सबका सुपर सेट ऑलरेडी एक टेस्ट सीरीज के क्वेश्चन में है, सबका कि
वो
कितने नंबर ऑफ पॉसिबल वेज हैं
गुरु
इंसर्ट
ने
करने की ये ट्री बन जाए.
गुरु प्रसाद ने बोला है कि ही विल प्रोवाइड यू, ही विल ही इज सेइंग दैट मुझे याद है, यू कैन सी द पिंड कमेंट, आई हैव ऑलरेडी पिंड इट.
हाँ.
गुरु प्रसाद
या
इज सेइंग
आई विल
दैट
टेल यू
मुझे
नेक्स्ट.
याद है ये क्वेश्चन, आई विल टेल यू द मॉक टेस्ट नंबर ऑल्सो. तो
राइट,
टेस्ट सीरीज
राइट.
में था ये क्वेश्चन, बस इसका
हाँ.
जो टेस्ट सीरीज में क्वेश्चन था उसका बहुत ही इजी और डाइल्यूटेड वर्जन गेट में आया है. मतलब जो टेस्ट सीरीज का क्वेश्चन था वो तो थोड़ा एक तरीके से हाई लेवल था, उसमें सचिन इज सेइंग कि रिकर्सिवली हमने किया, ओके, नंबर ऑफ सीक्वेंसेस हमने फाइंड किए.
राइट. सो दिस वाज वन क्वेश्चन. आई थिंक डीएसए के यही क्वेश्चंस थे. There was one question from C programming, and the answer was I equal to 9. So C programming question. So basically, that question was regarding, some code was given to us, and the question was like that code was not doing anything. Interestingly, there was a local variable which was getting modified, but ultimately the original I was not getting modified. So that's why the original assignment was I equal to 9, and the final answer is also I equal to 9. So there was no modification to the original I. There was a modification to the local I.
Sachin, I can take some more questions actually from the COA, from computer organization.
Okay, okay.
Is there any other question you want to take?
Yeah, let me just quickly tell answers of the question. So ये हो गया. एक बार आंसर्स बता देता हूँ.
हाँ हाँ.
MST. There was one question from C programming only, and it was something like this: that char star S1, char star S2, int star S3, right? Equal to hello, something like this. It was hello, and they have not put the closing parenthesis, closing bracket, closing quotes. It was just a opening code, and there was one more like hello, something like this, right? Okay. So basically, here it was like kind of C programming plus mixed question. You can say C programming plus compiler design question. It was also a good question. Here in this question, if you notice that this is not a valid string, right? So lexical analysis, in the lexical analysis, you will not be able to provide a valid token to this. There is no valid token to this. Okay, no valid token. Tokenization is not possible in this case. So you will say it is having the lexical error. This is having the lexical error. And there is no error in this. Even though the semicolon is in between, but it will be treated as a string. So there is no error in this. Okay, there is no error. And here in this case, since int has written and ultimately you are having the string here, so there's a type mismatch. Type mismatch. So you can say it is semantic error. Okay. So this was the question. There was one question from hashing. Linear programming question. Do you remember what was the answer of this question? So basically it was x plus 7 mod 11, right? And so I think the options were 0, 1, 10, 2. Okay. If I remember correctly, then these were the options, or something else was the options. So some questions, something like this was there. Do you remember the options? So they were inserting something like, I think they were inserting 13, 22, 15, 11, 24. Before that also there were some numbers, right? They were inserting some numbers. So I think two was the correct answer for this question. Two was the correct answer, right? This was the correct answer. Okay. So this kind of question was there. It was very easy question. There were some numbers. One or two numbers was also there before these 13, 22, these numbers. One, two numbers were also there. But yeah, ultimately two was the answer for this hashing question.
This was actually MSQ question, and the only one option was correct for this question. Basically, the question was asking which position, which hash index will remain empty. Which index will remain basically empty? Which entry will remain empty? Something like that.
Yes. So at 2 there won't be anything. Okay. Because I think it was starting from 7. The cluster was starting from 7, 7, 8, 9, 10, and then 0, 1. Till 0, 1 it was going. But at 2 there was nothing.
Yes, yes. So for this question, only one option will be correct. The answer will be option, which is 2. Okay. So the value 2. It was actually MSQ, but only one option is correct.
So I think, Deepak, I have covered all the questions that I had. Just
Okay.
one more question. That C1 plus C2 they were asking in the calculus. The answer is 3. Okay. I think most of you might have done it correctly. It was something C1 into e power x minus C2 into log base E1 upon x. Okay. And otherwise it was 3, right? If x is greater than 0, this is fx. Otherwise it was 3. Something like this was there, right? So if you put x equal to 0, then you will be getting c1 minus c2 into this is kind of infinity, right? So obviously, like, you have to make it 3, so c2 must be 0. So c1 was 3, c1 was coming out to be 3, and c2 was coming out to be 0. Okay. Yeah. So linked list question, that question was easy. Let me quickly tell the linked list question also. So they were asking about size, I think they were asking. So E1, E2, right? E1, E2 they were asking. So E1 was coming out to be head next, because if head next equal to null, then it means the number of nodes are actually 1. Okay, so E1 was coming out to be head next equal to null, then we should be returning 1, right? And E2 was kind of recursive case. It was 1 plus get size. Obviously, you won't be passing head, otherwise it will be the infinite recursion. You have to pass head next. Okay, so this was the answer here.
So how many of you did it correct? This linked list question, this was easy question, very easy question. The question was saying that the linked list is non-empty. Sachin, this was given actually. That given given linked list was non-empty. It was given.
Yes. So actually, these kind of things generally they give to make sure that you don't raise the question of that what if head is null. So they are already saying, because if head is null, then code won't be able to execute. Okay, you won't be able to execute the code. So they just give it for the sanity check. I mean, they just make sure that you don't get trouble in the corner cases. Okay, so it was given that linked list was non-empty.
Sachin, in one another question, that foo bar question, they have written at the end that ignore if any error is there.
Ah, right.
That statement was written at the end,
Ah,
that ignore any syntax error. If there
right.
is, by any chance, if there is
Okay.
any syntax error, then
Ah,
ignore it. This they have written in that foo bar question.
right.
Okay. Sachin, there was a question. I think there was some linear algebra question also.
Okay, okay, yes, yes. So there was one question, linear algebra question. Let me just tell you that question. It was related to null space. I don't know why they have used this term null space. Generally, they do not use in the gate CSE. So they were saying in the null space. Okay, null space means it is nothing but AX equal to 0. They are having some vector which was 0, 1, all zeros. Okay. So only 1, 1 was there. I mean, there is some X. Let's suppose this is X. So they are saying there is some X such that AX equal to 0. Null space means such that AX equal to 0. Then one of the option was there are multiple such X. Okay, multiple such vectors in the null space. Then if some vector is if some vector X is in the null space, then you can always multiply by the K, right? Both side. And then you can always say that AKX is also 0. So if X is in the null space, right, null space, or null space means like AX equal to 0, then KX is also making AX equal to 0. I mean, KX is also doing the A into that vector equal to 0. So KX is also in the null space. Okay, so basically one of the option was that there are multiple vectors in the null space, which that option is correct. One of the option was there are multiple vectors in the null space. There are more than one vector in null space. That option is correct. Another was asking about the determinant. Okay, determinant of that A. So let me tell you that, see, if you're multiplying A with a vector which is something like 0, 1, 0, something like this, then it means you are basically picking, ultimately you are getting 0, right? So it means you're picking the second column. So basically this is the first column, second column, third column. Then 0 into the first column, 1 into the second column, and 0 into the third column. Which means you're picking the second column, and the second column has to be 0. So from this you can say the second column has to be 0. Second column has to be 0, right? So if you open the determinant along the second column, then you will be getting the determinant to be 0, right? Determinant to be 0. You cannot say anything about the rank, but you can for sure say that rank is less than n. Obviously, it cannot be n, but you cannot tell the exact number. So basically, I think two options were correct here. Okay, determinant is 0, and there are more than one vectors in the null space. So exact rank we cannot calculate, right? But we can definitely say that rank of A is less than n, but we do not know the exact value. Okay. There was one last question that I have regarding the binary min heap. There was one question from data structures, binary min heap. They were saying take n greater than 100. Okay. So first of all, there is no point in taking n greater than 100. You can solve this question by taking any other value of n. I mean, they just wanted to make sure that you do not guess. Okay. But there was no point in putting n greater than 100 or something. So they were just asking something like, uh, which of the following will be at the Deepak, do you remember the question? What they were asking?
हाँ, they were saying that there are n elements in a binary heap represented as array. ओके, तो बाइनरी हीप जो है, बाइनरी मीन हीप जो है वो एरे की तरह एरे में रिप्रेजेंटेड है. सो विच इज बेसिकली द स्टैंडर्ड केस. We usually represent binary heap as array, I think, right?
Yes, yes.
So binary heap is represented as array, and elements are there, and which index cannot have leaf node. Which index? The indexes are starting from 1. Which index have cannot have leaf node? Which index cannot have leaf node?
Yes. So basically, they were saying n is greater than 100, but there was no point in having n greater than 100. You can take n equal to 7, and then you can solve this question easily. I mean, you can just make a small tree. Okay, can take n equal to 7, because they just wanted to make sure you do not I mean, if it is working for n equal to 7, for n equal to 7 also the things are same, right? I mean, the formulation will be same. So you can work with n equal to 7 and you can solve this question. The options were
इसमें
n.
सचिन, एक तो ये जो इंडेक्स है वो 1 से स्टार्ट है, 0 से नहीं है.
हाँ,
एक तो ये चीज थी, एक लिख देना ये कि इंडेक्स स्टार्टिंग विद 1, ये दिया हुआ था.
हाँ,
Okay, so basically the question was asking that which index cannot have leaf node, and four options I remember. One was n, another was n plus 1 by 2, another was n minus 1 by 2, another was n minus 3 by 2. Option C, comma D are correct.
yes.
So
So
only
here
two options are correct.
only two options were correct. It was MSQ question. Okay, you can do this question with a hit and trial. I mean, if you know that, then it is good. If you do not know, then it's fine. So I think the leaf nodes, like, we need to just quickly check, but I think the leaf nodes start from n plus 1 by 2 to n. Okay, so they start from n plus 1 by 2 to n. So whatever is the before that, and I mean whatever before n plus 1 by 2, they cannot be at the leaf. Okay, they are internal nodes. Leaf node start from n plus 1 by 2 to n. Okay. 1, 2, 3, 4. Yes, they start from n plus 1 by 2. So this index is n plus 1 by 2 to n. Okay.
Okay, so
So yes, I think that is all from my subjects. Now COA questions were
हाँ,
remaining.
मैं जल्दी जल्दी उनका आंसर बता देता हूँ. Okay, so let me just quickly go through all the remaining questions of my subject, and I will just quickly share the answers. Okay, so I am sharing. Okay, so let's quickly go through the answers of the remaining questions. We have taken a lot of time because we were providing kind of complete analysis, so we have taken time. But now let's quickly go through the questions. Okay, so let's go through the COA questions. There was a question from cache memory. There was a question from cache memory. Do you remember this question? Direct mapped, comma, full, direct mapped and set associative. Okay, set associative. So let me just give you the answer. This was MCQ question. Only one option was correct. And let me just quickly give you the correct answer. Okay, I will provide you the complete analysis in a different way, in a different session. Okay, because already we have spent too much time. So I'm going to give you the correct answer directly. The complete analysis, if you want, I will provide you in a different session. Okay, in a different lecture. So the correct answer was basically n is equal to m plus l. यही था ना सचिन?
हाँ यही है, करेक्ट है।
N is equal to m plus n, m plus l. This is the correct option. Okay, and this was MCQ question. This will be the answer. Okay, let me go to the next question. Question number 2, addressing mode question.
Yes. So there was indirect addressing mode, pointer, immediate constant.
So in this addressing mode question, there were two columns, the column 1 and the column 2. So in this, basically match the columns. Okay, and in the column 1, we have immediate, right? Immediate addressing mode. Another is indirect addressing mode.
Another one
Another
is
is
base plus offset, base plus index.
base plus index, base plus offset या displacement.
Offset.
Okay, so this was the question. Offset or displacement, I think this was written right, Sachin? याद है कुछ
Yes,
ऐसा
yes.
कि लिखा था?
Offset ही था शायद।
ऑफसेट के ब्रैकेट में शायद डिस्प्लेसमेंट
Okay.
स्लैश करके शायद डिस्प्लेसमेंट भी लिखा था.
Okay.
Okay, so basically this was addressing mode question. Column 1, this contains the addressing modes, and the column 2, you can see in the column 1 we have addressing modes. Okay, in the column 1 we have addressing modes. You can see in the column 2 we have high level constructs. In the column 2 we have high level features, or high level constructs. So high level features we have, for example, in this column 2, let me tell you. Okay, let me just give the answer. So basically with immediate, the matching will be with the constant. Okay, with immediate addressing mode, the matching will be with the constant, and with indirect addressing mode, the matching will be pointer. Okay, and with base plus index, the matching will be element of array. And you can see for the last, I can say the element of record or structure. Okay, element of record or structure. So I think in the question they, Sachin, do you remember like record दिया था कि structure दिया था?
Record ही था।
Okay. So basically, this is the correct answer. I have already given you the directly correct answer. Okay, this is the correct matching. So this was very easy question. Anyone did it wrong? Two COA question we have seen. This addressing mode question, very easy question, very trivial question. I hope you did it correct. This was MCQ question. Okay. And another question we have seen, that is cache memory question. That is also very easy question. Okay, so let me put the category of the question. So I think this was also easy question. Very traditional type question, easy question. It was not hard. This question, this cache memory question was not hard. It was easy question. And this addressing mode question, this was also easy question. Okay, very easy. Now let's see the next question. In the COA, the question number 3, there was a question from hard disk. Do you remember this question? Anyone? Hard disk. Okay, some data was given. For example, 400 sectors per track. Okay, this type of data was given. You can see sector size was also given. I think 1024 bytes. This was sector size. Is this correct? Sector size, I think that was 1024 bytes. This was sector size. Yes or no? Is this correct? 1024 bytes, sector size. 400 sectors per track. Then we have 15,000 RPM, the rotational speed. 15,000 rotations per minute. Okay, so this type of data was given, and seek between adjacent tracks. Seek time between adjacent tracks. That was given. What was the value? Seek time between adjacent tracks. Sachin, याद है क्या?
I think one millisecond. I think it was.
1 millisecond. हाँ 1 millisecond. Yes, yes. So seek time. Okay, this is basically seek time between adjacent tracks. So this we had. Okay, and was there anything else? That head starts at track 0. Okay, and the question was saying that you have to go the order. The order was given that we have to go to track 5, then 12, then 7. Okay, we have to go to track 5, then 12, then 7. And this was the order. On every track, 10 sectors we have to read. Okay, so you can see read 10 random sectors on every track. Read 10 random sectors. Read 10 random sectors on each track. On each of these track. Okay, we have to go to track number 5. First we have to go to track number 5, then we have to go to track number 12, then we have to go to track number 7. Okay, and on every track, like on these 3 tracks, we have to read 10 random sectors. Okay, now I am giving you the answer. What was the answer? Let me tell you. I think the answer was 77.3 millisecond. I think this was the answer. Anyone? 77.3 millisecond. This was the answer. Let me tell you why this answer was coming. Because you can see that if you go to track number 5, see, it's like this. For track 5, what will happen? Okay, let me just quickly, let me just write. For track 5, what will happen? For track 5, the seek time will be how much? That will be 5 milliseconds. 5 milliseconds will be the seek time. This will be the seek time because we have to go from 0 to 5. Okay, from track 0 to track 5 we have to go. So you can see that we will take 5 millisecond of seek time plus then 10 random sector you are reading. Okay, so 10 multiplied by average rotational latency, that is 2. Okay, so this is I can say average rotational latency. Average rotational latency. Okay, then plus I think it was because now you have to transfer also. Okay, so 10 sectors you have to transfer, right? So for that 0.1 millisecond. Okay, so overall this value is coming out to be what? You can see this is for track 5. Okay, let me tell you just directly I'm writing for track 12 what will happen. Okay, these values will be same. Okay, the seek will be 7 plus these values will be same, so 7 plus 20 plus 0.1. And for track 7 what will happen? Again these values will be same, the seek will be 5. Okay, so the seek will be 5 plus 20 plus 0.1. Okay, so you can see seek is 5, average rotational latency that is 20, and 0.1 this is the transfer time for 10 sectors, for 10 random sectors. So finally if you do the summation, you can see 20 plus 20 plus 20 that is 60 plus 5 plus 7 plus 5 that is 17, and 0.1 0.1 0.1 that is 0.3. So your final answer that will be you can see 77.3. Okay, I want to ask all of you one thing. In Go classes all India mock test, also this type of questions you have seen, right? There was a question I have given. I think this year in GATE 2026 we have conducted 6 all India mock tests for GATE CS aspirants. In those 6 all India mock tests I have given I think 3 or 4 questions on hard drive, hard disk. Do you remember? Seek, average rotational latency, transfer time, basically considering all these parameters. So you may have done enough practice in the Go classes, all India mock test, in the mock test, in our lectures. Okay. So this was, I can say this was easy question. It was really not hard question, but maybe for some students it might be moderate. So this question I can keep it in the category of easy to moderate. This type of many questions we have done in our lectures, in our test series, in our mock test, all India mock test. Okay, so you can see this was easy to moderate question. What do you think? This question in which category you will put? Easy, moderate, easy, moderate, or hard? Let me know. In which category you are going to put it? In this question, some student is saying rotational latency is 2 millisecond. See, for one complete rotation, 4 millisecond time will be taken. For a complete rotation, okay, for one complete rotation, 4 millisecond will be taken. So you can see on average, 2 millisecond will be taken. Okay, average rotational latency, that will be 2 millisecond. So this question you can consider like a moderate question. Okay, let's not call it easy, but definitely this was moderate question. Okay, a lot of practice of similar questions we have done in our Go classes lectures also. Okay, so these were questions from COA, and let me discuss some digital logic questions also. In the digital logic, a very beautiful question came. Do you remember in digital logic there is a question, sign magnitude question? Sachin, normally I've seen many students in many coaching institutes also, they teach the overflow condition only for 2's complement representation.
Okay.
Basically, for 2's complement representation, they provide that these are the formulas, you by heart these formulas for 2's complement representation overflow condition. So remember, so far in the GATE exam, before 2026, so far in the GATE exam, they never asked for sign magnitude representation overflow detection condition. But if you remember in Go classes lectures, we have seen overflow detection condition for all the representations, overflow detection condition for unsigned representation, for signed representation, for sign magnitude representation, one's complement representation, two's complement representation. In the Go classes lectures, we have already seen, if you remember, anyone remembers? The sign magnitude overflow detection condition, how to detect overflow. Whatever representation is given to you, how to detect overflow for any arithmetic operation, addition, subtraction, multiplication. So whatever arithmetic operation they give you, whatever representation they give you, how to detect overflow. So that I taught you in the Go classes, lectures on overflow, if you remember. So I hope you were able to solve this question that came in GATE 2026 Set 1 CS. In this question, basically, let me write that the question was, it was a MSQ question, and in this question, sign magnitude representation was given. Sign magnitude representation was given, X was given, Y was given, 8 bits. Okay, let me tell you, if you convert this X to decimal, it will be minus, Sachin, minus 52 मैंने बताया था ना?
एक सेकंड, -52, हाँ.
हाँ. So if you convert this X, of course binary was given, but if you convert this X to decimal, it will be minus 52, and this Y, if you convert, it will be 76. I think Y was 0, 1.
Let me tell you X and Y both. So X is 10110
1011 1011
0100.
0100.
And Y is 0100 1100.
Okay, let's see, is it 76? Yes. So yes, this is basically 64 plus 12, so this is 76. And is this minus 52? This is minus, and this will be 32 plus 16 plus 4, 32 plus 20.
20.
Yes,
Yes.
so this is correct. Okay, so X is this string. or I can say this binary number, and why is this binary number in the sign magnitude representation? And the question was asking overflow occurs. Overflow occurs for. Okay. So overflow occurs for what? And options were given.
X plus
One
y,
option
X
was
minus y.
minus x plus y. Another was x minus y, Sachin.
X minus y, X plus y, minus X minus y.
So these options were there. Okay. And for this question, the answer will be option A and option B. The answer will not be option C, will not be option D. Okay. So the answer will be basically, okay, let me tick here. That answer will be option A, option B, not option C, not option D. Is this clear? Because, okay, what is the logic? Because 8 bits you have, okay, and in 8-bit signed representation, in 8-bit sign magnitude representation, the minimum value that I can store, that is minus 20, minus 1 to 7 to plus 1 to 7. Okay, so remember, if the result is in this range, whatever operation you perform, addition, subtraction, multiplication, division, whatever operation you perform in the sign magnitude representation using 8 bits, this is the range we can store in 8 bits. These are the numbers we can store in sign magnitude representation. So whatever operation you perform, subtraction, multiplication, whatever operation you perform, if the result is not in this range, then there is overflow. If the result is in this range, then there is no overflow. So you can see for option A, B, overflow occurs. For option C, D, no overflow occurs. Okay, very simple. I hope you understood. There was another question in COA, in computer organization. There was another question which was a simple MCQ question. So basically, question 4, it was a simple MCQ question, and this question was that which dependency becomes hazard in the pipeline. Okay, so which data dependency, may become data hazard in pipelined processor. This question was there, and the 4 options were read after write dependency, write after read dependency, write after write dependency, and read after read dependency. Okay, first of all, this is not even a dependency. So you can see, first of all, this read after read, this is not even a dependency. Forget about hazard, this is not even a dependency. Okay, and if you remember in our Go classes pipeline lectures, I told you many times, I told you that in a pipeline, in an in-order pipeline, WAR, WAW, these dependencies can never cause hazards. Do you remember? In Go classes pipeline lectures, I told you this many times. I told you this, that if you have in-order pipeline, if you don't have out-of-order pipeline, if you don't have superscalar system, if your pipeline is in-order pipeline, single issue pipeline, in order, basically all these concepts we have already seen in Go classes pipeline lectures. We have seen what is the meaning of in-order pipeline, what is the meaning of out-of-order pipeline. Okay, in order, out of order. We have seen single issue pipeline, multiple issue pipeline. All these concepts we have seen in Go classes pipeline lectures. And I told you that in pipeline, or I can say by default, in order pipeline, by default, when we say pipeline processor, it means we are talking about in order single issue pipeline. So in an in order pipeline, if your pipeline is in order pipeline, your pipeline is not out of order pipeline, then you can see that WAR, WAW, these dependencies, they can never cause hazard. Okay, they can never cause hazard. So only RAW dependencies, only they can cause hazard in order pipeline. And here this question does not mention whether this pipeline is in order or out of order. By default, we will assume that it is in order. Or also, this question was MCQ question anyway, only one option is correct. So for this question, the answer will be RAW, read after write. These dependencies, they may cause data hazard. Okay, they may become data hazard in the pipeline processor, but WAR, WAW, write after read, write after write, these dependencies, these data dependencies can never become data hazard in a in order pipeline. All these concepts we have already seen. Okay, so this was another COA question. There was one more COA question based on pipeline, but I don't remember the data. It was basically load store, some data was given. Okay, there was a question number 5, pipeline question, but I don't remember this. Okay, do you remember? There was ex stage question was there, and the question was asking that total number of stalls ex stage, some instructions were given, and I can say time tex was given. Okay, some instructions, for example, load instruction was given, and tex that was like 1.2 nanosecond. Okay, like this, some instructions were given and time was given, and the question was asking that for a program of 100 instruction, you have a program with 100 instructions, with 100 instructions, your program with 100 instruction. So how many stalls, how many stalls due to structural hazard, due to structural hazard, due to structural hazard in ex stage. Okay, this type of question was there. Do you remember this question? Okay, I have forgotten this data, the data that was given to you. I have forgotten this data. And do you remember what was the answer for this question? So basically, some instructions were given of different type. Some add instruction was given, integer addition, floating addition, okay, floating point addition. This type of question was there. Okay, and time taken by the ex stage for different type of instruction, that was also given. The question was asking that for a program of 100 instruction, what is the total number of stalls due to structural hazard? This type of question was there. Okay, what was the answer for this question? Let me tell you how I solved this question. Okay, I have forgotten the data and I have forgotten the answer, but basically you can see here, notice one thing, that for this load instruction, the execute stage, it needs 1.2 millisecond. So of course it will take 2 cycles. Yes or no? So you can basically find cycles. Okay, notice what you can do. You can basically find cycles. Okay, to solve this question, what you can do, you can find cycles. So basically this means that it will take 2 cycles here. Okay, and then the next, for example, if the next is, let's assume 1.7, then you can say it was basically 2 cycles again. Okay, if something was, let's assume 2.5 nanoseconds, so it will be 3 cycles. Okay, yes or no? At the end, they were also saying that less than 1 nanosecond, this type of instructions were also there. So for them you can just take 1 cycle. Okay, something like this. So these are the cycles. Do you remember? So what was the answer? Did you get? Okay, what you can do, let me tell you. We need to find the total number of stalls. So what you can do, you can see here, out of these 2 cycles, 1 cycle is stall. Okay, so you can see number of stall cycles. Here 1 cycle, here 1 cycle, here 2 cycle, and so on. Here 0 cycle. Okay, and then you can just multiply with the frequency. Okay, you can just multiply with the frequency. You can multiply with the frequency. Okay, you can multiply with the frequency, and then you can do the summation. Okay, and then what value you will get? Anyone here? Please tell me what value you will get. This was a nice question from pipeline. Did you solve like this? Is there anyone here? Did you solve like this, let me know. Anyone? What will be the answer? What answer we are going to get? Did you solve this question like this? Okay, so this type of question was there. Some student is saying 95. Okay, I don't remember, but okay, let's. Some student is saying that they got answer 95 and this same method they used. Okay, so okay, let's write. Okay, let's not write this answer because a student is also not certain and I also don't remember. But overall, this type of question was there. Okay, when the response sheet will be out, I will provide you the complete analysis of this question also. Okay, but I hope you understood what this question was trying to say. Okay, and how we can solve this question. I hope this is clear. Okay, there was another question. Actually, there were 6 questions from COA. There was another question, load store architecture, easy question. Okay, there was a very, I can say, extremely easy question. Extremely easy question came, and this was load store architecture question. This was load store architecture question. And the question was saying that z is equal to x plus y, where z x comma y comma z, these are in memory. Okay, these are in memory. Do you remember this type of question I provided you in All India Mock Test 1 or 2? Okay, do you remember? Load store architecture, does it click? Is it clicking? In All India Mock Test 1 or 2, this question I provided you where I told you that we have a load store architecture. Okay, and this instruction we have XYZ are in the memory, and we have to find what will be the code, what will be the instructions. Yes or no? Okay, so let me tell you the answer. The answer will be that you load X. The answer will be you load X in the R0. You load Y in R1. Then what you do? Then you perform the addition. In R2, you put R1 plus R0, and then you store. Then you store this in Z, this R2 in Z. Okay, so let me tell you, this will be the answer. This was one of the option, and this will be the answer. This was very easy question. Did you solve it? Did you do this correctly? And do you remember, is there anyone here who remembers that this question was there in Go classes, All India Mock Test in AIMT 1 or AIMT 2? I gave 2 instructions. Load store architecture, everything was same. Instruction was there, and we were asking for the code. Okay, we were asking for the assembly code, or I can say low level code. Do you remember this? Let me know. Okay, so this was another very easy question. I hope you understood. Now let's see the answers for the digital logic questions quickly. So for the digital logic, one question we have seen, sign magnitude representation question we have seen. Let's see the next question. Question number 2. That was exclusive OR question. Some P or P bar or Q exclusive or PQ bar, something was given. Okay, something was given. If you solve it, what you will get? You will get P bar or Q whole bar PQ bar. So this will be PQ. Okay, so I think it was P bar Q. It was P bar Q. Okay, it was P bar Q. So P bar Q. P bar Q. P bar Q. So plus P bar or Q. P bar Q whole bar. Okay, so what you will get here? You will get PQ bar, P bar Q. So this will become 0. Or here what you will get? You will get P bar or Q. And here you will get P or Q bar. So what you will get from here? You will get P bar Q bar or PQ. Yes. Okay. So you can see this question was there. Okay. This was given. This was given. And the question was asking equivalent expression. The question was asking equivalent expression. Some options were given. One option was P XOR Q. Another option that was P XOR Q bar. I think P bar XOR Q. Okay, another option was P bar XOR Q bar. And another option was P XOR Q whole bar. Okay, so you can see for this question, already we have seen that this is actually equivalent to P XOR Q. Okay, P XOR Q, and that is same as P XOR Q complement. Okay, so you can see that the answer will be option D. Also, the answer will be option B because they are basically equivalent. Okay, you can see this is also equivalent to P XOR Q. Okay, so overall for this question, the answer will be these two options. This will not be the option. This will not be the answer. Okay, so this was another, I think, very easy question again. Okay, do you agree? This question, this was another very easy question. It was MSQ question. It was MSQ question. Very easy question. I hope you understood this and I hope you solved it correctly. Okay. Now let's see the next question in the digital logic. There was a question 3, where a function was given to you and the function was on the 4 variables. This function was there, PQRS, and the summation of min terms was given to you. And this was 1, 2, 3, 4, 5, then 7, then 10, then 12, 13, 14. I think this was the question. Do you remember? This type of question was there. And the question was asking minimum, minimized SOP, minimized SOP. It was MSQ question again. So many MSQ questions. You can see this was MSQ question again. Okay, it was asking for the minimized SOP. And for this question, I remember correctly, 2 options were correct, 2 options were wrong. Okay, so for this question, I remember that 2 options correct, 2 wrong. 2 options were correct, 2 options were wrong. Okay, actually, if you make this, if you just quickly make this K map. Okay, so for this function, if you just quickly make this K map, then it will be like PQRS. So this is the area for P, this is the area for Q, this is the area for R, this is the area for S. Okay, and here you can see that 0, 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, 12, 13, 14. Okay, so this type of K-map you will get. In this K-map, you can see this is essential prime implicant. Okay, this is EPI. You must take it. Okay, because of this one. So you can see. And next, you can easily notice that this is another EPI. Again, you must take it. Okay, this is another EPI because of this one. Okay, so you can see these are the EPI. And definitely we must take these EPI. So what will be the minimized expressions? Let me tell you. The correct minimized expression, one will be, you can see this will be Q R bar. Okay, so you can see Q R bar will be there. And this is P bar S, P bar S. Or now you can see we need to cover these 3 ones. Okay, so in one option, they were covering like this. Okay, if I remember correctly, they were covering like this. So you can see this will be P bar R Q bar. Okay, P bar Q bar R. Or you can see they were covering like this. So it will be R S bar P. P R S bar. Okay, so this was one of the correct option. And another correct option was that they were doing like this. And this one they were covering with this. Okay, so here another correct option will be Q R bar or P bar S, or you can see if I do this, then it will be R Q bar S bar. Okay, so you can see Q bar R S bar. Or if I make this, then it will be PQ S bar. Okay, it will be PQ S bar. These will be the correct options. Okay, I hope you understood. So these are the correct options, this one and this one. I hope you understood this. Okay. So for this question, remember two options were correct and two options were wrong. Okay, for this question, two options correct, two options wrong. So this was your digital logic question. Another digital logic question was there. Question 4, that was flip flop, D flip flop. Okay, two D flip flops. Okay, so do you remember this question? Okay, let me tell you, in this question, they have given that there is a variable P. Okay, and some table was given. Actually, it was like this: Q1, Q0, and here you have Q1 plus, Q0 plus. And the question was saying that when P is 0, then we have up counter, saturated up counter. And when P is 1, we have saturated down counter. Okay, so you can see when P is 1, when P is when P is 0, then we have saturated up counter. Up counter means from 0 0 we will go to 0 1. Okay, from 0 1 we will go to 1 0. From 1 0 we will go to 1 1. From 1 1 we will go to 1 1. So did you notice that this is a saturated up counter? Okay, this is saturated up counter. What do I mean by saturated up counter? What does it mean? It is also given in this question. Saturated up counter. Okay, the meaning is also given in this question, because you can see when P is 0, when P equal to 0, then we are going from 0 to 1, from 1 to 2, from 2 to 3, and from 3 to 3. Okay, so you can see saturated up counter means when you go to 3, you will stay 3. Okay, saturated up counter means when we reach 3, from 3 to 3, from top, top means 3, from top to top. Okay, from 3 to 3 means saturation. Okay, and when P is equal to 1, then we have saturated down counter. This table was given in this question. You don't have to remember what is the meaning of saturated up counter, saturated down counter. You don't have to understand the meaning of saturated up counter, down counter to solve this question, because this table was as it is given in this question. Okay, you can see in this table, you can see when we have P equal to 1, then saturated down counter means from 1 1. See, from 1 1 we will go to 1 0. From 1 0 we will go to 0 1. From 0 1 we will go to 0 0. And because this is saturated down counter, so from 0 0 we will go to 0 0. Okay, so you can see when P equal to 1, then we are going from 3 to 2, 2 to 1, 0, and then we will stay at 0. So you can see saturated down counter means you will keep going down. Okay, but on 0 you will stay. Okay, you will be stuck, saturation. Okay, so you can see this is the meaning of this question. Anyway, this table was given, this information was given in this question, and the question was asking, what the question was asking, let me tell you. So this table, okay, given table, given this table was, okay, this table was given, then the question was asking that we are using 2D flip flop to implement it. Okay, we are using D1 D0. To D flip flop we are using synchronous. Okay, synchronous D flip flops we have, we are using them two D flip-flop which are synchronized by the same clock. So synchronous D flip-flop, two D flip-flop we are using to implement it. And the question was asking what will be the expression for D1, what will be the expression for D0. This is what the question was asking. Okay. So you already know one thing. See, the question is actually very simple. Do you remember that in the D flip-flop, whatever is the value of D, that will be Q next? Do you agree with me? Q next is same as D in the D flip-flop. In the D flip-flop, we already know this, that the Q next, that will be same as D. Whatever D you apply, that will be Q next. Whatever is Q next, that is your D. So Q next and D, they are basically same. Yes or no? So now what you can do, remember, in this question, you don't have to do anything. This Q1 plus, is your D1, and this Q0 plus, this is your D0. That's it. That's it. You can see that this is your D1 and this is your D0. Because remember, in D flip-flop, if you have a D flip-flop, this concept we have already seen that in the D flip-flop, the Q next, or I can say that Q plus, Q next, that will be same as D. So you can see this Q next, this Q1 next, this is D1, Q0 next is D0, nothing else. Extremely easy question. So finally I can say that remove this Q1 next, Q0 next, forget about all these things. Okay, just say that this is D1, this is D0, that's it. Okay, now you can see what will be D1. Now you can find what will be D1. You can just make the K map. Okay, so you can see that this will be the K map. Here you can see we have P Q1 and here Q0. So this is the area of P. This is the area of P. This is the area of Q1. This is the area of Q0. Okay, and you can see this table we already have. Okay, so you can see 1, 2, 3, and then 7. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, so finally what will be D1? D1 will be what? That will be, you can see, P bar Q1. Okay, it will be P bar Q1 or Q0 P bar Q0. Okay, this is P bar Q0. This is P bar Q1 and this is Q0 Q1. This will be the D1. Okay, that's it. This is the answer for D1. The question was asking what is D1, what is D0. So this is the answer for D1. What is the answer for D0? Similarly, you can find the answer for D0 also. You can see that here you have P Q1, here you have Q0. Okay, this is the area for P. This is the area for Q1. This is the area for Q0. And you can see here we have 0, 0, 2, 3, and 6. So 0, 1, 2, 3, 4, 5, 6. Yes. Okay. Now, what you will do here? So you can write the D0 equation. So what will be D0? That will be, you can see that will be P bar Q1. Okay. This will be P bar Q0 bar. P bar Q0 bar. And this will be Q0 bar Q1. Okay, Q0 bar Q1. Okay, that's it. I hope you understood. Did you do this correctly? This was an easy question. Okay, let's call it moderate. This was not a hard question, remember. This question, you can say it was basically moderate, or I can say easy to moderate. See, this question was so easy. Why I am saying that this question was so easy? Because you already know that in a D flip-flop, the Q next is same as D, the Q next is same as D. So this Q1 next will be D1, Q0 next will be D0. That's it. Your question is over. Finish. So please tell me, Did you understand this explanation? Also, did you do this correctly in the gate exam, in the set 1? Did you do this correctly? What do you think? This question was easy, hard, moderate? What type of question was this? Very simple question. It was not hard. Okay, I hope you understood this. So we have seen digital logic questions. Is there any other digital logic question that I have forgotten to consider? We have taken the question from sequential circuit. I think there was no question from multiplexer, decoder, all these concepts. So basically from the combinational circuit, there was no question. Any other question do you remember? Sequential circuit, there was one question we have taken. Combinational circuit, there was no question. No question from multiplexer, decoder, encoder, from priority encoder, from demultiplexer, from adder, from ripple carry adder. Basically, half adder, full adder. Basically, from the combinational circuit, there was not a single question. Okay. Exclusive OR question we have seen. Minimized SOP question we have seen. Sign magnitude overflow detection condition, that question we have seen. Is there any other digital logic question that we missed? Please let me know. Okay, so let me quickly discuss the compiler design questions and their answers. Compiler design. Let's discuss the questions and answer. There was a question in compiler design from available expression analysis. Common sub expression. Okay, yes or no, redundant? The question was saying common sub expression. The question was also saying that this was redundant expression. Okay, and the question was asked, basically this question was based on available expression analysis. We have already studied in Go classes lectures in a very detailed way available expression analysis. Okay, do you remember in the Go classes lectures this available expression analysis, this concept we have seen in a detailed way? I told you for a single statement how to perform available expression analysis, for a basic block how to perform available expression analysis, for a control flow graph without cycle, for a control flow graph with cycle, basically for all the variations, for all the varieties, how to perform available expression analysis, and then based on this analysis how to perform common sub expression elimination. All these concepts we have already studied in Go classes lectures, and this question came. You can see the question was asking that common sub expressions. The question was asking common sub expressions. Common sub expressions in block B4, block B5. Okay, this was the question. Let me tell you the answer. Okay, this was a MCQ question. It was MCQ. So let me tell you the answer. What will be the answer for this question? Let me tell you that for basic block B4, the answer will be G into K. That's it, nothing else. So in this basic block B4, G into K, that was redundant expression. And in basic block B5, there was nothing redundant. Okay, means empty. So let me tell you, this will be the answer. This will be the answer. This was one of the options. So in the basic block B4, G into K, this expression will be common sub expression, or I can say this will be redundant because we have already computed this before entering the basic block B4. Okay, if you notice a control flow graph was given. So if you do the available expression analysis, you will realize that before, or I can say at the entry point of B4, let me tell you, at the entry point of B4, this expression was alive. Okay, this expression was available at the entry point of B4. This expression was available, and this expression we are using in this B4. Basically, this expression we are computing. Again, I am telling you that this expression was available expression at the entry point of B4, and this expression we were also computing in this B4. So in this B4, this expression will be redundant. But in the basic block B5, there is no redundant expression. In this basic block B5, let me provide the explanation that in the basic block B5, we are computing C plus M. we were computing something like this. C plus M we were computing in basic block B5. Okay. But remember that at the entry point of B5, this C plus M was not available. At the entry point of B5, this C plus M was not available. So in the basic block B5, we are computing C plus M, but at the entry point of B5, C plus M, this expression was not available. So in this basic block, this C plus M, this is not a redundant expression. Okay. So here you can see that C plus M not available. C plus M not available. Okay. That is the reason in basic block B5, there is no redundant expression. But if you notice this basic block B4, here we are computing this G into K, we are computing. One more expression we are computing. But here G into K is available. Okay, is available. So that is the reason in this basic block B4, this G into K, this was redundant, or I can say common sub expression. So for this question, the answer will be this one. Let me tell all the students, in Go classes compiler design lectures, we have seen live variable analysis, available expression analysis. These are the two analyses. Based on live variable analysis, we have applications. For example, register allocation, we have studied. Also, based on live variable analysis, we have another optimization, that is dead code elimination. So based on live variable analysis, we have two optimizations. One is dead code elimination, another is register allocation. Both these applications we have studied. We have studied the live variable analysis also. There is available expression analysis, that also we have studied. The complete coverage of available expression analysis we have done for control flow graph, with cycle, without cycle, for basic block, for single statement, everything. Based on available expression analysis, we have two optimizations: common sub expression elimination and copy propagation. Okay. So everything we have studied in the Go classes lectures. The available expression analysis, that is a forward analysis. We go from top to down. Okay. And the live variable analysis, that is a backward analysis. We go from bottom to top. Remember, with every analysis, a direction is associated. Live variable analysis is a backward analysis. Means you start from the bottom and you go in the reverse direction. The available expression analysis, this is a forward analysis. You start from the top and you go in the forward direction. Okay, I hope you understood all these concepts we have already studied in the Go classes compiler design lectures. So did you solve this question? This was the first time a question came from available expression analysis. Let me tell you, so far in the GATE exam, available expression analysis, from this topic, no question came before GATE 2026. But still, before GATE 2026, already in Go classes compiler design course, you can find available expression analysis. Even though before this year, before 2026, there was no question in the GATE PYQs from available expression analysis, but still we taught it. The complete coverage we did. And finally, our efforts were rewarded. Go classes efforts were rewarded, and this question came in set 1 of GATE CS 2026. I hope you were able to solve it. Let's move on now. So this was compiler design question. The answer I told you. Now let's see the next compiler design question. So some students are asking some doubt. Let me see. In the previous question, a student is asking, sir, C plus M was not available just before B4, but was present above. Was it not redundant? C plus M, that was not even in the B4, if you remember, I think. Okay. I remember very clearly, okay, that this is the answer. The answer that I gave you, this is the answer. I remember very clearly. Okay. I attempted set 1. I was solving the question, and I remember very crystal clearly that the answer that I provided you, this will be the final answer. Okay. Now I have forgotten what was the actual control flow graph. Okay, what were the statements? But I remember the final answer. I remember. Okay, and the logic also I told you what was the actual logic, the explanation, the logic, everything we have seen. In the compiler design, there was another question. Question, question two. This question actually Sachin sir has already discussed, but there was one particular option that I want to discuss. Basically, this question was related to compiler errors. Compiler errors. Sachin sir has already discussed this question, but there was a particular option that was interesting option. Okay, so basically you know that statement 1 was there, statement 2 was there, statement 3 was there. And in this statement, it was char star str, okay, is equal to hello, and then this. So you can see unterminated string. Okay, unterminated string you can see. So next, you can see this was unterminated string. And when we have unterminated string or unterminated comment, okay, so when we have this unterminated string, then this unterminated string, you already know this is lexical error. Okay, this is lexical error. Remember, this is not syntax error, and there was an option that is this syntax error or not. Okay, so this is lexical error. This is not syntax error. Okay, this was an option actually. That's why I'm telling you that this was a lexical error. Unterminated string. This will be a lexical error. Okay, and because this is a lexical error, remember, it is not a syntax error. Please understand, because already in the lexical analysis phase, this error will be caught. Okay. Also remember one thing, that the lexical analyzer will read your source text and it will convert your source text into a series of tokens, and those tokens will be the input for the syntax analyzer. So remember, for the parser, for the syntax analyzer, the input will not be your source text. The input will be sequence of tokens. The lexical analyzer will convert your source program, source text, your character stream into token stream. Your source program, that is a character sequence, or I can say character stream. Okay, on the keyboard, whatever button we press to write the source program, every button that we are pressing, that is a character. Even the space button, if you are pressing 5 times, these are also characters, null, blank characters. Okay, but you can see the lexical analyzer will read your source text, and this source text, which is character sequence, character stream, it will be converted into token stream. This token stream will be given to the syntax analyzer. For the parser, for the syntax analyzer, the input will be token stream. Okay, and you can see that here, because of this unterminated string, we will get lexical error. I told you in the Go classes lecture what are the possible lexical errors, what are the possible syntax errors, what are the possible semantic errors. All these things we have discussed in a very detailed way. Okay, so very easy. This S1, this is lexical error, but remember, this is not syntax error. And there was one option. There was one option saying that S1 has lexical error, S3 has semantic error. This option was there. S3 has semantic error. But there was another option. Okay, or let's see option B. There was another option. It was saying that S1 has syntax error. S1 has syntax error and S3 has semantic error. This was MSQ question, I think. Okay, so for this question, remember, the answer will be option A, but not option B. Okay, I hope you understood. And of course, the remaining, you can see S2 has no error. S2 was nice statement. There was no error. It was hello, like this. Okay, so of course this is a string. Don't worry about it, because overall this complete thing is a string. So there is no error in the S2. And in S3 we have int star str, and we are putting hello. Okay, so this character string is there, and we can see this is a character string and this is int star. So this is a type mismatch. Yes or no? So S3 has semantic error. Okay. Overall, I can say that S3 has semantic error. Semantic error. With semantic error, type mismatch. Type mismatch. Okay. S2 has no error. And S1 has lexical error, not syntax error. Okay. So this option was there that S1 has syntax error, S3 has semantic error. So that is wrong because S1 does not have syntax error. Okay. So this was compiler design. Another question. Let's see another question in the compiler design. There was a question number 3, which was based on LL1. LL1 question. Okay. This was also MSQ question. In this question, the options were like this. The first option was that LL1 more powerful. LL1 more powerful than SLR. Remember, LL1, SLR, they are uncomparable. Okay. So remember this point that LL1 you cannot compare with SLR. LL1, SLR, they are not comparable. Not comparable. Okay. Actually, LL1 is also not comparable with LALR also. Okay. This misconception some students have that LL1 is more powerful than LALR or LL1 is less powerful than LALR. Remember, these are also not comparable. Okay, these are also not comparable. But yes, LL1 is less powerful than LR1. Yes, this is correct. Okay, so overall, if you notice, it will be like this that if these are LL1 grammars, then these are SLR grammars. Okay, similarly, if these are LL1 grammars, then these are LALR grammars. Okay, but remember, if these are LL1 grammars, then these are LR1 grammars. Okay, so you can see that option A, LL1 is more powerful than SLR. So this option A, this is a false. Okay, option B was LL1 grammars. To be LL1, to be LL1, it must be G must be to be LL1, G must be left recursive. Left recursive. Okay, of course, this is also false because if the grammar is left recursive, it can never be LL1. Okay, option C, that is to be LL1, G must be left factored. Yes, this statement is true. Okay, because if your grammar is not left factored, then it is not LL1. Okay, the question, remember the option is saying to be LL1, grammar must be left factored. It means what this statement means. It means if the grammar is not if the grammar is not left factored, if the grammar is not left factored, then it is not LL1. Yes, that is true. If the grammar is not left factored, our grammar cannot be LL1. So the option is saying to be LL1, grammar must be left factored. This is true because this statement means that if the grammar is not left factored, then it is not LL1, and this statement is true. Okay. So I hope you understood. Actually, there is one misconception that some teachers also teach, and some students also have some misconception. Students get very confused, or I can say students have misconception in left factored and left factoring. Remember, left factored is basically a good thing from LL1 point of view. Okay, I hope you understood. Basically, if your grammar is not left factored, then the grammar is not LL1. If your grammar is not left factored, then we can convert this to left factored grammar by a procedure that is called left factoring. So if your grammar is not left factored, if your grammar is non-left factored, then using the procedure called left factoring, using that algorithm, we can convert this grammar to left factored grammar. And this left factored grammar, this is a good thing for LL1. Of course, left factored does not mean it will be LL1, but to be LL1, it must be left factored. Means if the grammar is not left factored, it cannot be LL1. Okay, I hope you understood. So this was option C. What is option D? Anyone remembers? LL1. Yes, LL1 needs backtracking, uses backtracking. Yes or no? Needs or uses backtracking. So LL1 needs backtracking or uses backtracking. That is also false. We have already seen this very clearly in our lectures. I told you that we have two type of top-down parsers. Top-down parser, we have two type of top-down parser. One is with backtracking, another is without backtracking. With backtracking, we have a recursive descent parser. Without backtracking, these are called predictive parser. They will use a predictive table. And the example is LL1. LL1 parser, these are predictive parser. They will use a LL1 parsing table. So they are predictive parser. So they don't do backtracking. The recursive descent parser uses backtracking. Okay, top-down parser are of two types. I told you in the Go classes lectures very clearly. And on the Google, on the YouTube, you can search recursive descent parser Go classes on the YouTube. If you want to study everything about recursive descent parser, if you want to solve Ullman exercise questions, standard Ullman book questions, if you want to solve, then you can just search on the YouTube recursive descent parser Go classes. That lecture you can watch to understand all about recursive descent parser with standard questions, Ullman exercise questions I have solved. Okay, now let's move on. So I hope you understood the analysis for this question. So this was MSQ question, but for this question only one option is correct, that is to be LL1 the grammar must be left factored. Did you do this correctly? This particular question, did you do this correctly? This was an easy question. Okay, now let's move on. What was another question in compiler design? Anyone remembers? Question number 4. So there was LL1 question we have done. Available expression analysis question we have done. Compiler error question we have done. There was SDD question. Okay, there was SDD question. Anyone remembers it? There was SDD question. So two grammars were given. G1, G2, two grammars were given. Two SDD were given basically. Okay, SDD1, SDD2. Okay, I don't remember the exact SDD1, SDD2, but let me tell you which options are correct, which options are wrong. Okay, let me tell you the answer. That's what matters, right? So there was one option that languages L of G1 is equivalent to L of G2. What do you think? The languages were equivalent or not? What do you think? LG1, LG2, the languages, are they equal or not? There was another option that SDD1 uses the SDD1 uses all inherited attributes. Only inherited attributes. Okay. There was another option. SDD2 uses only synthesized attributes. Okay. For this question, there was another option that SDD1, SDD2 store same info in symbol table for identifiers. For identifiers. Okay. So let me tell you, the languages were same. Okay, let me tell you the answer. The languages were same. If I remember correctly, the languages were int or float. If I remember correctly, the language were int or float id whole plus. Do you agree with me? Please tell me. So basically, this SDD question was there. Syntax directed definition. Two syntax directed definitions were given: SDD1, SDD2. What they were doing? They were basically finding the type information. They were storing the type information of identifiers in the symbol table. Okay. These SDD1, SDD2, both were doing the same, basically, both were doing the same task, that they were storing the type information for the identifiers. They were storing the type information in the symbol table. Okay. And the question was asking that, is the language of the two grammars same? So yes, the language was same, and I think this was the language, if I remember correctly. Option B was SDD1 uses only inherited attributes. This was false. SDD1 was actually using both inherited attributes as well as synthesized attributes. Actually, this was L attributed. Okay, let me tell you, this was actually L attributed grammar. Okay, it was using it was using both inherited and synthesized attributes. Some attributes were inherited, some attributes were synthesized. In SDD2, it was S attributed grammar, means all the attributes were synthesized. Okay, so it was S attributed grammar. Now you can see option C was actually true, and option D, if I remember correctly, option D was also true. Okay, both save the same type info in the symbol table. Okay, so for this question, the answer will be A, C, D. Guru Prasad, what did you do in this question? Anyone here who did it correct this question? Go classes, SDT, SDD, all these lectures I put on the YouTube. Many students actually, who I can say, who have some kind of misconception in these topics, SDD, SDT. Actually, many students, they don't even understand that SDD is different from SDT. There is something called syntax directed definition, and there is something called syntax directed translation scheme. Both are different concepts. Second thing, SDD, this is good for high level specifications. SDT, syntax directed translation scheme, this is good for implementation, for execution. Okay, we can convert SDD to SDT. In Go classes lectures, we have already seen this, that how we can convert S attributed SDD to SDT, and how we can convert L attributed SDD to SDT. Do you remember all these concepts we have seen? We have seen evaluation of SDD, evaluation of SDT, the dependency graph concept to evaluate SDD. Okay, how to evaluate S attributed SDD, how to evaluate L attributed SDD, what is the relationship between SDD, different types of SDD, and parser. Okay, also we have seen what is circular SDD, which SDD we can never evaluate. There is something called circular attribute grammar. What is attribute grammar? What is side effect? Every concept related to SDD, SDT in the Go classes lectures we have seen, and these lectures are available on the Go classes YouTube channel. All you have to do, just search SDT Go classes or SDD Go classes. Okay, these are different concepts. If you want crystal clarity, like what is the side effect, what is attribute grammar, what is circular attribute grammar, okay, what is circular SDD, how to evaluate, everything, all the variety of questions we have done in our lectures. Okay, So for this question, the answer will be option A, C, D. And in this D, let me put a star here for now. Okay, that I will confirm this when the response sheet will come. Okay, is this clear, Guru Prasad? So we will confirm. I can say we will confirm. Will confirm after response sheet. But if I remember correctly, it was correct option. Okay. The other options, option A is definitely correct, option C is definitely correct, option B is definitely wrong. But option D, that I will confirm after the response sheet is out, then this option D I will confirm. But as long as I remember, when I was attempting in those 3 hours, as long as I remember, it was correct. But still, the confirmation I will give you after response sheet is out. Okay, we will see, don't worry. So Guru Prasad, don't worry right now. Okay, I'm telling you that I'm putting this star star. Maybe you are right. Okay, so I will provide the confirmation after the response sheet will be out. Okay, let's see the next. Was there any other question in the compiler design? Anyone remembers any other question in theory of computation, compiler design, discrete mathematics, DBMS, COA? Any other question? A lot of questions we have seen, but what do you think? Any other question? Did we miss some question? Anyone? Sachin, are you here? Tell me. Actually, थोड़ी देर पहले my wife gave me coffee, but now it has gone cold. Okay, कॉफी थी ठंडी हो गई. मैंने रखी थी बगल में कि बीच में टाइम मिलेगा तो पी लूंगा, लेकिन अभी वो हो चुकी है ठंडी. कोई बात नहीं. So, any other question did we miss? Please tell me. Let's see. IEEE question was there. I don't remember it because I could not solve it during the exam. Okay, I can say, running out of time. Actually, I spent too much time on some questions which were very good. There was a pipeline question, very good question. There was a theory of computation question. Do you remember that? Number of A, number of B, number of A is less than equal to twice the number of B. So that type of question was there. So there were some very good questions. In these good questions, I spent a lot of time. There was another matching question was there, that took a lot of time. Foo bar question was there, that took a lot of time. Okay, so basically cute cup, show us again. अच्छा, ये क्यूट कप है क्या ये? ओके ओके, कुछ ऐसा सा ही है, इतना कोई क्यूट तो नहीं है. Something like this. Okay, please tell me, did we miss any question? See, IEEE question I don't remember. Anyone want to tell me answer? If you are confident in the IEEE question, can you tell me the answer? Let's write the answer for that. There was a IEEE question, floating point question. Anyone who is very confident that his answer is correct, can you tell me? Tell me the answer, please. Match the addressing mode we have discussed. Abhishek, the addressing mode question we have already done the discussion. Guru Prasad, you are sure that this is the answer? I just want to write the answer. Anyone want to tell me the answer? L1 L2 वाला सवाल, ये कौन सा सवाल है? L1 L2 वाला. Heath Prajapati is saying the answer was 35 C80000. Is it correct, Heath? This was the final answer. I am asking the final answer. Was this the final answer? Heth and Guru Prasad, if you both got the same answer, then it must be the correct answer. If you both got the, if you both are getting the same answer, of course it is correct answer. Gate will change it and make it correct answer. Okay. 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 So for the IEEE question, this will be the answer. Okay. Any other question did we miss? There were some more question. Let's quickly just write the answer for those. There was a probability question. Do you remember? Ball, red ball, something probability question. Anyone remembers the answer? Just tell me the final answer. Let's write the final answer. There was a linear algebra question also, multiplicity of eigenvalues. Just let's write the answer. Multiple linear algebra eigenvalues question. So tell me the answer for this probability question. Anyone remembers? 1 by 3. Okay, students are saying 1 by 3. So let's do 1 by 3. Okay. So for this probability question, the answer will be 1 by 3. And what about this eigenvalue question? In the linear algebra, the multiplicity, that will be n. This is the answer. This is the answer. Okay. Very good. Very good. Excellent. So probability question, we have done. The answer is 1 by 3. Linear algebra, eigenvalue, multiplicity question we have done. The answer will be n. What do you think? How many questions we have done? Did we do all the 55 questions of the technical part? Did we miss any question in the technical part? What do you think? In the technical part, if there is any question that we missed, please let me know. I think now we can discuss the aptitude questions also. Sachin sir remembers the aptitude question. Okay, so let me just call Sachin sir and invite, okay, to discuss the aptitude questions. Heth Prajapati is saying that I guess 46 questions we have discussed. Only 46 out of 55, only 46. 9 questions did we miss? TOC में L1, L2 we have done. The L1, L2 question of TOC we have already discussed in this lecture at the beginning. Okay, you can check it. Other than aptitude question, can anyone tell me any technical question did we miss? Just stay with me, okay? I'm calling Sachin sir, okay, to discuss the aptitude questions. Just stay, okay? Don't leave this session, please, okay? Hello, Heth Prajapati and Guru Prasad, can you join this live session so that we can discuss the aptitude questions and the remaining questions? I am sharing the link with you. See, on the WhatsApp, Heth and Guru Prasad, please check. I have shared the Zoom link with you. Please join this session and let's discuss all the remaining questions. Hello, Heth, Guru. Let's finish this set 1. Let's not leave any question. All the 65 questions let's do. In the technical also, please let me know which questions we skipped. Probability question we have already done, right? 1/3 will be the answer. Any other question? सचिन, एक प्रोबेबिलिटी का एक और क्वेश्चन था कुछ. अरे हाँ, एक x इक्वल टू 1 कुछ एक्सपेक्टेशन पूछी थी.
हाँ 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 हाँ, उसका क्या था आंसर है?
4 पॉइंट मेरे को भी याद आ रहा है, कुछ 4.25 था क्या? एक्सपेक्टेशन पूछी थी.
हाँ
तो
हाँ
उसको जैसे था
हाँ
1/6 को मल्टीप्लाई करना था मेरे ख्याल से. 1/6 को मल्टीप्लाई करना था और 1/12 को मल्टीप्लाई करना था.
हाँ
ऐसा
हाँ
सा
हाँ।
कुछ क्वेश्चन था, याद आ गया मुझे. हाँ, मैं एक बार उसको शेयर कर देता हूँ. सो देयर वाज प्रोबेबिलिटी क्वेश्चन. आई थिंक दे हैव जॉइंड. हेलो.
हेलो सर.
हेत और गुरु.
हाँ सर, गुरु बोल रहा हूँ.
हाँ गुरु, रीनेम कर लो. हेलो हेत. गुरु, आप एक बार रीनेम कर लो. हाँ, okay. So let's discuss. Actually, there was a question. If you remember, Guru and Heth, if you remember, there was a probability expectation question. This was so easy question, even I did it. वैसे तो सचिन का सब्जेक्ट है, लेकिन मैंने भी कर दिया. इतना इजी क्वेश्चन था ये. So for this expectation question, do you remember what was the data that was given? Like it was, I think, that probability that x is equal to 1. This was equal to probability that x is equal to. What was this question?
1, 2, 5 and 7. They have 1/6 probability.
Okay, so these values have 1/6 probability,
And
and
3, 4, 6 and 8 have 1/12.
3, 4, 6, and 8, they have 1/12
1/12.
probability. And the question was asking what is the expected value of x. So I think the answer will be very simple. It will be 1/6, and here we can just do 1 plus 2 plus 5 plus 7. Is it correct, Sachin?
Yes, yes.
1/12, 3 plus 4 plus 6 plus 8. Okay. Basically, it will be like 1 into 1/6. Okay. With this probability, x value is 1. With this probability, x value is 2. With this probability, x value is 5. So 1 into 1/6 plus 2 into 1/6 plus 5 into 1/6 plus 7 into 1/6. That will be overall this. 3 into 1/12 plus 4 into 1/12 plus 6 into 1/12 plus 8 into 1/12. So that will be this. And I think if we calculate this, then what we are going to get?
51 divided by 12 total.
Okay.
4.5.
So what we will get? 51.
हाँ,
यही है क्या? 51/12. फिर आंसर क्या आ रहा है इसका?
4.25.
4.25. हाँ, if I remember, it was the correct answer. 51.
सही है.
51 divided by 12. Yes. So the answer for this question will be, this is the final answer. Okay. Yes, Guru, we will discuss now all the aptitude questions. Any other technical question did we miss? Okay, let's first discuss the aptitude questions line by line. Okay, so let's discuss all the aptitude questions. जो जैसे जैसे याद आ रहा है जल्दी जल्दी बताओ आंसर सीधा. direct answer. Okay, so let's see the question number 1. What should be the question number 1? Heth, you can speak. Guru, you can speak.
One question was the what is the opposite of protagonist?
Okay, opposite of protagonist.
Yes.
ये तो मैंने बहुत मूवीज के अंदर, ये तो इतना बहुत इजी हो गया ये तो शायद.
सर मैंने तो
Okay.
डॉस्टोयेव्स्की की बुक रीड करी थी एक, तो वहां से पता चल गया था.
कौन सी बुक क्रिएट करी थी?
क्रिएट नहीं, डॉस्टोयेव्स्की की बुक है, तो लोग
अच्छा,
प्रोटैगोनिस्ट बोलते हैं.
ओके.
सो
एक्चुअली मूवीज में या टीवी शोज के अंदर ये वर्ड बहुत बार आता है कि प्रोटागोनिस्ट कौन था, एंटागोनिस्ट कौन था, इस तरह के वर्ड्स मतलब बहुत बार आते हैं ये. आई थिंक इट हैज समथिंग टू डू विद हीरो वर्सेस विलन, इफ आई रिमेंबर करेक्टली, राइट? इज इट करेक्ट? Hero versus villain, something like that. So just give me a sec. Okay, so what will be the answer for this question? Antagonist.
Yes, antagonist.
Okay, so the answer will be antagonist. Yes. Okay, so this was the question. Another question, question number 2.
There were 64 players and match is played between each of them. Then how many total matches are played?
64 players playing matches. Okay, so you can see total will be, I think, 64 C2. That's it. That will be the answer.
No, I think 63 was the answer.
63
63.
was the correct.
एक सेकंड, क्वेश्चन क्या था? क्योंकि अगर 64 प्लेयर्स आपस में अगर मैचेस खेलते हैं तो वो 64 C2 हो जाएगा ना.
I mean, one will win and one will lose, like
सर
this.
हाँ,
सर
So
इसमें क्या है
basically,
कि
it's like knockout game, and so total how many
अच्छा.
till the one person remains. Like how many games we need to play, so that finally only one person will win.
ओके ओके, मतलब ऐसा नहीं है कि हर पेयर के बीच में मैच हो रहा है.
नहीं नहीं.
ओके 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 ओके. सो मुझे लगा कि हर पेयर के बीच में अगर मैच होगा तब तो 64 C2 हो जाएगा. ठीक है. सो फॉर दिस क्वेश्चन द आंसर विल बी
63.
63. ये टूर्नामेंट प्रॉब्लम है. ये तो आई थिंक मल्टीपल टाइम्स आई थिंक वी हैव सीन दिस इन आवर क्विजेस एंड टेस्ट सीरीज, आई थिंक, सचिन.
yes sir, exact same question Sachin sir did, like he did for n equal to 1000 and answer we were getting was 999. so logic इसमें ये है कि अगर exactly one match will knock out one player, exactly one match will knock out one player, बाहर निकल जाएगा, तो टोटल 999 टोटल 63 मैच हमें खेलनी पड़ेगी, तो 63 प्लेयर्स निकल जाएंगे और एक
Yes.
बचेगा.
Yes, yes. This is actually a famous problem, tournament problem. And there, Sachin, if you remember, there was one probability question we have put in our test series. In last year All India mock test, we have put a probability question, if you remember, 64. And this tournament, based on this tournament problem, this
I think
you were saying that this is like most like very good question in probability and tournament, basically tournament problem plus probability. Okay, so yes, this is actually a famous problem, tournament problem. Many times I think similar questions, as Guru is saying, Het is saying, that this question was already present in the Go Classes test series, where Sachin sir has given 1000 players are playing the matches in the tournament problem. So the answer will be 999. Okay, so very good, I think. So this question basically already present in our test series. कोई टेस्ट आपको याद है क्या कि किसमें था, गुरु?
हाँ, अगर वो आपको मिले ना उसका लिंक भेज
सर
देना आप.
मुझे याद है, लाइक एग्जैक्टली आई रिमेम्बर सचिन सर ने इवन लेक्चर में करवाया, टेस्ट सीरीज में मुझे पता नहीं, बट
ओके
लेक्चर में
ओके
तो कई करवाया है. आई विल सेंड यू द स्क्रीनशॉट वंस आई विल गेट, आई विल गो थ्रू द अनोटेटेड नोट्स, बट करवाया तो है. एंड ही डिड फॉर n इक्वल टू 1000, सो आई रिमेम्बर्ड एग्जैक्टली सर.
ओके.
ओसम ओसम ओसम. फिर तो मतलब बिल्कुल इमीडिएटली कर दिया होगा इसका क्लिक की. ठीक है, 63.
लाइक सर जैसे ही मैंने क्वेश्चन रीड किया वो सचिन सर का याद आ गया, एंड आई जस्ट टेक, लाइक मैंने सॉल्व भी नहीं किया.
वेरी
ओ
गुड, वेरी गुड, ऑसम ऑसम. सो एनी अदर एप्टीट्यूड क्वेश्चन? क्वेश्चन नंबर 3, ये नीरज चोपड़ा का क्या चल रहा है, ये जो क्वेश्चन है?
हाँ, एक क्वेश्चन था नीरज चोपड़ा से रिलेटेड कि वो फोर्थ, उसका आई थिंक फोर्थ है या थर्ड है, पता नहीं।
उस क्वेश्चन
फोर्थ
का
है
आंसर
शायद।
क्या है, मतलब नीरज नीरज चोपड़ा रिलेटेड क्वेश्चन है, राइट?
हाँ।
ओके, आंसर क्या है उसका?
गुरु सिंह थर्ड और हेते सिंह फोर्थ, आई थिंक।
क्या क्वेश्चन क्या था, अपन सोल्व कर सकते हैं क्या अभी, अगर क्वेश्चन पता है तो?
उसमें तीन कुछ प्लेयर थे और 6 राउंड्स में मतलब फाइनली नीरज चोपड़ा जीतता है
मोस्ट
और
मोस्ट ऑफ द स्टूडेंट्स आर एक्चुअली सेइंग 3, आई थिंक सो।
सर लाइक मैं थोड़ा बहुत याद है मुझे, लाइक टोटल 6 राउंड्स वर देयर,
हम्म
एंड फर्स्ट 2 राउंड में नीरज चोपड़ा कुछ अच्छा परफॉर्म कर रहा है, एंड लास्ट 2 जो मैच हो रही थी उसमें जो दोनों बाकी जो प्लेयर थे वो लोग फॉल हो गए थे, मतलब ऑफ कोर्स 5 and 6 इज नॉट आंसर, एंड 1 and 2 इज ऑल्सो एलिमिनेटेड। और एक प्लेयर था जिन्होंने अच्छा किया था, मुझे जहां तक पता है 4th राउंड में अच्छा किया था, दैट वाज नॉट आस्क्ड, सो एक ही ऑप्शन बचा, लाइक सो थ्रू दिस लॉजिक आई टिक्ड आई थिंक 3rd राउंड,
ओके
क्योंकि
ओके।
ऑलरेडी मेंशन था कि 4th राउंड में जो वो दूसरा प्लेयर है जिसके बारे में नहीं पूछा था, वो
हम्म
वहां में उन्होंने बेस्ट करा था, सो सो डेफिनेटली 3 इज मतलब बचा है, नॉट सो
ओके।
मच श्योर बट जितना पता है लाइक इतना ही पता है मुझे।
हेत, आपने 4 किया है, आपका मतलब आप यू हैव डन 4, राइट हेत?
यस, बिकॉज उसमें जो स्टेटमेंट्स थे उसमें एक स्टेटमेंट था कि जो जिसके प्लेयर के बारे में बताना है, वो 4th राउंड में उसने बेस्ट परफॉर्म लास्ट 4th राउंड में किया था, उसके बाद उसने बैड परफॉर्म किया। इसलिए मैंने 4th राउंड किया कि अगर बेस्ट उसका 4th राउंड में है तो वो फोर्थ होगा, थर्ड में पता है नहीं, दैट्स वाई।
ओके, सो लेट्स डू वन थिंग, लेट्स कीप इट ओपन, आई थिंक सचिन, नहीं क्या?
हाँ, मैंने भी शायद 4 किया था, बट हो सकता है 3 आंसर हो,
ओके
बिकॉज देयर
सो
मेनी स्टूडेंट्स आर सेइंग 3।
आई कैन से we'll discuss later, or put a comment, I can say, put answer in comment.
एक क्वेश्चन था जिसका ग्राफ वाज गिवन एंड देन दे वर आस्किंग फॉर द इक्वेशन ऑफ द ग्राफ, समथिंग लाइक दैट।
ओके, इक्वेशन पूछी थी,
हाँ।
ठीक है, क्या आंसर है उसका? एनीवन
उसका
रिमेम्बर?
था, उसका कुछ H2010 -H2030 कुछ ऐसा है। एच सबस्क्रिप्ट में 20, सबस्क्रिप्ट में 20।
एच सबस्क्रिप्ट में 20, ओके, एच
हाँ,
20
ऑफ के समथिंग, H20 और फिर ब्रैकेट में के, कुछ ऐसा था शायद, माइनस
माइनस
एच। याद है क्या हेत आपको, हेत या गुरु किसी को याद है क्या, क्या ऑप्शन था?
H10s माइनस H20s, ऐसा है क्या?
हाँ हाँ हाँ,
H10s माइनस
10 - 20, हाँ,
H20s,
10
ये
-20 होगा, हाँ।
H10s
के, हाँ,
minus
माइनस 20,
H20s. Okay,
हाँ।
most of the students are also saying the same answer, H10s minus H20s. Okay, so this is the answer for this question.
हम्म।
Okay, now any other question in the aptitude? 4 questions we have done the discussion. This question is open because some students are saying 3 or some students are saying 4. So let's keep it open. Now, any other question anyone remembers?
हाँ, फिर
Front
तो
view, top view?
हाँ, स्पेशल एप्टीट्यूड का था, तो वो तो बना नहीं पाएंगे अभी तो।
Okay, special aptitude का question.
ऐसा हमने सेट वन सेट टू लिया था ना,
हाँ
एएमटी
हाँ,
का, वो एएमटी
AMT5 का।
है ना, तो सेट वन में ऐसा ही क्वेश्चन दिया था, ऑलमोस्ट सेम।
ओके, टॉप
हाँ।
व्यू एंड फ्रंट व्यू।
हाँ।
डायग्राम बना सकते हैं क्या हम, अगर मतलब याद हो तो? जो आंसर है उसका डायग्राम बनाया जा सकता है क्या?
हाँ, थोड़ा बहुत तो खैर बनाया जा सकता है।
कोई बात नहीं, अगर याद आए तो
हाँ।
बताना। नेक्स्ट, उसके बाद में क्वेश्चन नंबर 6 क्या था? 5 questions we have done the
एक
discussion. एक
स्पेशल एप्टीट्यूड का ही था। उसमें था कि टाइल्स मतलब दिए हुए हैं और ये बताना था कि इन टाइल्स का यूज करके कौन सी वो बना सकते हैं। which of the following we cannot make using these tiles?
टाइल्स क्वेश्चन
हाँ
हाँ,
बेसिकली
एक
मतलब
2x2
हाँ
का मैट्रिक्स था और एक था
इसी में,
अ,
इसी
हाँ
क्वेश्चन में।
इसमें, हाँ हाँ वो मतलब टाइल्स अरेंज करके जो शेप बनता है वो एक टू बाई
मतलब
टू
मैट्रिक्स मतलब ऐसे वो उसको ऐसे नहीं मतलब ऐसे
स्क्वायर
बॉक्स बॉक्स।
अच्छा
बॉक्स,
अच्छा
मतलब
अच्छा।
4 बॉक्स।
अच्छा ऐसा ऐसा।
हाँ हाँ इसके चार पार्ट हैं जैसे।
हाँ ऐसा।
हाँ
हाँ ओके।
और
और
एक वर्टिकल बॉक्स था 4x1 का, मतलब 4 बॉक्स का स्टैक था। यस,
हाँ
in which
इन
shape
दो
will be
शेप्स का यूज
possible
करते
after
हैं।
arranging this box in any direction?
ओके फाइनल आंसर याद है क्या?
हाँ, 3x4 था आई गेस, मैट्रिक्स में बनाए तो।
सचिन गुरु
हाँ
याद आ रहा
हाँ
है कुछ? 3x4 मतलब कैसे,
हाँ
3x4 कैसे बनाना
मतलब
है?
जैसे 2x2 बनाया ना ऐसे ही वैसे ही मतलब हाँ 3 रोज।
कितनी, 4 कॉलम या 4 रो?
4 columns and
4
3 rows.
कॉलम्स 3 रोज, ये आंसर है हाँ?
नहीं ये तो बन जाएगा, ये शेप तो बन जाएगा।
I guess
मतलब कौन सा
one
शेप
more
नहीं
column
बनेगा
है।
इनका यूज करके ऐसा कुछ था।
I
इनका
guess
यूज
one
करके
more column होगा।
कौन सा शेप नहीं बनेगा?
नहीं नहीं बनेगा हाँ।
जैसे कि ये शेप कैसे बनेगा अगर मैं बनाना चाहूं तो? जैसे ये क्या, ये 2x2 है,
नहीं
ये
4x4
भी
के
टू
तीन
बाई टू
तीन तीन लग जाएंगे ना हॉरिजेंटल।
हाँ 4x4 के 4 लग जाएंगे, सॉरी।
हॉरिजेंटल 3 लग जाएंगे।
हाँ ऐसे 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 3 लग जाएंगे।
हाँ
हाँ ओके। सचिन ऐसा नहीं कर सकते क्या कि एक ये लगा दिया, एक ये
हाँ
लगा
ये
दिया
भी कर सकते हैं राइट
और एक
राइट।
ऐसे लगा दिया? हाँ
हाँ हाँ हाँ हाँ वो
तो
वो शेप मतलब बन नहीं रही थी कुछ साइज 5, वन ऑफ द डायमेंशन वाज 5 है ना। हाँ अच्छा एक और
थ्री
कॉलम
बाई
ऐड
फाइव
करना।
था आई गेस। यस
थ्री
यस।
बाई फाइव होगा हाँ।
3x5,
हाँ एक
तो
और कॉलम ऐड करना।
मतलब 5 कॉलम करूं?
हाँ 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 ये वाली शेप नहीं बन पाएगी।
5 कॉलम कर दिए,
यस,
ठीक
ये
है।
वाली थी।
ओके दिस इज द आंसर राइट।
हम्म
3x5, हाँ मतलब बेसिकली 3x5। ओके
हम्म
सो ये हम बना नहीं पाएंगे क्योंकि ये वैसे ही, हाँ मतलब अगर हम ये रखते हैं तो ये कहाँ से आए? ओके ओके ठीक ठीक, तो ये सही लग रहा है।
यही था
Okay,
भाई।
so this is the answer, right? 3 by
हाँ
5 or 5 by 3, whatever. Okay. Basically, the answer will be the 3 by 5 shape or the 5 by 3 shape. Okay. Both are basically same. If you normally we first we consider the row. Okay. Usually first we consider the row. So this is fine. Okay. 3 by 5. This will be the answer for this particular question. Okay. सो
हम्म
दिस वाज क्वेश्चन नंबर 6। नाउ व्हाट वाज द क्वेश्चन नंबर 7? एक एप्टीट्यूड के अंदर भी कोई प्रोबेबिलिटी का क्वेश्चन था क्या?
सर एक लॉजिक का था, प्रोपोजिशनल लॉजिक का, कि इफ
किसमें,
टीचर्स कम।
एप्टीट्यूड में?
हाँ,
हाँ
एप्टीट्यूड। और इफ टीचर्स कम्स देन स्टूडेंट विल स्टैंड एंड ऑल स्टूडेंट्स विल स्टैंड इन साइलेंस, ऐसा कुछ था। रफली बता रहा हूँ।
हम्म
इफ टीचर कम्स देन ऑल स्टूडेंट्स विल स्टैंड एंड स्टे साइलेंट, ऐसा कुछ था
हम्म
सिमिलर। तो एक गलत था, एक ही गलत था। पूछा था कि कौन सा नेसेसरीली ट्रू नहीं है।
देन ऑल
एंड
स्टूडेंट स्टैंड
साइलेंट।
साइलेंटली,
हाँ
हाँ
साइलेंट।
ये तो दिया हुआ स्टेटमेंट था, ये तो गिवन स्टेटमेंट था।
तो
हाँ,
इसका
एक गिवन।
आंसर था कि विच ऑफ द फॉलोइंग इज नॉट करेक्ट। तो नॉट करेक्ट में आंसर था कि इफ स्टूडेंट्स आर स्टैंडिंग साइलेंटली है ना देन इट मींस टीचर हैज कम।
ओके कॉन्वर्स दे दिया मतलब।
हाँ
ओके ओके सो बेसिकली नॉट इक्वलेंट पूछा था।
हाँ मतलब नॉट करेक्ट
आई
किससे
थिंक
क्या।
मेरे ख्याल से अगर इसको पी और क्यू बोलूं तो जो ऑप्शंस थे वो शायद कुछ इस तरह के रहे होंगे कि ऑप्शन ए रहा होगा नेगेटिव क्यू, ऐसा कुछ रहा है क्या?
हाँ मतलब बेसिकली इसको पहले तो दो दो पार्ट्स में तोड़ दिया था। इफ स्टूडेंट्स कम्स इफ टीचर कम्स देन ऑल स्टूडेंट्स स्टैंड, ये एक ऑप्शन था। इफ टीचर कम्स और देन ऑल स्टूडेंट स्टैंड।
क्वेश्चन में पूछा था कि नॉट इक्वलेंट, हाँ।
हाँ मतलब क्या क्या इन्फर नहीं कर सकते।
ओके ओके कांट इन्फर,
हाँ
व्हाट वी कांट इन्फर, ठीक है। फिर इसमें जो करेक्ट आंसर है वो बता देना बस।
हाँ करेक्ट आंसर यही था कि इफ स्टूडेंट्स आर स्टैंडिंग स्टैंडिंग देन इट मींस टीचर हैज कम।
ओके इफ क्यू देन पी, मतलब ओके ये देन ये,
हम्म
ठीक है। सो दिस इज द आंसर, रिमेंबर this we cannot infer because this is actually the converse of the given statement, and the given conditional statement may not be equivalent to the converse. Okay, so this converse, of course, we cannot infer. Okay, so this was question number 7. Was there any probability question in the
Yes, sir.
aptitude?
Yes, sir.
Okay, tell me what is the question then.
Two dice are thrown, unbiased dice are thrown. So 1 to 6 are the numbers on the dice. Then
Two
what is the
dice,
yes,
two dice thrown. Okay, and these dice have 1 to 6.
yes.
हाँ, फिर
What is the probability that the second number is the integer multiple of first number?
probability that second number, मतलब second dice number, right?
The second dice number.
Two dice are thrown one time.
Yes.
Okay, second dice number is
Integer multiple of first dice number.
integer multiple of first dice number. Okay, ठीक है. So what was the answer for this one?
7 by 18 was the answer, I think.
Yes.
7 by 18.
Uh,
This is the final answer. Okay. So these are the 8 questions we have done. 7 by 18 is the answer for this particular question. Any other question? Question number 9 and question number 10. In the chat also we can see if someone has told any question. So okay, next. Any other question did we skip? Did we miss? कोई और क्वेश्चन याद आ रहा है क्या? 2 ही क्वेश्चन बचे हैं बस एप्टीट्यूड के, जल्दी से बता दो. कॉम्बिनेटोरिक्स स्टेटमेंट क्वेश्चन, ऐसा कोई क्वेश्चन था क्या कॉम्बिनेटोरिक्स में? कुछ स्टेटमेंट क्वेश्चन
हाँ, एक था तो काफी बड़ा सा था
किसमें? एप्टीट्यूड में?
एप्टीट्यूड में। हाँ
कॉम्बिनेटोरिक्स का बड़ा सा क्वेश्चन.
हाँ, मतलब कुछ स्टेटमेंट बेस्ड था। एक सेकंड तो
इन्होंने क्या किया है कि मतलब पूरी जो डिस्क्रीट मैथ्स है वो एप्टीट्यूड में दिए क्या इन्होंने? प्रोबेबिलिटी का
कॉम्प्रिहेंशन
क्वेश्चन
वाला था।
एप्टीट्यूड में, कॉम्बिनेटोरिक प्रोपोजिशनल लॉजिक का क्वेश्चन एप्टीट्यूड में, कॉम्बिनेटोरिक्स एप्टीट्यूड में. एक बार सचिन याद है
हाँ
ऑल इंडिया मॉक टेस्ट 1 में, एआईएमटी 1 में हमने एप्टीट्यूड के अंदर जो क्वेश्चन डाले थे वो इसी तरह के मैथमेटिकल क्वेश्चन डाले थे. तो
हाँ
कुछ स्टूडेंट्स ने फीडबैक भी दिया था कि एप्टीट्यूड में एप्टीट्यूड जैसे क्वेश्चन डालो.
हाँ।
और ये सेट 1 के अंदर आज जितने भी क्वेश्चन देख, मतलब वॉट एवर क्वेश्चन वी आर सीइंग, मोस्ट ऑफ देम आर बेसिकली मैथमेटिकल क्वेश्चंस.
मैथमेटिकल।
दीज आर बेसिकली डिस्क्रीट मैथमेटिक्स और इंजीनियरिंग मैथमेटिक्स क्वेश्चन विच आर प्रेजेंट इन द एप्टीट्यूड. ओके,
राइट।
तो मेरे ख्याल से वो जो ऑल इंडिया मॉक टेस्ट 1 में जो फीडबैक मिला था कि अरे एप्टीट्यूड में एप्टीट्यूड जैसे क्वेश्चन डालो, तो तो now you can see, those students can see, I'm not blaming you, okay, nothing, okay, I'm not saying anything, I'm just telling you that see in set 1 also the same thing has happened. So anything can happen, you must be ready for everything. Okay, I think that in any all India mock test, if we put, let's assume all the questions from relational model, Sachin, in the
हाँ
DBMS, let's assume we put, just assume, we don't put any question from transaction management, no question from SQL, no question from indexing, no question from ER model. We just put the question from relation model and relation algebra. 5 questions if we put, then a lot of criticism will happen.
राइट।
है ना? But you can see in this set 1, it was disbalanced. Okay, the theory of computation was disbalanced, the DBMS was disbalanced, algorithm was disbalanced. Okay, so any other question? So total 8 questions we have done the discussion. Credit question was there? Anyone remember credit question, Sachin?
क्या था यार क्रेडिट क्वेश्चन?
Yes, sir. I have written in the chat.
Okay, you have written in the chat. Okay, okay, nice. So this question you are saying, a student has to take credit from project. Acha, okay, okay. Let me take this screenshot.
अच्छा हाँ हाँ हाँ।
Okay, let me put this as it is. Let me put.
I think aptitude was like I can say easiest aptitude in last 5 6 years. Aptitude was extremely easy.
Okay, this is the question here. So what is the answer?
Yes, sir.
What was the answer?
25 is the answer.
Okay, for this question, the answer will be 25. Okay, very good. Okay, only one question is remaining. I think that is that combinatorics question. I think that long combinatorics question.
Right.
Do you remember that question? Anyone remembers that question? Maybe you can just give me the answer. If you don't want to if you don't remember the complete question. Combinatorics with probability of physical values, ऐसा कुछ क्वेश्चन था, याद आ रहा है? Combinatorics with probability of physical values. गुरु हेत याद आया कुछ? ऐसा कुछ था क्या? So what is the answer for this, Guru? This
Sir,
type
I
of
think
question.
one
Yes.
statement was not correct. वहाँ पूछा था कि combinatorics is always uh, we can use it to model physical formulas or quantities, ऐसा कुछ था, but ऐसा लिखा था, it is always used combinatorics, but
Okay.
that was not the answer.
तो आंसर अच्छा आंसर मतलब आंसर क्या है?
एक मतलब दो स्टेटमेंट दे रखे थे, एक ट्रू था और एक फॉल्स था.
हाँ हाँ.
अब
ओके.
जो अंदर दे रखा था मतलब आंसर एक मतलब फॉल्स वो था कि combinatorics is always used to model the physical quantities or formulas, ऐसा कुछ था. वो always word यूज हुआ था, so definitely it is not correct option statement. And दूसरा एक statement था कि like I am not able to recall that second statement, but it was true.
Can I say that this is the answer? This is the final answer. Can I say that the first statement was false and second statement was true, Guru? This is what you are saying, right? That the first statement was false and second was true.
So I also marked this one. S1 false, S2 true.
Okay, okay. So in the chat also, most of the students are saying that S1 was false, S2 was true, and the same thing Guru and Het is also saying. So, okay, so this is the answer for the 10th question. So we have done the discussion of aptitude 10 questions. This question, the answer we have seen, this question answer seen, answer we have seen. Okay, for this question, this is the answer. Okay, for this question, I think answer is missing. If anyone can describe the photo for the answer, maybe we can write it here. Anyone? Do you remember, Het, Guru? Do you remember like what was the photo for the answer?
एक रेक्टेंगल बॉक्स बनाना. रेक्टेंगल मतलब
एक रेक्टेंगल
हाँ.
बॉक्स. ओके,
हाँ.
ठीक है.
मतलब सॉरी, स्क्वायर स्क्वायर आई मीन स्क्वायर.
स्क्वायर स्क्वायर.
हाँ.
ओके, स्क्वायर बॉक्स, ठीक है.
अब इसमें मतलब इसमें एक सबसे लेफ्ट में मतलब एक हाँ, ये वर्टिकल बार खींचना है. एल बनाना है मतलब एल. हाँ हाँ हाँ, यहीं पे. हाँ सही है, सही, ये लाइन सही थी. हाँ, यहाँ पे एक एल एल राइट साइड में. इसको राइट, नहीं नहीं ऐसे नहीं, राइट साइड में.
ऐसा, ऐसे.
हाँ.
ओके
हाँ
ओके ओके,
और
ठीक है. ठीक है, ऐसे. हाँ,
हाँ और ऊपर जो एल एल बनाया ना, इसके लेफ्ट में जाना है एक बार.
एल
हाँ
बनाया इसके लेफ्ट में
हाँ,
यहाँ.
उसको मतलब
हाँ,
ऊपर से ऐसे एक एक छोटा सा एक और वो बनाना है ऐसे. हॉरिजेंटल एक लाइन की, नहीं नहीं, ये तो इसके नीचे, इसके नीचे, इसके अंदर ही होगा जो होगा.
अच्छा अच्छा, एक सेकेंड.
हाँ, बस एक हॉरिजेंटल लाइन खींचनी है. एक लाइन छोटी सी, छोटी सी. हाँ ये.
ऐसे
हाँ हाँ, ऐसी ही एक लाइन वर्टिकल खींचनी
टच
है.
करनी है इसके.
हाँ,
टच कर
टच
दूं.
करनी, हाँ.
हाँ,
ऐसी एक लाइन वर्टिकल खींचनी है एल के मतलब एंड में. एल
एल
बनाए.
के
हाँ
एंड में
हाँ
यहाँ.
हाँ हाँ
हाँ,
हाँ.
ओके.
हाँ, ऐसा ही कुछ मतलब शेप आंसर था कुछ.
ऐसा ही कुछ था क्या हेत? गुरु गुरु इज सेइंग बाय द वे, ये टॉप व्यू फ्रंट व्यू वाले क्वेश्चन में ऑप्शन वर नॉट इन ऑर्डर. ऑप्शन वर नॉट इन ऑर्डर, इसका
और
क्या मतलब है?
मतलब जो तीन फिगर दे रखे, फोर फिगर्स दे रखी थी ना, 1 2 3 4, तो मेरे में दिखा रहा था कि थर्ड पहले था, सेकंड पहले था, मतलब 1 2 3 4 में नहीं दे रखा था. दैट इज आई एम टेलिंग कि पहले थर्ड था, टू था, वन था, इसलिए कि ऑप्शंस वर नॉट इन ऑर्डर.
ऑप्शन तो सफल होते हैं ना, उसमें क्या दिक्कत है?
मतलब यूजुअली ABCD होता है ना,
अच्छा.
सो
अच्छा, यूजुअली एबीसीडी होता है, आपको एबीसीडी नहीं दिख रहा था ऐसा?
हाँ, मेरे में नहीं दिख रहा था वो। आई थिंक
ओ,
मुझे पता नहीं, बट यस, मैंने नोटिस तो किया था कि इट वाज नॉट इन ऑर्डर।
अच्छा अच्छा, ओके ओके, ठीक है। ऐसा ही कुछ, मतलब आंसर बेसिकली ऐसा ही डायग्राम, ऐसा कुछ था क्या, इस तरह का डायग्राम? ठीक है,
हाँ हाँ, आंसर तो ऐसे कुछ था।
ओके, चलो ठीक। ऑप्शंस आर बेसिकली सफल्ड, बट it might be very odd if like you were not able to see option A, B, C, D like that. Okay, so but yes, I think students are also saying that this type of diagram was there. Okay, so that's it. We have done the discussion of aptitude questions. There were 10 aptitude question. We have seen the answer of all these aptitude question.
So actually, I've sent one diagram in chat.
अच्छा, चैट में भेजा है क्या?
हाँ मतलब ये क्वेश्चन तो हमने एएमटी में दिया था, सेट सेट वन में, एएमटी
ओह
5 सेट वन,
नाइस। सो
है ना? ऑलमोस्ट
यस
सेम
यस,
क्वेश्चन आया था। हाँ
एक सेकेंड, सच में
हाँ हाँ,
this question was present in our
एएमटी 5।
AIMT. Okay, let me just put it. See, see, we are putting one question that we have given in the AIMT. This was the question in Go classes AIMT.
एएमटी 5
AIMT 5.
सेट वन।
Okay. So you can see on your screen, this question was present. You can see almost identical, right? It is looking very identical.
हाँ
Okay,
काफी
so
सिमिलर सा था।
this was in our All India Mock Test 5. Set
वन।
set 1. Okay, for GATE CS 2026. Okay. So in our test series, in our mock test, in our All India mock test, this question, you can see this question was present, and similar question has come in GATE 2026 set 1. Okay. So that's it. कोई और क्वेश्चन बचे हैं क्या? कुछ क्वेश्चन शायद, पता नहीं, टेक्निकल में तो मुझे कोई याद नहीं है कि कोई क्वेश्चन बच गया हो। वो मल्टीप्लिसिटी वाला क्वेश्चन सचिन, वो भी, उसका भी आंसर स्लाइड के अंदर लिख दिया है, वो जो आइगन वैल्यू का एक था एक,
ओके ओके।
और एक प्रोबेबिलिटी का क्वेश्चन था बॉल्स वाला, टू टू
हाँ
बॉल्स, वो भी आंसर लिख दिया है। ठीक है, और कोई क्वेश्चन तो याद नहीं आ रहा मुझे। एक बीएसटी वाला भी प्रेजेंट था मॉक मॉक टेस्ट में। अच्छा, ओके, मॉक टेस्ट में सारे 65 क्वेश्चन कर दिए क्या हमने, या फिर कुछ बच गया,
नहीं नहीं,
मतलब कुछ
लेकिन
याद ही नहीं
बचे
आ
हुए
रहा।
हैं। हाँ बचे होंगे क्वेश्चंस तो।
लेकिन याद नहीं आ रहा कोई क्वेश्चन,
हम्म।
मतलब ऐसा कोई क्वेश्चन मुझे याद ही नहीं आ रहा कि कोई क्वेश्चन हमने भूल गए हैं अपन। ठीक है, अगर कोई याद आएगा तो
हाँ वो तो कोई दिक्कत
वी
नहीं
विल
है।
प्रोवाइड यू दैट ऑल्सो। ओके। कैलकुलस में एक मैक्सिमम मिनिमा का भी क्वेश्चन था,
हाँ राइट राइट।
उसका किसी को आंसर याद है क्या? एक एमएसक्यू क्वेश्चन था कैलकुलस में,
हाँ
उसका आंसर लिख देते हैं।
हाँ मैं बताता
सो
हूँ।
एक कैलकुलस का क्वेश्चन था, लेट्स राइट द आंसर फॉर दैट।
ये
हम्म।
सर वो क्वेश्चन याद है मुझे, वो फंक्शन।
याद है क्या?
हाँ मुझे भी याद है वो तो।
बताओ, एक कैलकुलस का क्वेश्चन,
एफ
मैक्सिमम
एक्स इक्वल
मिनिमा,
टू, एफ एक्स इक्वल
मैक्सिमम,
टू
एक सेकंड, मैक्सिमम मिनिमा क्वेश्चन, एफ एक्स
इक्वल टू
इज
मॉड एक्स बाई टू
मोड एक्स बाई टू
माइनस एक्स,
माइनस एक्स,
हाँ ये एक ब्रैकेट में, एंड दूसरे ब्रैकेट में एक्स माइनस मॉड एक्स बाई टू, मतलब इसका उल्टा,
प्लस करना है
मल्टीप्लिकेशन।
क्या?
नहीं नहीं, मल्टीप्लिकेशन में ही। इस,
मल्टीप्लीकेशन में क्या करना है?
हाँ, इसका उल्टा मतलब एक्स माइनस मॉड एक्स बाई टू।
ओह ओके
हाँ
ओके, फिर
तो
ये
चार
एमएसक्यू
ऑप्शन।
क्वेश्चन था। हाँ,
हाँ सो वन ऑप्शन इज लोकल, एफ हैज लोकल मिनिमा, लोकल मैक्सिमा, f dash is not differentiable at x equal to 0, f dash is continuous at x equal to 0,
एफ डैश,
is not differentiable at x equal to 0, and f dash is continuous, it's continuous at x equal to 0.
एफ डैश, हाँ,
हाँ f dash,
एफ डैश इज कंटिन्यूअस।
हाँ एट एक्स इक्वल टू 0।
एट एक्स इक्वल टू 0।
तो
ओके
ए और डी आंसर इसका।
ओके ओके। सो इसका आंसर हो जाएगा ए और
डी।
ऑप्शन ए, ऑप्शन डी। दीज आर द आंसर्स। Okay, so this is the calculus question. How many of you did it correct?
हाँ, सी प्रोग्रामिंग का वो हो गया, आई इक्वल टू 9 वाला वो आंसर बता दिया था। आई थिंक नाउ वी हैव कवर्ड ऑलमोस्ट ऑल द क्वेश्चंस।
एक स्टूडेंट की कुछ कमेंट है, अभी आया हूँ चैनल से, किसी दूसरे चैनल से फुल टारगेट करा है गो क्लासेस को। मेरे पॉइंट ऑफ व्यू से तो पूरा गो क्लासेस जैसी टेस्ट सीरीज आया था पेपर। क्या टारगेट किया गया है? आदित्य, कैन यू इलेबोरेट, लेट अस नो। हम तो जब से सेट वन खत्म हुआ तब से इसी सेशन के अंदर हैं। ओके सो हाँ, कोई सचिन क्या
नहीं नहीं, कुछ नहीं।
इसके अलावा क्या कुछ अभी क्या बोल
हो
रहे थे?
गए आई थिंक। नहीं नहीं, मैं ये बोल रहा था कि आई थिंक सारे हो गए अब तो।
ओके ओके। एक डीएफएस का कोई क्वेश्चन है क्या, था क्या,
हाँ, डीएफएस का था यार एक क्वेश्चन, अच्छा क्वेश्चन था वो।
याद है क्या?
हाँ याद है, मैं बताता हूँ। तो डीएफएस में डिस्कवरी टाइम और फिनिश टाइम डैग दिया हुआ था, डायरेक्टेड असाइक्लिक ग्राफ।
एक
एंड
डेक ग्राफ दिया हुआ था पूरा?
हाँ, नहीं नहीं, मतलब ऐसे बोला था कि गिवन डायरेक्टेड असाइक्लिक ग्राफ
ओके।
वेयर यूबी इज एन एज।
जी इज बेसिकली अ डायरेक्टेड एसाइक्लिक ग्राफ डैग।
हाँ, एंड
हाँ हाँ।
यूबी एक एज दी हुई है, डायरेक्टेड एज।
एंड यूवी जो है वो डायरेक्टेड एज है।
हाँ,
हाँ।
तो
फिर
विच ऑफ द फॉलोइंग आर पॉसिबल ऑफ इन टर्म्स ऑफ द डिस्कवरी टाइम एंड फिनिश टाइम, ठीक है।
ये यूवी एज दी है और फिर क्या पूछा है?
मतलब विच ऑफ द फॉलोइंग आर पॉसिबल, ऐसे पूछा है।
विच इज पॉसिबल।
हाँ।
ओके, और ऑप्शंस में
एक
एमसीक्यू था
ऑप्शन
एमएसक्यू था?
है एमएसक्यू, एमएसक्यू।
सारे क्वेश्चन एमएसक्यू रखे हैं। ओके सो व्हाट वाज द ऑप्शन?
वन ऑफ द ऑप्शन वाज कि डी यू,
डी,
डी यू इज लेस देन डी वी। डी,
डिस्कवरी टाइम।
डी, हाँ डी स्मॉल में लिख देना।
अच्छा
डी,
डी, ओके ओके।
हाँ,
हाँ
डी यू इज लेस देन डी वी।
हाँ ओके।
लेस देन उसी में लेस देन एफ यू, लेस देन एफ बी।
ओके ओके।
हाँ, नॉट
ठीक
पॉसिबल
है।
था शायद, विच ऑफ द फॉलोइंग नॉट पॉसिबल।
ओके ओके। विच ऑफ द फॉलोइंग इज, विच
नॉट।
इज नॉट पॉसिबल।
तो ये हमने उसमें पैरेंथेसिस थ्योरम, आप लोगों ने गुरु और हेत आपने पैरेंथेसिस थ्योरम से किया था ये क्वेश्चन।
यस सर, जो लेक्चर में आपने वो ट्री बना के करते थे ना आप, और जो ट्री एज क्रॉस एज और वो सबका दिखा
ओके
था ना
ओके।
पूरा।
हाँ
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 वैसे।
हाँ हाँ हाँ। ओके ओके। एक ही हो गया, और दूसरा था डी, डी, डी वी। सबसे पहले डी वी, डी वी के बाद एफ बी, डी वी एफ बी, डी वी लेस देन एफ बी,
अच्छा एक सेकंड, ऑप्शन बी में क्या है?
डी वी
हाँ
लेस देन एफ बी,
हाँ।
लेस देन डी यू, लेस देन एफ यू,
लेस देन डी यू, लेस देन
एफ यू।
एफ यू।
एक और क्या था, मतलब डी वी डिस्कवर पहले हुआ है, ठीक है।
ये दो ऑप्शन थे, और भी
हाँ, और दो और ऑप्शंस थे।
कुछ
डी,
क्रॉस एज की कंडीशन, ट्री एज की कंडीशन, क्या कुछ ऐसा है क्या? ट्री एज क्या है? हेत इज सेइंग द ऑप्शंस इन द चैट। सचिन एक बार देख लो।
हाँ हाँ, वो मैंने देख लिया। वो
हाँ,
कंडीशन क्या था, मतलब वो तो मतलब पर्सपेक्टिव है, उसने दूसरे उससे किया है, मतलब मेथड से।
अच्छा।
और दो ऑप्शन और थे, एक सेकंड। एक तो जैसे ए वाला तो सीधा सीधा गलत है, दूसरा बी वाला, वी एक्सप्लोर होने के बाद, हाँ ये सही है। एक है कि यू एक्सप्लोर हो गया, वो मान लो।
इसमें ऑप्शंस कौन कौन से करेक्ट थे, मतलब वो वाले बस ये लिख
डी
देते
यू,
हैं।
डी यू एक सी ऑप्शन में लिखना, डी यू इज लेस देन, डी यू इज लेस देन एफ यू,
हम्म।
लेस देन डी, डी वी लेस देन एफ वी।
एक बार सचिन देखना,
हाँ
हेत ने कुछ भेजा है।
डी यू लेस देन डी वी, ये वाला ऑप्शन को लिख लिया हमने, डी वी लेस देन टी यू, ये नहीं लिखा ना बीच वाला, हाँ।
कौन सा लिखना है?
हाँ, डी यू लेस देन डी वी
डी यू लेस देन डी वी
लेस देन एफ यू
लेस देन एफ यू
लेस देन एफ बी।
लेस देन एफ वी। ओके, ठीक है। ओके, तो
हाँ,
फाइनली आंसर क्या है?
नॉट पॉसिबल में आंसर ए है एक तो।
अच्छा, आंसर एक तो ए है।
हाँ, नॉट पॉसिबल में, और बी तो, ये बी तो सही है, और यू और बी, सी है, सी। यार एक और
ओके,
अलग ऑप्शन था, कुछ अच्छा ऑप्शन था वो, पता नहीं।
ये याद है कि टू ऑप्शन करेक्ट थे, टू रॉन्ग
हाँ
थे,
हाँ
ऐसा कुछ याद
हाँ,
है?
टू करेक्ट थे, टू नहीं थे, ये तो
ठीक है,
कंफर्म।
ये ओके, ये पक्का है कि टू गलत और टू सही, टू रॉन्ग
हाँ
टू करेक्ट। ओके,
हाँ
तो
हाँ
अब इसमें जो ये जो गलत आंसर्स हैं,
हाँ
सॉरी मतलब जो नॉट पॉसिबल के अंदर ये जो है, ये दो तो पक्का है ना, बाकी चलो कोई बात नहीं।
हाँ। नहीं मतलब जैसे अगर ये सेम टू सेम एग्जैक्ट क्वेश्चन होता तो ए और सी आंसर्स तो हैं, मतलब इसमें, मतलब फॉर एग्जांपल कि अगर ये क्वेश्चन होता, मतलब ये इसमें ए और सी ही है, मतलब इसमें कुछ वो नहीं है, कुछ गलत नहीं है, बाई चांस मतलब हो सकता है कि ऑप्शन ए का इधर उधर हो।
ओके,
ठीक है, कोई दिक्कत नहीं है।
ठीक है, तो फॉर दिस क्वेश्चन द आंसर इज ए कोमा सी।
हाँ,
यस, ए
टू ऑप्शन
गुरु इज
है।
सेइंग, गुरु इज सेइंग डीवी लेस देन डी यू एक ऐसा ऑप्शन में था, एक ऑप्शन में ये ऑर्डर था डी डीवी लेस देन डी यू। ठीक
सर
है।
लास्ट ऑप्शन में यू एन वी इंटरचेंज कर।
अच्छा, यू एंड वी को बस थोड़ा चेंज कर देते हैं। ओके ओके
ओके,
ओके।
तो
सो ये वी और ये यू। ठीक है,
हाँ, वी डिस्कवर हुआ, उसके बाद यू डिस्कवर, हाँ वो तो फिर नॉट पॉसिबल में आ जाएगा ना।
मतलब अगर ये होगा तो नॉट, तो फिर ये भी आंसर
हाँ,
होगा
फिर तो
ऐसा?
ये भी आंसर हो जाएगा, हाँ।
तो फिर ये नहीं होगा ना?
फिर या तो फिर सी नहीं होगा।
मतलब ये
मतलब
सी
अगर,
गलत है?
हाँ, कोई, हाँ, या तो फिर हमने सी सी कुछ पॉसिबल ऑप्शन वाला होगा, तो टोटल टू बार ओनली करेक्ट, क्योंकि डी, फिर तो अगर डी, अगर ये ऑप्शन है तो डी भी करेक्ट हो जाएगा वरना।
एक काम करते हैं सचिन,
हाँ,
ये तो
डी को तो
ये
मार्क कर देते हैं, हाँ।
ये तो नॉट पॉसिबल है ना।
हाँ,
अब सी में ऐसे अपनी तरफ से कुछ भी ऐसे बता
कुछ
दे जो पॉसिबल हो।
पॉसिबल, हाँ पॉसिबल का कर देते हैं सी। यू के बाद ये एफ यू बीच में से एक बार हटाना।
एक स्टूडेंट ने बोला है एफ यू डी यू एफ वी डी वी, तो ऐसा करूं क्या? एफ यू डी
नहीं
यू।
नहीं, डी से चालू हो रहे थे सारे।
अच्छा, सारे डी से चालू हो रहे थे, ओके
हाँ,
ओके, ठीक है।
ये सी ऑप्शन में से एफ यू को सबसे लास्ट में पहुंचा देना बस।
एफ यू और एफ वी को पहले ले आऊं?
नहीं नहीं नहीं, सब सही है, सब सही है, मतलब हाँ, बस एफ यू को सबसे लास्ट में।
हटा दूं यहाँ से?
हाँ, यहाँ से हटा के सबसे लास्ट में बस।
यहाँ पे एफ यू रख दूं? मतलब
नहीं,
तीन ही
एफ
चीजें
वी
हैं।
था, एफ वी था वो, है ना, उसके बाद में एफ यू लेस देन एफ यू।
अच्छा, समझ गया, ओके ओके।
हाँ
ठीक है, ये पॉसिबल है।
हाँ, ये पॉसिबल है।
ऑप्शन सी इज पॉसिबल,
हम्म,
दिस इज ऑल्सो पॉसिबल, बट द क्वेश्चन इज आस्किंग नॉट पॉसिबल
नॉट
एंड द
पॉसिबल,
आंसर विल
हाँ।
बी ऑप्शन ए कोमा डी, दैट्स इट।
हम्म
ओके,
हम्म।
so yeah, let's leave it now. Now, so this was DFS question. Is there any other question we left?
सर वो रिसोर्सेज वाला हो गया, मैक्स नंबर ऑफ रिसोर्सेज फॉर नॉट गेटिंग डेडलॉक।
अरे हाँ, वो नहीं हुआ, उसके तो सिक्स आंसर
हाँ
होगा ना?
हाँ हाँ हाँ,
उसका आंसर क्या होगा? सिक्स होगा ना
सिक्स,
उसका।
हाँ
ओएस में डेडलॉक रिसोर्सेज क्वेश्चन, राइट? डेडलॉक फ्री क्वेश्चन, ऐसा कुछ।
हाँ
डेडलॉक फ्री रिसोर्सेज क्वेश्चन। इसमें मेरे ख्याल से शायद एवरी प्रोसेस नीड्स एट मोस्ट टू रिसोर्सेज, ऐसा कुछ था। पांच प्रोसेस थी, P1 P2 P3 P4 P5, and every process needs at most two resources, instances of a resource, at most two instances of a resource. Okay, and the question was asking that deadlock free for deadlock free execution minimum how many instances we need? So for this question, it was very easy question. The answer will be 6. Okay. So if you have 6 instances of the resource, then there will be deadlock free execution. Okay. So this question also we have done very good, very good. Acha hai. So now I think we are close to the completion. कोई और क्वेश्चन याद आ रहा है या फिर ठीक है, इतना काफी है और हो गए सारे?
हो गया आई थिंक मोस्टली.
So I think we have covered, I think, all the questions. I will have to count how many questions we have covered. I did not count it, but all the aptitude questions we have covered, and I think all the technical questions we have covered in set 1 GATE CS 2026 paper. Okay. कोई LR0 का कोई क्वेश्चन था क्या? कोई कॉन्फ्लिक्ट का, SR कॉन्फ्लिक्ट का ऐसा कोई क्वेश्चन था क्या? नहीं था ना? ओके. एक इमेज भेजी है, देखना गुरु ने. हार्ड वर्जन ऑफ क्वेश्चन वाज प्रेजेंट. एक सेकंड, ये एक ओके. देखो, basically this question we had in our test series, you can see. Okay, let me share it with you. And the diluted, or I can say easy version of this question has come in the GATE exam. You can see. Okay, so the diluted version of this question has already come in the GATE. You can see, you can check, all the set 1 students, you can check that this question was present in Go classes test series, and easy version came in set 1 GATE CS 2026. Okay. Thank you Guru for sharing. Thank you Heth for joining. Thank you Guru for joining. DAG question we have done. Okay, DAG question we have already done. I don't remember any other question. I think we have seen all the questions. Okay, so I think now we can stop this session, Sachin.
Yes. Yeah.
Okay. So I hope you loved this session. In this session, almost all the questions of set 1 of GATE CS 2026 paper we have discussed. For many questions, we have provided you complete analysis. For some questions, we have provided you the answers. I hope you loved this session. Please share it with the GATE aspirants. We will also provide you set 2 discussion that we will do tomorrow. Okay, because already you can see it's 9:30 and ये 3 PM से ये session चल रहा है, तो ये कितना घंटा? 6.5 hours of session, but we have covered all the questions. Okay, I think all the 65 questions we have discussed. So I hope you loved the session. Please press the like button. That's you can do. Okay, and so see you in the next session for set 2. Set 2 discussion we will do tomorrow. Okay. Thank you everyone.
Thank you everyone.